Welcome everyone, this is another Chris course with your host Chris, and today we're going to be coding the very first tower defense game. We'll start by creating a map using a map editor called Tiled. Then we'll import that map into the browser and begin creating enemies which follow a path. We'll learn how to place buildings in a grid-like format and shoot projectiles at enemies, and then we'll completely transform everything by adding in sprites and also adding in a game over UI. For more premium game dev tutorials, be sure to check out chriscourses.com. Otherwise, let's get right on into it. So let's go ahead and get started with map creation. In order to create a map, we're going to need to download the game assets in which we can draw different tiled pieces onto a map. So where would I actually go to get these game assets? Well, if you go to your browser and head over to itch.io, we're going to come across this website. And this website allows you to download tons and tons of assets for your game, usually completely free of charge. So if I head over here on the left-hand sidebar to game assets, and I head on up to a price of free, you're going to see that these are all the free game assets that we can use directly within our game. And the cool thing is, a lot of these are for commercial use. And as you can see, there are just tons and tons of them for us to choose from. So it can get a little overwhelming finding which one do we want to choose for our specific tower defense game. So I went ahead and did this behind the scenes. I actually selected 3 and then compiled them all into my own specific file, which we're going to use directly for this tutorial. But to give you a little bit of background for which ones I chose, they're going to be called, first, the Free RPG Desert Tile Set. This is by the artist craftpix.net. I believe that is a whole company, and these are all the assets they're allowing us to use directly within our game. So with this asset pack, we're going to be using it mainly for the dirt, the paths, and then all the little objects we might be throwing in between, such as cacti, plateaus, etc. So this is one asset pack we're going to use. Another one we're going to use is going to be for our enemies. This is the free 2D orc sprite sheets, also by craftpix.net. And it gives us a few orcs in which we can use within our game. We're really only going to use orc 1, and we're only going to use one animation which is provided to us. It's going to be the walk animation, so our orc can walk from point A to point B. But this is still a great and completely free asset pack in which we can use for our game. The other asset pack we're going to use is called Free Stone Tower Defense Game Art. Who is it by? No other than craftpix.net. A lot of free great game assets from them. So here, we're going to be using these towers as the actual towers in which we use to shoot projectiles at our enemies as they walk across the screen. For this specific tutorial, we're only going to be using this tower right here. We really only want to focus on the basics, because there's really so much that just goes into a tower defense game in the first place. But if you ever want to use any of these other towers, or at least learn how to use them, I will be doing premium tutorials on this over at chriscourses.com. But this is just another really great asset pack in which we can use for our game. So let's say that I wanted to download these asset packs directly from these pages. I would just hit download now. And it's going to ask for some sort of donation, and I do recommend donating to these authors because they put a lot of work into these assets. You don't have to though. If you don't want to donate, you can just hit no thanks, just take me to the downloads. And then hit the download button right here to begin your download. So I already have this downloaded, and I don't really recommend downloading this unless you want to use those additional assets which are not provided directly within this tutorial. But for this tutorial specifically, I created my own tile set, which is basically a combination of these 3 asset packs to make our lives a little bit easier when we go about creating our map and developing this in the first place. So if we want to go ahead and get that combined tile set, there will be a link in the description of this video for downloading that. It's going to be a Google Drive link, and over here you'll see that there is a tileset.png file. We want to right click this, and then hit download, and then find a place to save this in. So I'm just going to go ahead and save this directly with my downloads folder. I think that's fine. I'll call it tileset.png. It's going to go ahead and download that file. So let's go ahead and take a look at it. You'll see within my finder, we have tileset.png. If I open this, this is what the tile set consists of. It's just a simple PNG that contains a combination of assets from those 3 asset packs I just mentioned. Pretty much everything up here, this is all from the desert asset pack. This is obviously the orc asset pack, and this is the tower asset pack. This is everything we need combined into one specific file. But why is everything combined into one specific file? Well, everything right here is organized in a very specific manner. Everything is arranged into tiles of 64 by 64 pixels. This right here represents one tile. This right here represents one tile. And then over here with these bigger objects that consist of many of these 64 by 64 tiles. So this one rock right here consists of 4 of these tiles. Basically everything within this file right here was sized correctly so that it fits this grid-like format with all these different tiles. And what this is going to allow us to do is select one of these specific tiles, stamp it onto our map, and then continue onwards with one of the other tiles that we have available to us. A tile set is basically just an image we can chop up into perfect segments and then use those segments to rapidly create a map for our game. So this is really going to be the only file we use for our map. We can begin using it now. But first, let's head on over to Do and check off Game Assets and Downloads. So the very first thing we're going to use this tile set for is creating a path. But what program do we even use to create a path in the first place? Well, the program we're going to use is called Tiled. So if I wanted to find this program, I would head on over to the website, mapeditor.org. And when you go here, you're going to be redirected to the Tiled homepage. So you'll see right here, this background image is what Tiled looks like. Basically, we're going to be given this grid-like area in which we can stamp on tiles to create a really detailed map like we can see in the background right there. So to download Tiled, we'll hit download on itch.io. It's going to redirect us over here. We want to scroll on down, hit download now. You don't need to donate anything here. We can just hit no thanks, take me to the downloads. And then we want to install for the specific operating system we're using. So me specifically, I'm using Mac OS. I'm going to go ahead and hit download right here and then save that in my downloads folder. So I do already have the save and installed. Just make sure you install it on your own and then double click to open it. When you've double clicked to open it, it should open up on this screen right here, given you've never used Tiled before. So I don't have any open files at the moment, but I do want to create a new file by hitting New Map. So we're going to be creating a new map at what size? Well, I want this to be a fixed map size because I know this isn't going to be some sort of infinite scroller game. It's going to be a simple fixed tower defense. Now the width and the height right here represent how many rows and how many columns of tiles we want to include within our map. Basically, how large should the drawing space be for our tile set? And I know I want this to be 20 by 12 tiles large, and I want our tile size to be 64 by 64 pixels. Because when creating that tile set, that .png image, I made sure that each tile within that image was 64 by 64 pixels. So we make sure our tile size over here has 64 by 64, and we're using a width and a height of 20 by 12, it's going to give us a map dimension of 1280 by 768 pixels. And that is going to fit most computer screen sizes on desktop, so this will be just a desktop game. But if you were to do some sort of mobile game, well, basically you'd make sure your width is smaller than your height, etc. But we're not going to do that right here. We're simply going to focus on desktop to make sure that we have a dimension of 1280 by 768. So once we have these correct, we want to hit OK. And this is what our game map looks like. So we have this whole grid in which we can begin drawing on to create our map. But we do need that tile set imported before we can begin drawing. So to import that tile set, I'm going to hit this button right here, New Tile Set. And then I want to go ahead and locate a source. This is going to be the source of the file. So I hit Browse. We know that we just downloaded tileset.png. So I'm within my downloads folder. I'll hit tileset.png, hit Open. And then what else do I have to do here? I can call this a different name than what we have. I think tileset is totally fine. And then I want to make sure that our tile width and our tile height is 64 by 64, because that is what the tile set was actually created at. Now all I have to do is hit Save As, and determine where I want to save this. So I'm just going to save this directly within Downloads. I'll go ahead and call this tile set as well, because this is going to be a different file type. It's not going to be .png, but rather .tsx. So it'll still allow me to save it without overriding everything. If I hit Save, now you'll see this tile set is opened. So as I mentioned, this file is perfectly segmented into tiles that are 64 by 64 pixels, which when we import into Tiled at that exact ratio, it allows us to select each of these individual objects, which in return will allow us to draw them directly on the tiles within our game map. So if I want to begin using this within our game map, I'd head on over to this tab right here. This is going to be our game map. Currently it's called untitled.tmx. So if I want to begin drawing on this, you'll see our tile set is now open on the right over here. I can simply click a tile and then hover over a map over here and click and drag, and you'll see we're now drawing tiles out onto our game map. And this works for pretty much any segment that we have within our tile set. Let's say I want to draw a rock onto our map. I'd select that rock, and then I can click in different locations to draw that on. I can drag, doesn't really matter where. Whatever I want my map to look like, I can make that happen directly within Tiled really quickly using this tile set technique. Now let's say I wanted to draw on a larger object like this rock. Well, what I need to do is not just draw a corner. I would want to go ahead and select the whole thing by clicking and dragging over the full image. This is going to allow me to select the whole thing, and now this takes up a 2x2 square in which I can just click and draw on that rock. And this is going to work for any of our assets because they are all perfectly laid out in the correct format to fill in these 64x64 sized squares. So how would we actually begin creating a path for our game? Well, this nonsense right here, we'd probably need to get rid of it, so there are two ways in which you can delete tiles that are already drawn on the screen. We could go ahead and click this eraser tool right here, and that's going to allow us to click and drag and delete anything within the layer we currently have selected on top right. Or if we want to be quicker, we could select this rectangle tool right here, click and drag from the top left-hand corner, all the way to the very end, and then just hit delete. It's basically like a little marquee selection tool which allows us to delete anything that we select. So with everything deleted, what would I want to use to begin actually drawing some sort of dirt path? Well, I think this middle segment right here is going to be great for our entire background. So let me go ahead and begin drawing that on. If I want to begin drawing on this little piece right here, I need to make sure that I have our brush/stamp tool selected. So I'll go ahead and grab that. And now I can begin drawing on this by clicking and filling up our whole entire map. Now this is really annoying and kind of tedious to have to do, so there are ways in which we can speed this up using tiled. And the quickest way to do this is by using the paint bucket tool right here. So if I click on the bucket fill tool, it's going to allow me to select areas which have not been filled in. So you'll see right here that blue area on the outskirts is completely being populated. Now I can click, and that is completely filled in. Now if this blue overlay is annoying you, it's because we still have that rectangle selected from using the rectangle tool. We can deselect everything with Command-Shift-A, and now everything looks back to normal, but we can still use the paint bucket tool. If I hover over the empty areas, it's going to fill in, and then once I click, that fill-in takes effect for every empty area in which we have. So this is going to be the background for our game so we can create that really cool map that we want. What would we draw next? Well, we'd want to start using these path options we have over here to create something in which our orcs can walk across. So to begin drawing a path, what I could do is select this middle path piece right here, and then select our brush tool, the stamp tool, and begin drawing on wherever I want our path. We could definitely do this, but I will say this is called destructive editing. Why? Because we are drawing on top of the same layer in which we had our dirt path on. So this might not look apparent right now since we're using two different path pieces, but if I were to use something that has a little bit of transparency for the background, such as this rock right here, watch what happens when I begin drawing on a specific location. Let's say I want to draw right here. I click, and now that tile piece is completely destroyed and replaced with this rock tile piece instead. So if I want to make sure that background piece is always going to be there, I want to make sure that I'm separating these into different layers. So I'm going to hit Command-Z to undo those actions. And right here, I'm going to double click and call this dirt because this is going to be our dirt background right here. I want to right click now and go over to new tile layer to create a new layer. And this is going to allow me to draw on top of that dirt layer without deleting whatever was there previously. So if I click now, you'll see this is drawn on top of it rather than deleting it. Great. That is exactly what we want. And this is also going to be very helpful later on because we can turn layers on and off to see what things look like without our buildings, orcs, etc. So tile layer 2 right here, I'm going to double click and rename this our pathing. And to create a path, I'm going to select this middle tile piece right here, make sure that I have pathing selected, and then I can begin drawing on our path. So how would we go about drawing a path that actually makes sense for a tower defense game? Well, we could draw from left to right to create that path, but that is a little boring. Maybe for an intro level or something like that, that's okay. But I do like a lot of curves within tower defense because it allows us to utilize buildings that have different properties associated with them, different ranges, gives us a full motion in which our enemies can walk as well. So I'm going to start from the left-hand side here. I'm going to go out to the right a bit, and then I'm going to start heading on upwards. Once I head upwards a bit, I think it makes sense for me to go to the right. Once I'm around here, let's start going down. You can draw this however you'd like. I just think this makes sense for my game. I'll start heading to the left, start heading down again. Let's go to the right now. And then I want to go back up and head off the map completely. So this is going to be the complete path in which our orc follows, going to the right, up, right, down, right, all the way till it reaches to the very end. It's unique, it's not just left to right. I like where this is going, but this doesn't actually look that great at the moment. Why? Because we haven't actually finished our path. To finish our paths, we want to use these edge pieces right here available to us within our tile set. So let's go ahead and use this top edge piece right here. If I select that, and hover over the row right above the path we just drew in and begin drawing, you're going to see that this is a perfect connection with the piece beneath it and the piece above it. It creates a really realistic look that makes our game look professional. So basically, to complete our path, anywhere where we need to put a top piece, so anything that is on the very top, I'd want to hover one tile above it, click, and then drag all the way to the right side of that top section. And I'm going to do that for every section in which we can put a top piece in. So all the way here on the bottom and here on the right hand side, that is going to fill in the top pieces for our path. So now let's go ahead and do the same thing for the bottom pieces. But before I do it, I want to challenge you to pause the video and try drawing in these bottom pieces yourself. Take a moment and see how you do. Once you think you have that in a good spot, let's go ahead and do it together. So on these bottom pieces right here, I'll click and drag. I know this bottom section right here is empty, so I'll click and drag that bottom section in. Down here, we also have bottom sections, so I'll click and drag all the way to the right, and then click and drag across to the right up here as well. We do have bottom sections right here, so I can go ahead and fill in 1, 2, and that is looking pretty good. Let's do the same thing for the left and right hand sides of our path. I'll click the left section right here, draw in the left hand side of this section, draw on the left-hand side of this section right here, and it's okay if this doesn't look perfect at the moment. We're going to fix it. And then we have one more left section. We'll fill that in. And finally, we just need to take care of the right-hand side. So we'll select the right piece, and then start drawing in wherever there should be a right piece. So wherever there's an empty column on the right side of our current path, we'll draw that on in. And I think we're going to be good to go with this. All that remains is going to be the corner pieces. So right now, we're trying to draw on side pieces where there should be a corner, but thankfully, the set does include corner pieces. So let's fill in any location in which there's going to be a bottom right corner. I can select this piece right here, and I know a bottom right corner should go right here on the bottom right side of our path. I'll click in, and that fixes that issue. That looks great for a corner piece on the path. This should also have a bottom right corner, and I think those might be the only bottom right hand corner pieces. Actually, looks like I missed some side pieces right here. That's totally okay. I'll add in this bottom right hand corner piece there. And I think that should be good to go. While we're at it, let's go ahead and finish in the sides right here that I missed, and we'll continue onwards with the corner pieces. Let's do any bottom left-hand corner pieces. I'll select this. I know right here, this is a bottom left corner. I'll click to fill that in, and that is going to be the only bottom left-hand corner piece I can see within our map. Let's do the same for the top right-hand corner. That should go right here. That is going to be the only one. Then we have a couple of top left-hand corners. So that's going to go right here on the top left-hand side of our map, right here near the middle, and then right here near the top right. So we took care of all of our outer corners, but why do things still look off? It's because we haven't taken care of all of our inner corners. So inner corners are going to be where path pieces connect. If I were to use a corner piece right here, it would just look completely off. We need to use an inner corner piece instead, which is going to be these 4 tiles on the right-hand side of the one we were just using. So let's start off with this inner corner piece right here. If we use this for this one piece in which we just tried filling in, you're going to see that creates a perfect path for us, and that looks a lot better. Is there any other location in which we go from a top tile piece to a left tile piece? Yes, there is. It's going to be down here. You'll see we go from a top to a left, which means the connection right here is going to use the one we currently have selected. We fill that in and things look good to go. So right here we have a right side tile piece connecting to a bottom side tile piece. If this is the case, we want to make sure that we're using this tile right here. This is going to be our connector from right to top. So for our inner corner, I can go ahead and select that, click, and now that looks really good. Same thing for right here on the right hand side. Let's fill that in. And we are almost done filling out our map. To finish this off, we need some sort of piece that connects a bottom piece to a right piece. And that is going to be the one directly next to the one we are using. Let's go ahead and select this one. It's going to be the top to the right connector. Put it right there. Are there any other locations in which a top piece connects to the right? Doesn't look like it, so I think we're good to go there. But we're not done just yet. We also need a piece in which the right connects to the bottom. It's going to be this top left inner corner piece, so I'll select that, click, And all we need to do here is fill in that little gap so I can grab this side piece right here, click in that empty spot, and that fills it in. So really the only remaining spot is going to be right here, but we can't really use these inner corner pieces to connect anything because we don't have a connecting side piece in which this would actually mesh in well together. What we would need to do is create an extra row right here of space so we could get in one right side piece to create something that looks like this section right here, but with the indent on the left-hand side. So we need to make sure that we extend this by one row. But we just drew all of this out. It would be really annoying to have to do this all over again to make sure that we get this right. So how could we go about expediting this process? Well, if we select the rectangle tool, make sure that we have our pathing selected, what we can do is select the area in which we want to move down. It's going to be everything from right here to the right-hand side, making sure that I have all that path selected. With all of it selected, I can hit Command X. It's going to delete it all, but copy it to the clipboard. Now I can hit Command V and paste in that entire section in the exact location I want. So I just want to move it down by 1. I'm going to go down by 1, click, and now I have that extra area in which I can make sure that our corner pieces work. So first, let's take care of the side pieces. I know I have a missing side piece right here. I'll fill that in. Now I also have a missing middle piece. I'll fill that in as well. And I also need a side piece right here. I'll put that in. But now I just need to make sure that this top side connects to the left side for an inner corner. To do that, I'm going to use the bottom right-hand inner corner. Click in that location, and now that connects perfectly. I want to do the same thing for this bottom section right here. So I'll grab this top right-hand inner corner piece. Click. And now that is looking really, really good. Now I just need to fill in this row right here. And to do that, I can select the rectangle tool, select the row above it, hit Command C, hit Command V to paste, and now I have all that selected and can just click to fill in that entire row. So I think this is looking really good for the start of a path, but what would I take into consideration here to make sure that our game is the best as possible? Well, where can our tower actually fit within our map right here? If I scroll on down within our tile set to the very bottom left-hand corner, you're going to see that we have our tower as a tile in which we can place within our map. So I'm going to click and drag so I can select the whole thing, and you'll see this is where our tower can be placed. So it takes up 2 columns worth of space, but when we pull this into our game, it's actually only going to take up 1 row. So you'll see our tower has no problem fitting over here in this section, has no problem fitting over here. We do not want to draw our tower onto the map. That is where our orcs are going to be running across. Our game would not make sense if that's the case. We're only going to allow ourselves to draw the tower within the dirt area. But if I wanted to be able to draw towers right here, I simply would not be able to do it because our tower is overlapping with our path. If that's the case, I would want to make sure that I design our map right here so this little dirt area has 2 columns worth of space so I could actually place a tower in between this section of the path and this section of the path on the right. So if we want to move this whole little section over to the right, we can use our rectangle tool, select that entire section, hit Command X, hit Command V, and now where do I want to place this? Well, I want 1 additional column on the left over there. So I'm going to make sure that column is included, click, and now really all I need to do is fill in that empty column. So I'll also select our rectangle tool, and then select 1 column of pathing, hit Command C, hit Command V, and fill that in. And if we want to test things out, we can scroll back down to the bottom left, select our tower, and now we know that we can actually draw this in between the paths, and I think this is going to look really, really good for when we actually implement it within our game. So this is going to be the absolute step 1, is creating a path directly in tiled in which our orcs can walk across. And as you can see, it looks really good because we have a good tile set and we used good tiling techniques with all the different corners. So with this, we can head back to do and check off create a path. Next, we're going to cover map details. I wanted to cover this to show you guys how to layer objects on top of each other to create a map that looks really good, really realistic, while keeping our game UI in the back of our mind. So let's head on over to tiled. And when I'm talking about game details, I'm just referring to these objects that don't really have too much of an impact on our game. Things such as rocks, things such as cacti, these little rocks, signs, foliage, whatever it might be. We use these to decorate our map, and really we can select one, place it anywhere we would like, and it doesn't really matter. This is mostly up for artistic intent. But there are a few techniques we can use to layer these objects on top of each other to make our game look even better than it would otherwise. So I'm going to go ahead and right click over here to create a new path, and I'm actually going to Control Z everything before I do that. Get rid of those signs, right click over here, hit new tile layer, and these are going to be details 1, because we're going to have multiple detail layers to make sure that we can overlay these objects on top of each other when needed. So let's start really simple. Let's say we want to draw this cactus somewhere on our map. I'm going to draw it in the top left-hand corner. Let's say maybe we want the skull right beneath it. But let's say maybe there is a large cactus beneath the skull. I'm going to select this large cactus by clicking and dragging downwards. And now you'll see if I want to place it right beneath the skull, that looks pretty cool. It's overlaid on top of the skull. But if I click, the skull is gone completely. Why is that? Well, it is because we are using the same details layer that the skull was on. So if we're taking up this little space right here where the skull is, it's just going to delete completely, and we're no longer going to see it. So whenever we want to layer objects on top of each other, we need to make sure that we have multiple detail layers within our game map. So I'll right click over here to create a new one. This is going to be details 2. So now that I have details 2 here, it should not overwrite the skull. So when I click, now we have that overlaid on top of our skull, and it looks more realistic because now we have a foreground object and a background object interacting with each other. This is the exact view we would see in something like real life. Now sometimes you will have multiple objects layered on top of each other. Let's say this cactus has another one right beneath it. If I click, well, that cactus is now gone. So what we need to do is simply right click, go to new tile layer, and then I'm going to create another one called details 3. So now that's going to allow me, with details 3 selected, to draw on top of that cactus we just created. And you can create as many detail layers as you'd like, it doesn't really matter. But just however many you need to start layering things on top of each other, that's the way you want to go. Now these objects can act as barriers to where you cannot draw buildings for your tower defense. Right now our path is acting as a barrier, as in we cannot draw buildings on this path, or at least that's how we're going to code the game. These objects are going to act as the same way. It does not make sense to be able to just completely remove an object and draw a building on top of it. So these detail objects act as a game function basically to either make our game easier or harder depending on where we place them. So let's say at the very beginning we don't want any buildings to be placed right here on the bottom left hand corner to make our game a little bit harder for this specific map we're creating. I'm going to go ahead and select this rock right here because it's quite large. And then over here I say I don't want any buildings right here. All I have to do is click. And now we're going to say that this one location, buildings can no longer be drawn. Maybe I want the same thing for the 2 tiles beneath it. In this case, I would have to use something smaller, like these rocks up here, so I can either select 1 or 2 of these at the same time, put them on over, and just drop them, and now I can no longer draw there as well. Now, something else I want to take into consideration is our game user interface. So within our game, we're going to have things such as resources, which allow us to actually draw buildings on our map, and we are also going to have hearts. These hearts represent how many lives do we have left before our game is over. And typically those go in the top right-hand corner of a game or the top left-hand corner. For this game, I'm going to put them in the top right-hand corner, and if that's the case, I want to make sure that nothing can be drawn in this top right-hand corner, because it's going to be reserved for those resource and heart values that I want to put in the game. So in this top right-hand corner, let's go ahead and create something that looks a little more realistic than what we have going on right now. So something cool you can do is you can select something like one of these big rocks. I'll go ahead and do that. And let's say I don't really want to include the whole rock, but I only want it partially in the scene to add this cool effect where we know this is a rock, but it is outside of our scene. To do that, I'm just going to move a little bit of it off the stage, and then I'm going to click, and just like that, only a partial part of this whole tile image is showing, which is exactly what I wanted. So let's keep moving onwards. I also want this little lake in there because I think it has some nice contrast with the rest of our map, and I kind of want it near this little alcove of that rock we just placed. So I'm going to move over to the left by 1, click, and now the pond is in our game, looking great. But I do want a little bit of layering as well. I think near the pond it makes sense to add cacti, because that way they have water to grow. So I'm going to go ahead and select this one we have not used yet. And I want this layered on top of our rock and right next to the pond. So if I were to click right now, you'll see that the rock disappears. We can go ahead and fix this in a few ways. One, we could right click and create a new layer. But I think that is a little tedious and it might muddle up our layers a little bit. We don't want too many as long as we don't need them. So what I'm going to do is select this little rectangle tool right here to select it with the dotted line, and then cover the section of the rock and hit Command X to cut it out of its place. So I know this is going to be in the background 100%, and if it's in the background, I want to go over to Details 1, and once I'm within Details 1, I can hit Command V, and then click wherever I want it back in our game. So I'll click, and now when we go to something like Details 2 or Details 3, we select that cactus. It's going to allow us to draw on top of that rock. And I think right next to the oasis, I'll add in this small little cactus as well, just to give it a little bit of visual variety. And I really like how this is looking. So this is going to be reserved for our user interface up here. And really the rest of the map regarding details is up to you. You can select anything you have here to say, hey, I don't want the user to be able to draw buildings in this particular location. I think for me, I'll draw a sign right here to indicate that this is the direction I want the enemies to go. And then I can just sprinkle in a few objects and locations I don't want towers to be drawn. So I'll add a little rock right here. This is going to completely prevent towers from being drawn in this top row where all these rocks are. Let's say I want to add a little bit more visual interest down here on the bottom right hand corner. I'll go ahead and select something like, let's say this rock right here. Place it there. And I could also do things such as start layering objects in the bottom right hand corner. So I know I want a background object behind this rock. I can select details 1, grab something like another rock, place it right there. You'll see that's now in the background. It could also grab something like the skull, place it there as well. Whatever you would like to make your game more interesting is pretty much up to you as an artist to determine where you want to place these objects and still make your game either harder or easier to prevent towers from being drawn. So this puts my map in a really good spot. I'm really happy with how this is looking. If you'd like to see how this looks without the grid, you can hit Command G or Control G for you Windows users to hide that grid and get a full view of your whole map. I'm going to turn the grid back on, and I know I want to save this, so I'll hit Command S, Control S for you Windows users. I'm going to save this directly within my Downloads folder, and I'm going to call this Tower Defense. It's going to save as a TMX file, so I'll save it directly in there. Now I have that saved, as you can see in the top left-hand corner. So this is pretty much all we need to do to get our game started using this map we just created. Our enemies are going to start from the left over here, and follow this whole trail to the very end. We just need to program it now. So let's head back to to-dos and check off map details. Now we're going to move on to our tower defense basics. We're going to actually program this game based off that map we just created. The first thing we need to focus on is going to be project setup. This means creating our new files and then importing and rendering our map into the game. So let's go ahead and do that now. What I'm going to do is open up a new window in Sublime Text. So I know this is a little bare bones for this tutorial, but this is indeed Sublime Text that I have opened, as you can see right here. And with this new file open in Sublime Text, I'm going to go to File, Save. Where do I want to save this new file I'm creating? So this is going to be an index.html file. It's what's going to host our canvas element so that we can actually begin drawing our game onto it and begin playing. So I just need to determine where do I want to host this file. So in particular for me, I like storing all my games within a web folder I created a while back. So I'm going to go inside of there, and you'll see this is just a basic folder with all my games. I want to actually create a new folder for our game. This is going to be our main project folder. So I'll hit New Folder, and save this as Tower-Defense. So now all I need to do is determine what I want to save this file as within the Tower Defense folder we just created. I want to save this as index.html. That is going to be the base file in which we start adding canvas elements to. So I'll go ahead and call it that. And now if I hit save, that file has been created. If I show you the interface right here, you'll see index.html is saved. So this is going to be our main HTML file. If I want to begin creating our game, I can create a simple canvas element. So I'll go ahead and do that now by adding in a simple opening and closing canvas tag. So if I save this, now I can go ahead and open this up within a browser to start viewing it. To open this up within a browser, all we need to do is head on over to Finder, and then find out where we just saved this file. So like I said, I like saving things within a web directory. We call this Tower Defense, and there is index.html. So you can double click this to open it. I'm going to go ahead and open it with a different browser. And this is what our game looks like right now. It's just a white screen. But the thing is, our canvas element is definitely there. How do I know? Well, I can right-click, inspect our element. That's going to open up Chrome DevTools. And now you'll see our canvas element is definitely within the game. We just can't see it because it is transparent. Nothing is being drawn on top of it. But this is step number 1, is just getting a canvas element rendered out in an index.html file. Next, let's make sure that we can see our canvas, because right now it's a little annoying to have to just use DevTools to see what size our canvas is relative to the rest of our browser window. So to style up our canvas, we're going to head back on over to index.html, and what we can do here is we can add in some style tags at the very top of our file. I'll go ahead and add those in, and within these style tags I can begin writing CSS. So I know for our game I want everything within my browser window to have a black background. To do this, we can select our body tag, which basically encapsulates everything within our browser window. We can start writing CSS within this body tag. So I'm going to select a background dash color style and set this equal to black. By doing this with a simple save, heading back on over to our browser and refreshing, you're going to see now our background is black. So you can see over here on the right hand side of this Elements tab, we have a body tag. It takes up the whole width and height of the screen. We just set that to have a background color of black. We can click this, and you can see down here we have a background color of black being applied directly from index.html on line 3. But we still can't see our canvas simply because we need to give this a color as well. Typically, I like giving canvases color by actually drawing color into the canvas itself. And in order to do that, we need to make sure that we connect our JavaScript to our HTML file. So we can start writing JavaScript in one of two ways. The easiest is going to be by creating a script tag at the bottom of our file. So go ahead and add that in, and within the script tag, I can start writing JavaScript that selects this canvas and then draws it in with a white background. So what JavaScript do I want to start creating? Well, I know I want to select this canvas and put it within JavaScript land, is how I like to think of it. So in order to do that, I'm going to create a constant called canvas. And this is going to store the element that we have right here. To grab this, I can get it with document.querySelector. Query selector will allow me to grab any element within my HTML. And I know I just want this simple canvas element. So with a string as an argument, I'll go ahead and grab that canvas element. And then I can console log out canvas to make sure that I'm actually grabbing it. So if I save this, head on over here, refresh, and then open up my console, you'll see we are indeed logging out our canvas element. That code is all working correctly, which is great. But now I need a way to access all of our canvas methods. So methods that will allow us to draw shapes, images, whatever it might be, we want to go ahead and be able to access that API. To do that, I'm going to create another const, and I'm just going to call this C. C in this case stands for context. But context is just really long in this case, and this is one of the few instances in which I recommend using a small variable name rather than a long one, simply because we're going to be using this variable so much that it just gets really annoying to have to type context over and over again, or something like CTX. I just like calling this C, and this is one of the few instances in which I'll actually use something that's shorter rather than more descriptive. So I'm going to call this const C, and I know I want to get our canvas context, that is basically the canvas API. To get that, I can call this canvas element we just grabbed within JavaScript, and then on top of that call, get context. And I just want to say what context do I want to grab. There are a few options we can put here: 2D, WebGL. I know I don't want this to be a 3D WebGL project. I just want to focus on a 2D game. So within this, I'll add a string and say that our context is going to be a 2D context. So we can console log this out to make sure that C is grabbed correctly. I save that, refresh, and this is everything that we can use within Canvas to start drawing shapes out onto our screen. So what shape do I want to draw on the canvas element that's currently right here? Well, I want a rectangle that fills up the full width and height of this canvas element just so I can separate it from our background. To do that, let's delete our console log, call our context of C, and then call a fill rect function on top of this. So fill rect takes 4 arguments. It's going to be an X position, a Y position, a width, and then a height. So where do we want to place this rectangle? Well, for the X position, I want this drawn on the very top left-hand corner of our canvas. If I hover over canvas right here, we know the top left-hand corner is going to be somewhere up here in the top left-hand side of our screen. So to draw up there, our X coordinate is going to be 0, our Y coordinate is also going to be 0, and then I want this to take up the full canvas width and height. We can get that using that canvas element that we stored within this canvas const. So for our width, I'm going to reference this canvas const, and then just get a simple width property. I can do the same thing for height by grabbing our canvas height as the 4th argument. And this is going to draw a rectangle that is the full width and height of our canvas. So I'm going to save this with Command S, head back over to our browser, and we're not going to see any difference just yet, even with that code. Why? Because by default, when we call fill rect without any fill style, it's going to be drawing it in as black. So right now, our black rectangle is blending in with our black background. This is a very simple fix. Right above c.fillRect, I'm going to call c.fill style, and then I can set this equal to a string, whether it be a color, a hex code, an RGBA value, whatever we set fill style to. Fill rect is going to take that into account and then draw the rectangle out in that color. So our fill style, I'm going to set that equal to a string of white. That just says draw a rectangle out with a white color. I'm going to save that, refresh, and finally there is our canvas separated from our background. So this is the only location in which we can draw our game out right now. But we know within tiled, our game map was supposed to be 1280 by 768 pixels. So let's go ahead and change our canvas width and height right here to make sure that it takes up those full dimensions that we created within tiled. To do this, we're going to go over to our JavaScript, and right beneath where we're declaring constants, I'm going to grab our canvas and say that I want to set its width equal to the size of 1280. This is just going to be a static value, which is totally fine for our game. And I also want to grab our canvas height and set that equal to 768. So I'll save it as that, head back over here, and now that takes up the full width and height of 1280 by 768. So I'll actually have to move this to the side so we can see the full thing. And there it is. This is going to contain our full game map. But before we get to importing our map, over here, our code is starting to get longer and longer within our JavaScript. If this is starting to get too confusing for you, it kind of makes sense to put this in a separate file, so that way you have some sort of separation between your HTML, your CSS, and your JavaScript. I pretty much always like keeping my CSS with my HTML. That is just a personal preference, especially because I like using Tailwind CSS, which kind of encourages that workflow. But for our JavaScript, in this one instance, I do think it makes sense to put it into a different file, just so we can keep this main file a little cleaner and focused on just HTML elements. So if I want to go ahead and put this JavaScript code within another file, I'm going to go out to File, New File, and this is going to represent our new JavaScript file. So all I need to do here is go back to File, and then hit Save, and you'll see we're already placed within our Tower Defense folder, which is great. So I could go ahead and call this index.js. This is going to be our main JavaScript file that loads our game and activates everything that we need to get it going. But I'm not going to save this directly within this folder because I will be preparing for the future. I know our game is going to have more JavaScript files, and if that is the case, I think it makes sense to prepare a little bit in advance by creating a new folder called JS. So within this JS folder, all my JavaScript files are going to go inside of here. I'm going to make sure that I have that selected, and then call this index.js and hit save. So I scroll up, you'll see I just created index.js. But with the way we have things open in Sublime Text right now, it's kind of annoying to have to jump between index.js and index.html. If this is the case, I want to go over to File, and then Open, and I want to go back to our Tower Defense folder. Now instead of selecting a direct file like index.html or index.js, I'm just going to make sure that I have the folder selected right here. If only the folder is selected, and I hit Open within Sublime Text, yes, it's going to open something that looks like an untitled folder. But that's totally okay. All I need to do is go to View, and then Sidebar, and then Show Sidebar. And you're going to see that it has our project open in the side right here, so I can easily jump between files, whether it be index.html or index.js. So it just makes our workflow a lot easier in this case. I'm going to delete this other tab right here for the time being, and just stay within our project tab instead. So as I was mentioning, we need to get this JavaScript over to index.js. To do that, all we need to do is grab all of our JavaScript, hit Command X to cut it out of place, and now we can get rid of the script tag as well. We no longer need that. I'm going to save index.html, head back to index.js, and then paste all that JavaScript code in. So if I were to save this and make sure that I have index.html saved as well, head back to our game, save and refresh, you're going to see that our canvas is no longer showing. This just means that our JavaScript is not being read. Why is that? Well, we need to make sure within index.html that we pull in our JavaScript. Otherwise, it's just not going to work when we load up index.html. So to pull in our JavaScript, we want to create a script tag, but this is going to look a little different than the script tag we created earlier because we're going to be passing a source attribute into this. This just specifies what is the location of the code that we want to load as JavaScript. The location is going to be JS. We're going to go inside of this JS folder, and then slash index.js to load this file right here. So if we save that, refresh, now our canvas is back, simply because we're loading all of our code correctly by pulling it in through the script tag. So now that we have our game loaded up, let's go ahead and get our map rendered out into this area that we have for our canvas. So the first thing we need to do is head back to Tiled and export our map right here. To export our map, we're simply going to go up to File, and then Export as Image. I'll click that. This small pop-up will show. I'm going to hit Browse to say where do I want to save this image. And I know I want to save this directly within our game folder. So I'll head on over to Web, go inside Tower Defense, and then since I know this is going to be an image, I'm going to create a new folder called img for image, and then save this directly within there. I'm not going to call this Tower Defense, but rather game map. And I want to make sure that I save this as a PNG, so I'll add the extension directly by saying this is a .png, and then I'll just simply hit save, And all of our settings look good by default. I only want to include the visible layers that we actually have on our map. I don't care about the current zoom level because I know our map is 1280 by 768 pixels. We don't want to include our tile grid. We don't need object names. We don't need to include a background color. So all these defaults look great. Now I'm going to hit export. And now if I look within Finder, within our IMG folder, we now have a game map. This is just a simple PNG of that map we just created within tiled. And it's the exact dimensions that we want at 1280 by 768 pixels. So now that this is within our game, specifically within our image folder, we can begin importing it directly into index.js. So to import this, we need to call a c.drawImage function. So this is a canvas context function and it takes a few arguments. The first is going to be a simple HTML image. So you might think that we could just reference a string right here, go inside to our image folder, and then reference game map.png. And that might work, but we do need two additional arguments. So the second argument is going to be what is the location in which we want to draw this image out. I want to draw it out at an x location of 0. And then our third argument is going to be the y location. I know I want that drawn out as 0 as well, so we're starting from the top left-hand corner of our canvas. And like I said, you might think this works. Let's go ahead and save, refresh, and then I'm going to click this to go over to our console tab. You're going to see that we have the issue of failed to execute draw image on canvas rendering context 2D. And that is simply because this type right here, we cannot pass through a string as this first argument. It needs to be some sort of HTML image element. So to create that HTML image element, what we could do is create a const of image and set this equal to a new image. So this image object comes with JavaScript by default, and basically it's going to allow us to create an HTML element, but specifically an image element we can use within c.drawImage right here. But we're not done just yet. You might be thinking to create this image with this actual image that we have within our image folder, then we can just copy the string and plop it within this image instantiator. Unfortunately, that is not the case. This will not work, even though it makes sense. So instead, what we have to do is call our image const, and then grab its source attribute, and set it equal to the source, which actually references our game map over here. But once we do this, with this image object, this represents an HTML image, we can go ahead and replace within c.drawImage this string, paste an image instead. We save that and refresh. And yes, our console error is gone, but our image is still not being drawn. Why is that? Well, right now we're trying to draw out our image before it actually loaded within our JavaScript. So if our image loads after we actually call this method right here, it's just not going to show at all on the screen. As a result, with this image object, what we can do is, right beneath image, call image.onLoad. This is another method that says what do we want to do once this image has fully loaded within our JavaScript. Well, we want to call an arrow function. So whatever is within this arrow function is going to call as soon as our image loads. And this is a perfect location to say that whenever our image loads, we want to call c.drawImage. This is going to make sure that our order of events is running correctly. If we put c.drawImage inside of image.onLoad, save, and then refresh, now our image is going to be rendered out on the screen correctly because the order of operations is correct. And you do want to make sure that you're calling .onLoad before setting .src, simply because we want to make sure that all of this code is ready to go, just in case our actual image right here loads really quickly. We want to make sure that this code is available to us before that. But now with our game map rendered out, this is going to allow us to check off project setup, and now we can move on to pathfinding. So now we're going to focus on pathfinding, which is essentially how do we get our enemies from point A all the way to something like point B. Well, there are a couple of ways we can do this, one of them being we can use collision detection, or we can go ahead and use waypoints. So what is the difference between these two, and what are their pros and cons? So when I'm talking about collision detection, I think it makes sense to look at our tiled map over here. Our enemies are going to be coming in from the left-hand side of our path, and as they come from the left-hand side, eventually what might happen is they might hit something like a collision block. A collision block is just an entity that is there to say when an enemy hits this, we want them to either stop or react to this collision in some sort of way. In this case, they would react to this collision by moving upwards until they hit another collision block up here. Then we would say once they hit this, we want them to go to the right, hit a collision block here, hit a collision block here, and we'd keep placing these collision blocks in places in which we want our enemy to turn a specific direction. Now we could do things this way, but in my opinion this is a little inefficient, and is a lot more complicated than using something such as waypoint. Because the thing is, when an enemy hits one of these collision blocks, well, we have to determine which way does the enemy go. Are they going to be going up? Or are they going to be going down once they hit this collision block? And then we need to make sure the collision block is placed in the perfect spot up here to say, are they going to go to the right? Are they going to go to the left? So it's just a little complicated in this case to use collision blocks to determine which way our enemy should go. And it's going to be more taxing on our computer because we're going to have a lot of collision blocks in place to make sure that we're always monitoring for collision between our different enemies and these individual collision blocks. So the other method that we can use are going to be waypoints. Basically, these are just points along our path that we draw in. So let's say we draw one right here. We would draw one up here, right here. We're going to draw these all along our path. And basically, these are just points in which we want our enemies to travel to. As they hit one point, they're going to go on to the next until they reach the very end off of our map. So enemies come in from over here, they hit this point, they reach it, they go on to the next point. Once they hit this, we'll go to the next point in the array, and we'll keep on going through all these points until we hit the end. Now this is much more efficient because we're not monitoring for collision detection between multiple blocks. We're basically just performing calculations between our enemies and the next waypoint in line. And if you know a little bit about algorithms, basically the collision block algorithm would be something like O n squared, while the waypoint algorithm would be something like O n. So we're going to be using this version right here because it is more efficient than the collision block algorithm. So how do we even get started with this waypoint travel effect? Well, the very first thing we need to do is draw these waypoints onto our grid and then export them as data that we can import into our game. So how would we draw these waypoints out using tiled? Well, we can begin drawing points onto our map by right-clicking over here within our layers. We're going to create a new object layer. Doesn't really matter where it is in relation to the other layers, but we will have object layer 1 right here, and then we want to select this little triangular tool that highlights once you have object layer 1 selected. So what does this even do? Well, if I start clicking on our map, you're going to see that it draws line segments based on wherever I click. And we can either connect the line segments by going back to the start, or we can just hit enter to make a whole line segment that is selectable and that we can move around eventually. So this is how we're going to be drawing out our waypoints, is by using this line segment right here, and then we're going to export this data and import it into our game. Now there are a few gotchas regarding tiled and how to create these waypoints. Let's go ahead and delete this by hitting delete. And I'm going to make sure I have this tool selected once more. And what I'm going to do here is I'm going to start from the very top left-hand corner of our map. You always want to make sure you do this when drawing waypoints for a tower defense game when using tiled. Because if I were to draw starting from down here, and just go along our whole path with these waypoints, and I get to the very end and hit enter, yes, this is totally great. This is a good pathing for our enemies to travel along. But the issue with tiled is, you can see over here in the left-hand sidebar, they add offset based on where you started your actual lines. So they added an offset of -38 on the x-axis and an offset of 476 on the y-axis. And based on these offsets, if we were to import this data into our game, every single point would be off by these values over here. So we don't want to do that. We just want to make sure that we're drawing starting from the very top left-hand corner. It's going to make sure that our offset is 0 and that we don't have any discrepancies in regards to where our points are placed. They're always going to be in the exact correct location. So we'll get rid of this by hitting delete. We're going to make sure that triangle tool is selected up here, start from the top left-hand corner so we don't get any offset, and then we're going to go to the very first position in which we want our enemies to spawn. I think a good position is right here because let's say we put a bigger enemy into our game. We want to make sure that we have enough distance between our enemy and our actual path to make sure that they're not spawning in a place where we can see them before they start moving. So I'm going to go ahead and place our enemy spawn point right here. And then I'm just going to keep drawing as straight as I can with this line to the next waypoint position. So once an enemy hits right here, I want them to start going up, so I'll click. And then I'll start traveling up in a straight line. And I'll try to make these as straight as possible, just all around our path until we reach the very end. We want to make sure we're only clicking once, because we don't want too many waypoints right here. We're trying to make this as efficient as possible. And finally, once I get to this very last location, I'm going to stretch all the way off our map to make sure that our enemies actually travel off the map. That way we can remove them from our game later on. And this is going to be representative of the pathing our enemy is going to take. Now we will have a point in the top left-hand corner because that's where we started from to take into account that offset, but we will be removing that when we export the data. I'll show you how to do that very shortly. But to complete this path, we're going to go ahead and hit enter. And now we have this path ready to go and is stored within object layer 1. We can either hide this layer or bring it back, and we're always going to see this path in place. And you'll notice our X and Y offset are both 0. That is totally great. That is exactly what we want. And this is going to allow us to export this path and then import it into our game. So let's save this with a Command S. We'll head up to File, and then Export As. So where do we want to save this? I'm just going to save this directly within Downloads because it's more of a temporary file where we're going to grab the data from. So when I'm in Downloads, I'll hit Save, towerdefense.js. That is totally fine. I already have a version there. I'll just hit Replace. And now we can go ahead and view that within our Finder. So over in Finder, now we have towerdefense.js. Let's double click it to open it up. So this is the data file that Tiled exported for us. It contains all the data related to our different tile layers and also that object layer we just created. So if I start scrolling down, you're going to see this data right here is all related to the layer with the name of dirt. I can keep on scrolling down. Here's our pathing layer. Keep on going down, and we want to keep on scrolling until we actually find object layer 1 because that is what contained our polyline. And if we scroll down, this polyline JSON is associated with all the points we just drew out on our map. So we started off at 0, 0, exactly what we wanted, and then we moved down to a position of negative 124 by 475 for Y. And each point right here is the exact location in which we want an enemy to travel. So this contains all the data we need to get our enemy moving across our map, and as a result, we want to go ahead and select this whole array right here. I'm going to go all the way down to the very end of the array. I'm going to right click, hit copy, and we don't really need this file anymore, at least not yet. So this array I just copied, I want to go ahead and paste it into our game to make sure that it's available for later use when we start coding our enemy's pathing. So we'll head back to our project code over here, and now we just want to store these waypoints within their own file. So I'm going to do that directly within this JS folder. I'm going to go to File, New File, and then paste these on in. And by default, I'm just going to hit Command S to save it. Make sure that I'm saving that within JS. You'll see that is indeed within Tower Defense JS. What do I want to call this? Well, I think it makes sense to call this our waypoints because it contains all the data associated with our waypoints. I'll go ahead and hit Save. And now all those waypoints are saved within this JS file. Now I do want to save these to their own const so I can begin using them within index.js or some sort of other JavaScript file. So on the very first line, I'll get rid of the semicolon, declare a const, and say I want this const to be called waypoints, and set this equal to the array that contains all the waypoint data. And if we ever want to use this within another JavaScript file, we need to go to index.html and make sure that it's being pulled in before the file we want to use. So this is a little more of an old school way to pull in JavaScript files, but it's still usable nevertheless, is we just copy a script tag, paste it above or below, and then right before the file we want to use the script in, we'll go ahead and change this file of index.js name to waypoints.js instead. So if we save this, now we can use all the waypoints.js data directly within index.js. This is still a totally valid way of doing things. We're not using npm, we're not using imports. This is a lot easier to set up actually compared to all that stuff, and there's a lot more discrepancies and problems that can go on when using those module imports and exports. There are many good reasons to use them, but in this case, it is a lot easier to set up by just duplicating a script tag. So back in our game, let's create an enemy that starts moving to the right along our path. That'll be the very first thing before we start integrating these waypoints. So to create an enemy, we'll head on over to index.js. Now how would I begin creating an enemy on our map? Well, in our case, we're going to be using orc sprites, but we're not going to get to sprites until later on. We want to make this as basic as possible before we start implementing the details. So our enemy to start is just going to be a basic red square. How would I draw a square on the screen using canvas? Well, the same way we actually filled in our canvas with that rectangle earlier, making sure we differentiated it from the black background by filling it in with the white rectangle. So to create a red square which represents our enemy, we'll use c.fillRect and say, where do we want to draw this? Well, I want our enemy drawn somewhere over here so we can kind of predict on the x-axis. This is about 100 to 200 pixels over from the left. So for our first argument, we'll say we want to use c.fillRect on an x value of 200. Our y value is going to be something a little greater. Let's say it's around 400 pixels down here. So we'll say y is 400. And then what is the width and height of this rectangle? Well, I want this to be a square, so our width is going to be 100, and our height is going to be 100 as well. So if we were to save this and refresh, we're not going to see anything just yet. Why is that? Well, really, c.fillRect is actually being called before c.drawImage, because image.onload takes a little bit of time to process because we have a lot of data within our gamemap.png file. So we're calling c.fillRect immediately, and image.onload is called after. Therefore, c.drawImage is drawing that image on top of our rectangle right here. So to fix this, we need to make sure that we're drawing a rectangle, c.fillRect, inside of our onload function after we call c.drawImage. So I'll go ahead and paste that in, refresh over here, and there is a rectangle. Now I do want our enemies to be red to start. This is an easy fix. Right before c.fillRect, we can declare a c.fill style and set that equal to red. And that's just going to change the color of the rectangle. So perfect, there is our first enemy. Now to start, it doesn't really matter whether or not it's off our screen, but we do want our enemy to start moving to the right so we get animation in place. How do we begin animating our enemy so that starts moving across our map? Well, in this case, we need some sort of animation loop. And to create an animation loop, we need a function in which I'm going to call animate. You can call this whatever you'd like, but since it's going to be responsible for animating our game, makes sense to call it animate. So to begin an animation loop, we're going to call a function called request animation frame. And this is a method directly available within the window object, but since window is available to us at all times within our code, we don't actually need to prefix this with window dot. We can just simply call request animation frame like so. Now this takes an argument. What function do we want to call over and over and over again whenever we call animate in the first place? Well, it's going to be the function animate. So basically we're creating a recursive loop here. When we call animate, we're going to call this function request animation frame, which in return calls the function animate. So basically when we call animate again, we're going back to the beginning, and then we're calling all this code one more time, and it just creates an infinite loop until we tell it to stop. And to test that this is working, I always like console logging out any text inside of this. Basically it should be logged out over and over and over again as long as this request animation frame is running. And now all we need to do is call animate to actually run this animation loop. So let's save all this, refresh over here, right click and then inspect element. And then I'm going to open up my console. And there we go, our animation loop is definitely running. Now that we know that's running, how do we begin moving our enemy to the right? Well, we want to call c.fillRect for every frame of our animation loop. Otherwise, this is always going to be statically drawn. It's always going to be placed in the exact same spot. So I'll grab these two lines right here, which detail out how we're drawing our enemy in the first place, cut those out, and paste them within our animation loop. So now that this is being called for every frame, what we can do is change the x-coordinate over time. The x-coordinate right now is set to 200. If we begin increasing this over time, our enemy theoretically should start being moved over to the right. So instead of using a static value of 200 right here, let's change this out with a let called x. We need to make sure that we actually declare this let in the first place. Right above our animate function, I'll declare let x equal to 200. And then for each frame we run animate, we're going to take x and add 1 onto it by using x++. X++ is just equal to x plus equal 1. Basically, for each frame, we're going to be adding 1 onto the value of x. And then it'll be available to us the next time we call c.fillRect. So we'll use the x++ version. We'll save this. And then refresh over here in the browser, and you're going to see now our enemy is starting to move to the right. But we're kind of creating some sort of snail trail right here. We don't actually see the full form of our enemy. Why is this happening? Well, yes, we are calling c.fillRect in a new position for each frame, but we're never actually clearing our whole game canvas to give ourselves a clean slate to draw fillRect on top of. To clear up our game canvas, we can either use c.clearRect, and that'll go ahead and solve what we're doing, but we don't want to just clear everything. We actually want to use c.drawImage to redraw our background image, and then draw a rectangle on top of it. So instead of calling c.drawImage right here within image.onload, we're going to be calling that each frame we call animate. And eventually that image is going to load, so it's okay to call it in here. We don't really have to wait for that onload to begin animate or anything. If we really wanted to be safe and wait for our background image to load before we call animate, then we could go ahead and keep image.onload and say within the arrow function we want to call animate. Let's go ahead and do that just to show you how that works. We'll save all of this code, refresh, and now you can see our enemy keeps that form without that trail. So great, that's exactly what we want, but we really want this enemy to start following some sort of path rather than just going off the screen to the right. Now, it's important to note if we have multiple enemies on here, our code right here of c.fillRect is not going to work. To create more enemies right now, we would have to duplicate this code, paste it down below, and then change the value of x to make sure that our two rectangles are separated out from each other. This would be a lot easier with object-oriented programming because with that we can tell each object, each enemy in this case, to have their own individual x and own individual y properties. We could also tell them to have their own individual color, own individual width and height. With object-oriented programming, we have a lot more flexibility than just duplicating code within our animate loop. So that's exactly what we're going to do, is we're going to replace our current enemies where we're using c.fillStyle and c.fillRect with an actual object where we call something like enemy.update instead. So to begin transferring this over to object notation, right above our animate loop, we can create a class called enemy with a capital E because class name conventions are always uppercase to start. We'll create some opening and closing curly brackets, and then we want to call a constructor function. So basically, whenever we create an enemy, we're going to call this function, which sets all the properties associated with those individual enemies that we're creating. So what properties would an enemy have? Well, if we look within c.fillRect, we know that they have a position, and position is representative of an x value and a y value. So within our constructor, I'm going to create a position property to say that each enemy we create will have their own individual position equal to an object with an x. I'm going to assign this to 0 to start, and then a y, which I'll also assign to 0 to start. What other properties does an enemy have? Well, in this case, right now we have a width, as indicated by the third argument within c.fillRect. So this .width will be equal to 100 to start. We also have a height indicated by the fourth argument right here. So this .height will be equal to 100 as well. Now all we need to do is define how an enemy looks. So to do this, I'm going to create a new method called draw. This is arbitrarily named. You can name this whatever you want, but since this is representative of drawing out our enemy, it makes sense to call it draw in this case. So what code do we have to call to actually draw out our enemy? Well, these two lines right here, c.fillStyle and c.fillRect. I'll grab those two lines, paste them into draw, and we're almost done with creating our beginning enemy. So instead of using this default X in which we created up above for animate, now we can use the individual property associated with the enemy which we're about to create. So we'll get rid of this X and say whenever we create a new rectangle, we want to create it at this.position.x. Basically, we're going to be referencing this value right here that we set whenever we create a new enemy. We can do the same thing for Y. Say instead of referencing a static value of 400, we want to reference the Y value of this.position.y. And then we'll also replace our width and height with the properties we just signed up above within our constructor. So instead of 100 for width, we'll say this is going to be this.width. And then instead of a static value of 100 here, we'll say this is equal to this.height. So now to get the same effect where an enemy would be moving to the right, all we need to do is update this.position.x for each frame we run through our animation loop. So what I'm going to do is add in one more method, and it's going to be called update. So whenever I call update, I like to call the draw function, which separates all of our drawing code from the actual updating and logic associated with our enemy. And then I know each time I call update, I want to move this.position.x by one value. So for each time we call update, we'll add 1 onto the current value of this.position.x. So to transfer our code completely over to the enemy class, we can get rid of let x equal to 200, get rid of all this code down here as well. Right above our function of animate, I'm going to create a const called enemy. Set this equal to a new enemy from our class up here. We don't need to pass through any arguments just yet. We will eventually. But now that we have this enemy created and stored within this enemy const, we can take enemy within animate call enemy.update. So enemy.update is going to call this code right here, which in return is going to call this.draw, which calls this code up here. Let's go ahead and save this to make sure our code is still working similar to how it was prior. Like Command S. Go back to our game and refresh. And yes, our enemy is definitely moving to the right, but using that object notation instead. But we do want our enemy placed down here, so this is an easy fix. We just need to make sure that our position for our enemy is not a static value of 0, 0 by default. As a result, within our constructor, I'm going to pass through one argument. It's going to be an object. And within this object, I'm going to declare a property of position. So now we can pass through a position property. And once this position property is available to us, I want to use position to set this.position equal to the position we're passing through as an argument. Now, if we want some sort of default value associated with position, even if we don't pass anything through, we can set position equal to an object with an x equal to 0 and a y equal to 0. And this also gives us a little bit of insight in regards to what position is. In this case, we know we want it to be an object that has an x and a y because that's how we're using it down below within our draw method. So with the ability to assign a new position to each enemy we create, down here when we actually create a new enemy, I'm going to pass through an object, which takes a position property. And now I know that this position is equal to an object with an x and a y value. So I want x equal to 200, y equal to 400, and that should place it down below where it was prior, and there it is. We just replicated our code by using object syntax instead. And this is going to allow us to create multiple enemies really easily and update them rather than just one. So what I could do is I could create a new enemy by duplicating this line, say this is enemy 2, and then down with an animate, call enemy 2.update, and then say that our enemy 2 is going to have a position of 0 for x to start. That should separate them enough. Refresh. And now we have two enemies in place, but using some really clean code because we don't have to duplicate everything, create new variables, and so forth. We're just using the properties that we already declared within our enemy class. Now with our enemy class created, we can begin moving its position on the x and y axis based on our waypoint data. So hypothetically, let's say that this is going to be our enemy, and let's just say we want our enemy to move to this point over here. How would we go about setting the x and y values of our enemy to start moving upwards in a top right motion? Well, essentially, we're going to need to find the x and the y velocities of our enemy. And to find these exact x and y velocities, we need to use a little bit of trigonometry. So let's start by drawing a right triangle from our enemy to the destination point right here. I'm going to draw that out real quickly. The very first thing we want to find is the angle created by this right triangle between our enemy and the destination point. Because we need this angle to find the exact x and y velocity we need to start pushing our enemy up towards that direction in the top right. So before we continue with this algorithm, let's go ahead and get that angle. To get that angle within our code, I'm going to create a const called angle. And this is going to be equal to math.atan2, which takes two arguments. The first argument is going to be the y distance between 2 points, and the second argument is going to be the x distance between 2 points. So what do y distance and x distance represent right here? Well, if we go back to our right triangle, our y distance is going to be the space between these 2 points on the y-axis, so it's going to be the distance of this line over here, while our x distance is going to be the distance on the x-axis between the two, so it's going to be this line over here. How long is this line, and how long is this line created in the right triangle? Well, with 2 points, we can get this like so. If we're going to be using variables like we are down below, we need to create a const right above called y distance. This is going to be equal to this dot position dot y, so the y position of the enemy we're currently using for this formula, but now we need a second point to reference. What is that point going to be? Well, it's going to be one of the points available to us within waypoints.js. So we look within waypoints.js, we have a const called waypoints equal to an array full of different x and y values. Now we know within index.html, we pull this in with a script tag referencing waypoints.js. So since it's available to us within index.js, we can grab our very first waypoint by declaring a const called waypoint and set it equal to our waypoints array, which is available to us within waypoints.js, as you can see right here. We want to get the very first value, so we'll get that with an index of 0. So the waypoint we're referencing is going to be 0, 0 for x and y, just that one object, basically this whole thing right here. So now that we have our waypoint, get the y distance between this current enemy and the waypoint we're referencing, we can go ahead and get our waypoint dot y, because we don't have a position property associated with waypoint. You'll see inside of here we just have an x or a y. So we're grabbing waypoint.y and we're subtracting this dot position.y. So basically what we did was we grabbed this y position up here, and from it we subtracted this y position down here. It's going to give us the distance right here, in which we need to complete this formula to get the angle associated with our right triangle. The next thing we need to do is get the x distance. So to get our x distance, we'll create a const called x distance. And this will be equal to the waypoint we're selecting, but on the x-axis. From this, we want to go ahead and subtract this dot position dot x, and that'll give us the x distance. Now we can plug y distance and x distance into math.atan2. It's very important you use y distance first. That's just the way the equation was set up, in order to get the correct angle between those 2 points. So basically, with an angle, we're storing the value of this right here. It is not stored in degrees, so this is about 30 degrees, as we can see. It is stored in radians. And radians is just a fancier way to measure an angle. It's used in a lot of math equations and so forth. But when I'm referring to radians, you can just think of it as how wide is this angle open. If we wanted to assign a hard value to this, this would be equal to around 1 radian, I believe. But as I mentioned, to get our enemy up here moving diagonally to the top right, we need to set the x and the y velocity of this enemy right here. And the very first thing we needed to do that was get this angle. Now we're going to use this angle and plug it into sine and cosine equations. So we'll just say this angle right here is r for radians. We're going to plug that into sine and cosine. So we have sine r and cosine r. And the value produced by cosine r is going to give us the x velocity that we want. The value produced by sine r is going to give us the y velocity that we want. Basically, these are producing ratios of how large is one side of this right triangle relative to the other. Both sine and cosine are always going to produce values anywhere from -1 to 1. Same thing goes for cosine down here, -1 to 1. And sine is going to produce a value of how large this side is in a ratio type format. I don't know the actual value it would produce here, but let's just say that this side is producing a ratio value of 0.4. This is about the same, so sine in this case would also produce a value of 0.4. If we're to add an x velocity of 0.4 and a y velocity of 0.4, doesn't it make sense that our enemy right here would be moving perfectly diagonally upwards towards the top right? Yes, it does. But based on where our waypoints are at any point in time, let's say our waypoint is over here, we're going to get completely different values for our x and y velocities, but they're going to be in perfect ratio format that we always know our enemy is going to be moving towards this waypoint. All thanks to getting the angle right here, plugging it into sine and cosine, which produces those ratio values to push our enemy in the correct direction. So based on what we wrote right here, let's go ahead and plug in this angle we just got directly into sine and cosine, and then assign them equal to an x and a y velocity. So over here, when we're adding 1 onto position.x, essentially what we're doing is using 1 as our x velocity. So here, what we can do is call math.cosine, because cosine is associated with the x-axis, and we want to plug in the angle, which we're retrieving down here. If we want to use angle, we need to make sure that we're calling this after we actually assign angle. So I'll move that down below. And we want to do the same thing for this .position.y. We're going to make sure that we add on to this for each frame, math.sine angle, and this is going to produce our y velocity. So when we use these two in tandem together, math.cosine and math.sine, and this angle we just produced, we're always going to make sure that our enemy is moving in the correct direction towards whatever waypoint we specify right here. So let's save this, and if we look within waypoints.js, currently we're referencing an x of 0 and a y of 0. So if we were to actually run this code for our enemies in place, both of them would start traveling towards a position of 0, 0, no matter where they're placed on the map. So let's go ahead and save this, refresh, and hope this works. Our enemies should start moving towards the top left with all this code. I refresh, and indeed both of our enemies are moving towards that one specific waypoint. So what we're going to do is, once these reach this waypoint up here, they're going to stop. We're going to set the waypoint equal to the next one within this equation. So we're going to change waypoint to the next value, waypoint's 1. That'll go ahead and give us this value right here. And if we run that with all this equation code down below, well, it's going to move our enemy to the next location in line. So each time we reach that waypoint, we're going to say begin moving towards the next one, and it's going to create that pathing effect, in which we've been trying to get during this whole lesson. So this value right here, the static value of 1, which represents our waypoint index, this needs to be dynamic for each enemy that we have, because one enemy might be at one waypoint before the other. We don't want to be changing all the enemy waypoints at once. They need to be dynamic and changing only when they reach a specific position. If we want to make this dynamic, we need to create a new property, and I'm going to call this .waypoint index. By default, it'll be equal to 0, but now we can use, right here instead of a static value of 1, we can use this .waypoint index instead. Now this is going to allow us to change this value based on some sort of condition. So down below, I'll write an if statement to begin that condition that says if this .position.x is equal to the waypoint.x and this .position.y is equal to the same position on the y-axis associated with our waypoint, so waypoint.y, then in this case we want to go ahead and move our waypoint index to the very next value by adding 1 onto it. So if we want this conditional to be true, it makes sense to round both of these to the nearest whole value, and that should solve our problem of these two never actually being equal to each other because they have those floating point values in place. So for our position.x, I'll round this with math.round. That'll give us a whole number value. And we can even test this by consoling out math.round position.x up above just to show you what this looks like. Go ahead and add that second parentheses on, save that, refresh. Now we're always getting some sort of whole value. So this is going to be a lot easier to test for when we reach that waypoint's value of 0 up above. You'll see that's actually working down below. So let's delete that console log, and we'll just round out everything. We'll add math.round to this .position.y, save that, and then also to our waypoints just to be extra safe. We'll round those out as well. Now we should always be testing for whole values, and once our enemy reaches a specific waypoint, we're going to change their next position by adding on 1 to the waypoint index. We'll save that. And now when these reach the position at 0, 0 on the top, that's our first waypoint, they should be moving on to the next one in line. So let's watch that happen. And indeed, those begin moving to the next waypoint, so perfect. Once those reach the next waypoint over there, they're going to start moving to the right. There they are. And they're going to keep moving throughout the whole map until they reach the very end. Now it's important to note within our code over here, we only want this conditional to run for as long as waypoint index is less than the actual amount of waypoints within our waypoints array. Otherwise, we're going to get some errors when we try plugging in waypoint index into our waypoints array up here, because waypoint index might try referencing something that doesn't actually exist because it is such a large number. So we want to make sure we add in one more AND statement that says, only call this code right here, only add 1 onto our waypoint index if this dot waypoint index is less than our waypoints dot length, so the current amount within our waypoints array, minus 1. That's going to prevent any bugs from occurring as we keep adding 1 onto waypoint index. So the next thing I would do is get rid of that very first waypoint up here because we only use that for export and import purposes for the rest of our waypoints. So to get rid of that one waypoint, I'll head into waypoints.js and delete an x and a y0 for the first waypoint. We can save, refresh, and now these are going to move directly to the next waypoint over here, but it kind of makes sense to make these enemies start at that waypoint rather than move to them by default. So to make these enemies start at that waypoint, over within index.js, where are we creating our enemies? Well, right here. We could do this in one of two ways. One, we could reference our waypoints object, the very first one, and then reference the very first value associated with that waypoint. We could get rid of the 400 over here and reference that y value as well, and that should make sure that our enemy starts from that one position. We could also go up above and make sure that we're signing position equal to the very first waypoint value. I think in this case it's totally fine to just pass through the very first value associated with waypoints. So I'll grab this code right here, all the properties within the object, get rid of these two properties that have static values, and paste in waypoint 0x and waypoint 0y for both enemies. So let's save that, refresh, and now our enemies are starting off to the side and they're going to travel the full path right here. Now if I wanted a little bit of offset between these two enemies, simple enough, I can find our second enemy, and from waypoint 0x, I could subtract something like 150, and this should give us a little bit of space between the two. Let's refresh after saving. Now we have our first enemy right here, and there comes our second enemy, and they're going to follow the whole path. Now the next thing I want to do is make sure that our enemies are actually following this path from their very center. Right now, they're only following this path from the top left-hand corner because that is where we're actually drawing out the square. We need to draw these from the center, so as a result, we're going to create some sort of center property which actually references this value. So to add in a center property with our enemy, I'm going to add in that property called center. It's going to have an x and a y. So our x is going to be equal to this dot position dot x. But how would we go from this point up here to the very middle? Well, we could add on to this dot position x half the width of our current enemy. And then for our y value, we could add on half the height to get this exact point right here. So that's exactly what we're going to do. On to position x, we'll add on this dot width divided by 2. Then we need a y value. So y will be equal to this dot position dot y plus this dot height divided by 2. Now that'll give us our center from where our enemy spawns. But if we want center to update, for each time we change our position, when we change our position down here, we also need to make sure that we're setting our center. So basically, right after position is set, down below we'll also set our center with this dot center is equal to an x and also a y. We're basically going to be setting it equal to the same thing that we just wrote up above. So I'll copy those two lines and say, whenever we're setting center down here for each frame with an update, we're setting it equal to the position we just set up above. But adding on to this dot width divided by 2 and this dot height divided by 2. It's going to ensure that we always get the center of our enemy right here. Now what we want to do is instead of getting the right triangle angle created from the top left-hand corner of our enemy, so in this case it would be this angle right here, we want to get the angle of the right triangle associated with the center of our enemy instead. So to get that angle, what we would do is replace position right here with this dot center dot y, and position right here with this Now we're going to get the position of the center of our enemy rather than the top left-hand corner. And this is all great, but we do want to change within our conditional right here to test for the center of a rectangle rather than the top left-hand corner. So in these two locations, instead of referencing the top left-hand corner, I'll reference this .center instead. Now when we save this and refresh, you're going to see our enemies eventually start coming from the left, and they're placed pretty darn close to the center of our path. When the center is hit the next waypoint, they're going to start moving out to the next waypoint. Basically, all of our waypoint code is now determined from the center of each square. We're getting that angle from the center rather than top left, which is allowing this to be drawn out correctly, rather than getting that weird offset where we're drawing from the top left-hand corner. So I think the last thing I would do here for pathfinding is making sure that we can create multiple enemies at once, spawning them all out on the screen, rather than just dealing with these two enemies that we have right now. So to spawn even more enemies, instead of using individual objects like we are right now, right above this I'm going to create an array called enemies. This to start is just going to be equal to an empty array, but what we can do is start populating this array with new enemy objects and then begin rendering them out on the screen. So instead of populating them directly, what we can do is run a for loop. We'll call that with for, let I equal to 0. This is where our index is going to start. We're going to add a semicolon to say that for as long as I is less than 10, we're going to add a semicolon. Then we want to, for each iteration of this frame, add 1 onto I. Basically what this for loop means is we're going to go through this whole thing 10 times. When we're going through this 10 times, we can call our enemies array and push into it a new enemy for each iteration. Now each enemy is going to take one argument, a simple object, with a position property. Position is equal to an x and a y, which we have down below. Let's go ahead and grab this, copy it, paste it into our new position up above. We can get rid of these two enemies down below. Since we're getting rid of those two, we need to get rid of enemy.update and enemy2.update. We'll get rid of those two. And we do want our enemies spaced out from each other. So we'd want to change this x value right here for each iteration of our loop. We can create a const called x offset and set that equal to I times something like 150. So by default, x offset is going to be equal to 0 because when I is equal to 0, we multiply that by 150, gives us a value of 0. Great. But once we go on to the next iteration of this loop, I will be equal to 1. We multiply that by 150, x offset is equal to 150, and now, from our waypoints.x, we can subtract from this the value of x offset. For that next iteration, we're subtracting 150, which will make sure our enemy's offset. And this is going to keep increasing that offset for each time we go through this loop until we hit 10 because I is always going to be increasing by 1. So those are going to push offset enemies into our enemies array. Now we just need to render them out onto our screen. We'll do so within our animation loop by calling enemies.for each. For each enemy within our enemies array, we're going to call the following arrow function. And within this arrow function, we'll select that one individual enemy and call their associated update method. So update right here is going to call update right here, but for each enemy within the array that we just pushed in. So we'll save this and refresh, and eventually our enemies will start coming in from the left. They should all be offset. So it indeed looks like some of these are offset. We do have one little offset issue right here, and is probably due to when these are spawning in the beginning. To reach that first waypoint, we're moving these a little bit to make sure that the center reaches that waypoint rather than the top left-hand corner. And over here, we don't really have much distance between the first and the second enemy, as the first enemy tries to move its center to match the waypoint's x-axis. A simple fix for this is just to increase I to 1 instead. We'll save that and refresh. And that should get rid of that little overlap that we had with those first two enemies. And indeed it did, so now this is looking great. We have multiple enemies in place which are ready to be shot against using some sort of tower. We can create as many enemies as we want with this technique. For however many times we're running through this, whether it be 10, 9, 20, 30, 100, we can just keep creating enemies with this and they'll always be available to us and start running along this path for as long as we tell them to. So currently we have 1, 2, 3, 4, 5, 6, 7, 8, 9 enemies who are ready to be shot at using towers. But I think with this, we can go ahead and check off pathfinding. Next, we're going to look at building placement. So how do we actually get buildings drawn onto our map? So we're actually going to start with tiled. So let's head on over there, and once we're within tiled, we want to scroll within our tile set on the right-hand side here all the way to the right. If we scroll all the way to the right, we're going to see this little green block in which we can select, and then we can start drawing blocks onto our screen as long as we have a tile layer selected. So I actually want to create a new layer for this block. I'm going to right click, hit new tile layer, and I'm going to call this placement tiles. So this little green block right here is going to represent a location in which we can place a building. So if I were to draw one right here, right here, right here, essentially we would only be able to draw buildings in these 3 spots. At least that's how we're going to program it. Now I do want to keep in consideration when adding in these building placement tiles that our buildings are going to be 2 tiles wide. So if our buildings are 2 tiles wide, we wouldn't want to place a placement block right here because that means a building can be placed across these 2 tiles. But a building would also be able to be placed in these 2 tiles, meaning that the building image would actually be overlapping with another one. To make this as easy as possible to program, I'm just going to make sure that our building tiles always have at least one gap of spacing in between them, at least on the x-axis. So what I want to do is say wherever we want to draw a building onto our map, I want to fill it in with that green tile that we have over here. So I'll make sure we have our brush tool selected, and I know down this whole column right here, I want to be able to draw buildings all the way across here. And then I want at least one column worth of spacing so that our building image will always fit without overlapping another one. So one column over, we'll draw those in. And then we'll go one more column over to the left and draw those in. So this is currently the only location in which we'd be able to draw in buildings. Where else could we draw in buildings? Well, I think it makes sense over here to start adding in tiles. Start spacing these out by skipping over one tile. So one. We'll just keep drawing in locations in which we can draw these buildings. And then finally, I want to make sure I get this little area right here so I can draw a building on this corner. Now, there are still a few areas in which a user might think they can draw in buildings, such as over here, maybe up here on the top right, and definitely right here. If you want to make sure that a user knows they can't build anything in these locations, it makes sense to go back to one of our detail layers and select some sort of small object. It could be any of these. Let's go ahead and select this little rock right here. We'll just select a location in which we don't want a user to be able to place a building. So I don't want to be able to place one right here. Over here, I'll select a different rock to add a little bit of variety. And I think the very last location would be right here next to this sign. Let's go ahead and add in a cactus. And now we are totally set. So here's how this is going to work. We just placed all these green building tiles within the placement tiles layer. We're going to export all the data associated with our placement tiles, so all the green tiles, and then we're going to import them into our game. So basically everything we see right here with the green tiles, we're going to be importing into our game, placing those tiles in their exact position, and basically transforming them into a JavaScript object we can interact with. So how would we begin exporting these tiles and then importing them into our game? Well, to export these tiles, we need to make sure that we go to File, and then Export As. Once we're within Export As, we can export this as a JavaScript map file. It's basically a compilation of all the data related to all of our layers. And I'm just going to save this as Tower Defense.js. It's totally okay if we overwrite this right now because all the data related to our polyline within Object Layer 1 is still going to be there if we need it later. So let's go ahead and hit Save, and then Replace, and that's going to overwrite that one file. Now let's go ahead and open it. So I'll head on over to my Finder, double-click TowerDefense.js, and here is our file. So we want to scroll through this until we find a layer name of placement tiles. We can also type Command F and search for placement. It's going to auto-direct us to the data that we actually want to use. So if we scroll on up above the name of placement tiles, you're going to see this data property which has an array assigned to it. So I'll explain this shortly, but to start, let's take this array to the very end, copy it, and then head back to our project. So within our project, we're going to want to create a new JS file that stores all this data related to our placement tiles. So to do this, we can go to File, New File, and then paste in all that data. So I'm going to make sure that I assign this equal to a const, and I'm going to call this placement tiles data. Add in an equal sign and then save this with Command S. And then where do I want to save this? Well, simply within our JavaScript folder, .js. And I'm going to save this as placement tiles data.js. So hit save, and now that is available to us within our JavaScript project. But if we want to use this within index.js, which we do, we need to make sure that we're importing it within index.html. So we'll head on over there. And then to import this within index.html, all we need to do is duplicate one of these script tags, and then say we want to pull in from our JS folder, placement tiles data.js. So placement tiles data.js, we'll hit save, and now this should be available to us within index.js if we need it. To double check that this works, we'll go ahead and console log out the variable that we declared in here, which is placement tiles data. Go back to index.js, paste that on in, save, and then head back over here to our game, and refresh, inspect an element, head to the console, and then in here, our array of 240 items contains all of our placement tile data. So this doesn't make any sense at first glance. This is just a bunch of zeros and 14s. But what we want to do is transform this into a 2D array. What do I mean by that, and why do we want to transform this into a 2D array? Well, let's go ahead and observe our data within placement tiles data. So basically, each number right here, whether it be a 0 or a 14, represents one tile within our tiled map. So everywhere we see a 0, we're saying do not draw anything in this one tile location. But every time we see a 14, we're saying let's go ahead and draw a placement tile in this specific location. And this is a one-to-one representation of what we created in tiled. So if we were to start from the top left-hand corner of our map, we know we don't want to draw anything in the very top left-hand corner, but once we move one tile over to the right, we do want to draw in a building placement tile. We should be allowed to place a building in this specific location. So let's go ahead and look at this real quick, and then scroll on back to tiled. You'll see in the top left-hand corner we do not want to draw anything, but right here with this green tile, we're saying we do want to be able to place a building right here. This green tile is representative of that 14. Now things are arranged in a way right here where we're just scrolling through all these values, but we don't really have a way to separate these values into rows and columns, which we would want to do to start creating building placement tiles as an actual JS object. So we want to convert this one-dimensional array to a 2D array. Basically, it's going to be an array of arrays. It's going to look a little something like this. We have our main array right here. And then inside of this, we're going to have another array that contains all these values. And within this one row right here, we're only going to have about 20 values. So 20 values right there. And these 20 values are indicative of how many tiles we have per row within our tiled map over here. So for each row, we have 20 tiles. And each row is going to be indicative of the values we're passing into the child array within our main array. So within our main array, once we go ahead and loop through these first 20 tiles, we're going to go ahead and loop through the next 20. Put 20 values within the next array. And we're just going to keep looping through this and putting 20 values in a new array until we reach the very bottom. So basically we're going to have 12 arrays, which represent rows of all of our tiles right here, and we're going to have 20 columns. And when we organize our data in this format, a 2D array, arrays within an array, it's going to allow us to precisely place our placement tiles in the exact location. So we can say, hey, we do want to be able to place a building right here. So when I click, simply place a building. So let's start parsing our data right here into a 2D array so we can start adding our placement tiles to our game. So to parse this into a 2D array, within index.js, we have all that data available to us. This is simply an array. What we want to do is create a new const. And this const is going to be called placement tiles data 2D. So this is the one-dimensional array right here. This is going to be the 2D one. We're going to set this equal to an array to start. Now we want to loop through our placement tiles data right here. We want to say take the first 20 values, put them within a new array, and then push that array into placement tiles data 2D. Then we're going to go to the next iteration, which gets the next 20 values, then the next iteration, which gets the next 20, and so forth, till we run through all the data within placement tiles data. So to get this effect, we can create a for loop. Within this for loop, I'll create a simple index with let I is equal to 0, and then I want to say run through this array as long as I is less than placement tiles data dot length. And then for each iteration of this loop, at the very end, I want to go ahead and take I and add 20 onto it, because that is how many tiles are within each row within our actual game map. So now I know for each 20 values, I want to push in those values into this new array we just created. So I'll select placement tiles data 2D, and then push in a new array of values. So how do I create a new array of values based on the first 20 units within placement tiles data? Well, within push, we can grab placement tiles data, and then call an array slice function. So what slice does is it takes an array, and it says slice out the specific number of values from this starting location and this ending location. So basically, we only need to pass through two arguments. The first one is going to be the starting location in which we want to slice out elements. It's going to be I because by default, I is equal to 0. So we're starting at the very first element. We'll add in a comma and say we want to slice out I, so 0, plus 20. So we're saying get the first 20 elements from placement tiles data, and then for the next iteration of this array, I is going to be equal to 20 because we added on 20 right here. And then if we say we want the elements 20 to 40 because we're adding on 20 right here, we're going to get the next 20 items until we loop through this whole array. So this should give us the effect we want to go for. To test this out, we're going to console log, placement tiles data 2D. I'll delete this console log up above, save, and then head back to our console and refresh. And now you can see right here, we have an array full of arrays, which is great. That's exactly what we wanted. And each of these arrays has 20 items within it. So if I were to stretch this out, you can kind of see how this resembles our game map. And everywhere where there's a 14, that is where we said we want to be able to place a building. So this little row over here, all the way down to our path, we want to be able to place buildings as indicated by these 14s. Then we have a space in between each 14, each building that we want to place. This is exactly what we drew out directly within tiled. So now what we can do is, based off of these rows and columns, we can say we want to put a placement tile object at this exact location when we loop over it. We're going to have an X value and a Y value that's going to allow us to do this, thanks to this parsing into a 2D array. It's going to make more sense shortly as we actually go through this process. So the next step is going to be looping through these arrays in a 2D manner. How do we go about doing that? Well, let's start looping through each individual row. To loop through each row, we want to take placement tiles data 2D and say for each row. Within this array, we want to call the following code. So basically, we're saying grab each of these rows that we just created, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we're grabbing each row and storing that array within this variable right here. And now that we have that array, we could call row.forEach for each what within the row. Well, for each symbol, essentially. 0 or 14 are going to be symbols. So let's go ahead and call this symbol right here and say for each symbol within the row, we want to call the following code. Now we're basically selecting the first row, looping through all the items within it, and then we're going to go to the next row, loop through all these items, and we're going to keep going until we hit the very end right here. So now we can analyze each individual symbol. Within this for each, we can say if the symbol we're currently looping over is equal to 14, then we want to create a building placement tile. And we're going to push it into an array right here. So let's go ahead and add a comment that says add building placement tile here. So a building placement tile is simply going to be a rectangle, basically a square. But in order to create one of these, it makes sense to create a class because that is going to make our code scalable and a lot easier to work with than if we were to use something else. So to create a class, I'm simply going to create it right above. We'll go ahead and refactor this into its own file shortly, but that class is going to be called placement tile with opening and closing curly brackets. So I want to create a constructor within this new class, and this constructor is going to pass through one singular argument. It's going to be an object, but within this object, I'm going to have a property of position, and the default is going to be x set equal to 0 and y equal to 0 as well, so I know exactly what this should look like as I pass it through. I'll add in the opening and closing curly brackets to actually factually fire this constructor. And then I'll say this dot position is going to be equal to the position we actually passed through right here. Now a placement tile is just going to be a simple square. So we need some sort of draw method that actually draws this out on the screen. So I'll create that draw method. And then within this, I'll say c.fillRect. What is the x position going to be? Well, it'll be this dot position dot x, which we declare up here. The y position will be this dot position dot y, and then we need a width and a height. So we know the width and height of our tiles are going to be 64 by 64. But if it's not directly indicative of what 64 and 64 are right here, what we can do is add in a property that says this dot size is equal to 64. So we'll replace 64 down here within draw with this dot size in both locations. And now we should be able to begin creating placement tiles and storing them within an array. So let's create that array. I'll go ahead and declare a const of placement tiles set equal to an array. And now as we're looping through our 2D array down here, right beneath this comment, I want to take placement tiles and push in a new placement tile instance. And this is going to take an object for the first argument with a position inside of it that has an x and also a y. So this placement tile is going to be indicative of the green little tiles we want to place along our map. But how do we place a placement tile when we get a symbol of 14, which basically says put a placement tile right here? Based on which tile we're currently looping over, we need to dictate the position of this new placement tile, and we can do so by getting the indices of each row in each symbol we're currently looping over. So if we look over here at our array, each row we're currently looping over has an index associated with it. The first row is going to have an index of 0, the second is going to be 1, the third is going to be 2, and so forth. And if we want to grab this index directly within our code, as a second argument within our callback function right here for the very first for each, right after row, we can add in a comma, and then indicate that we want to grab I, which is going to be the index associated with each row. So I right here is just representative of the 0, 1, 2, 3, and so forth until we hit 11. And if we think about this, each index associated with a row is going to determine a placement tile's Y position, because we're moving down for each row that we loop over. So I typically means index. I think in this case it makes sense to replace it with Y actually, to indicate that this is going to be the Y index in which we're currently looping over because we're going through our rows. And now that we're grabbing Y right here, when we create a new placement tile, we can replace the static 0 with the Y index we're currently looping over, and say whenever we hit 14, we're going to grab that Y index, but we're going to multiply it by a size of 64, because that is the tile size, in which we declared up above. It's the tile size declared within our map. We want to push our tile down to this exact location multiplied by 64, and when we do this, all of our tiles are going to be placed correctly along the Y-axis. But we want to do the same thing for our X-axis as well. So as we're looping through each symbol, we're going to be going to the right. We're going to have an index of 0 right here, an index of 1 right here, all the way until we hit an index of about 19 at the very end. So right here within our row.forEach, after symbol, we can add in a comma, and then add in an index, which I'm going to call X. This is going to be the X index. And down here, where we're assigning a position to X, I'm going to replace the 0 with X times 64, which is the size of our tile. Save that. And then I want to console log out all of our placement tiles. So I'll grab this right here, delete this console log down below, and replace it with placement tiles. Save, and refresh. And now we have about 39 placement tiles, all pushed into this array, and they're all going to be in the exact positions in which they should be rendered out at on our map. So I'll open up one of these. You'll see the position has 64.0. 64.0 is right up here in the top left-hand corner. Where is the next placement tile going to be? Let's open it up. It's going to be at 192.0. So that's going to be about right here. And each of these is perfectly placed in the exact location in which we want to render out a tile. But let's go ahead and actually render these out so we can see these being placed correctly. To render these out, basically we want to loop through all these placement tiles and then call their draw method that we declared right here. So to loop through all these tiles, we're going to scroll on down to our animation loop, and right at the bottom right here after enemies.forEach, I'll call placement tiles.forEach, and say for each tile within this array, I want to call tile.draw. So let's save this and see what it looks like within our browser. I'll exit out of the console, refresh, and now we have all our placement tiles in their exact locations relative to where we placed them directly within tiled. The only difference really is we're using a green tile over here. Here we never declared a fill style, right now it's just red. Let's go ahead and change this to green so that it matches up with what we have in tiled. To do this, we'll go ahead and find our class up above, placement tile, and then declare that this .color is going to be equal to a string of green. If this is the case, then within draw, we can declare a c.fillStyle is equal to this .color, and the reason I'm using a property of color right here is because we're going to be changing this later on dynamically, depending on where we place a building, but this is okay for now. Let's save this .color right here, refresh, and now our placement tiles have that green background, and our enemies have the red background, so great. The next thing I want to do is indicate when I'm hovering over one of these tiles to help the user know that this is a specific location in which we can place a building. So the very first thing I'm going to do is actually change this color once more from green to a light white. I'm going to use a very transparent color right here just to help indicate to the user that when we hover over this transparent element, it lights up. This is somewhere that we can place a building. So how would I make this a more transparent color? Well, right here within our placement tile class, instead of our default color being green, I'm going to set it equal to RGBA, which takes 4 values. The first is going to be how strong should our red color be? Now these values only range from 0 to 255. 0 is going to be a darker version of red. 255 is going to be a very bright version of red. So I want the brightest version possible. It's going to be 255. I'm going to add a comma that says what should our green value be? Any value 0 to 255. I know I want this to be as bright as possible, so I'll add in 255. And then what should our blue value be? Well, 255 for this as well. The final value is going to be alpha, and this ranges from 0 to 1. If we put 0 right here, this just means we're not going to show this at all. It's completely transparent. If we put 1, we're going to see the full color associated with this RGBA value. And if we use 255 for each value right here, these colors combine at their strongest value to create the color of white. So let's save this, refresh, and now we have that white value. But the cool thing is, we can change its alpha value right here down to something like 0.1, save and refresh. Now you can see a very faint outline in which we might be able to place a building. Now this might be a little too faint, but we can always turn this up by adding on to this alpha value. I'll add on 0.05, refresh, and I think I like where this is going. So now based on wherever my mouse is within our canvas, I want to detect for a collision between each individual placement tile and where my mouse is. If the mouse is hovering over one of these placement tiles, we want to go ahead and light it up to indicate that this is a location in which a player can place a building. So to add in this collision detection, we're going to go back to our code, and I'm going to create an update function that always monitors for whether or not our mouse is colliding with the placement tile we're currently hovering over. So if I'm going to call update, I want to make sure that I call draw. We're going to call this code up above. And then I want to create an if statement that says whether or not our mouse is colliding with this individual tile. So if we need the position of our mouse, well, we need to add in an event listener before we can even use it within update right here. To add in an event listener, usually I add these at the bottom of my file. I'm going to scroll all the way to the bottom, and then I'm going to call window.add event listener, like so. So the first argument is always going to be what event we want to listen for in string format. In this case, we want to listen for a mouse move event. So whenever we move our mouse on the window, we're going to track exactly where we moved it. And the second argument is going to be an arrow function. This arrow function determines how we react to whenever we move our mouse across the window. And this passes through an event object. So let's go ahead and console log out our event object so we can see what it looks like on the inside. Refresh with our console open. When I begin moving my mouse across the screen now, you can see if I open this, that we have a few properties associated with that event. The properties we want to focus on are going to be client X and client Y. So where on our window did we just move our mouse to? Well, we moved it to an X position of 1277 and a Y position of 519. We want to use this so that we can detect for collision between each placement tile and where we actually moved our mouse. So to use this within some sort of collision detection formula, I'm going to create a const right above this event listener called mouse equal to an object with an X and a Y. X by default is going to be undefined when we first load this, and Y by default will also be undefined. Totally okay to put that there, but we do want to assign these values whenever we actually move our mouse across the screen. So within add event listener right here, I'll take our mouse.x and assign it equal to event.clientX. This is the exact value that we saw over here within our console. We want to do the same thing for mouse.y, set it equal to event.clientY, and now this object is always going to be set whenever we move our mouse across the screen. Perfect. And now that this is being set, we can use it up above within our placement tile class by passing it through into this update function. So whenever we call update for each placement tile, we're also going to pass through our mouse object. And now that this mouse object is available to us, we can use it within some sort of collision detection formula. So we're going to create that collision detection by creating this if statement that first grabs our mouse.x. So where is our mouse on the screen on the x-axis? If it is greater than this .position.x, so the x position of the tile we're currently looping over, then we want to call the following code. So we'll go ahead and call this little red dot our mouse. This is obviously one of our tiles. We're saying if mouse.x is greater than the x position of this placement tile right here, we know it is colliding on the x-axis, at least from the left-hand side of our tile. That is step one, but we also need to determine whether or not it's colliding from the right side of the tile as well. So we only want to activate this code if our mouse.x is within the right side of our placement tile over here. How would we write that out as a conditional? Well, we'd want to add in an and statement that says if mouse.x is less than this position.x, which is going to give us the left side of our green placement tile, so we're getting the left side right here, plus this dot size, we're adding on 64 to this dot position.x. That's going to go ahead and give us the right side of the placement tile. So if the x value of this little dot right here is less than the right side of our placement tile, then we do know it is colliding. It's not colliding if it's over here, it's not colliding if it's over here, it's only colliding if it's in between the left and the right hand side of our placement tile. That takes into account the x-axis, but we also need to take into account the y-axis as well. So we'll continue adding in and statements. This and statement is going to say if our mouse.y is greater than this .position.y, then we know our mouse is colliding on the y-axis. This means mouse.y is within our building placement tile. We also need to make sure that it's in the tile from the bottom side as well. To take this into account, we'll add in an and statement that says if mouse.y is less than this dot position dot y plus this dot size. That's going to add on height. That says if mouse y is less than the bottom side of a building placement tile, it is definitely colliding. So now we're only going to call whatever is within this if statement. If this little red dot right here is actually within our placement tile, this little red dot, remember, represents our mouse. So this is exactly what we want. Let's go ahead and console log out within this if statement. Just some random text that says colliding to make sure that it functions correctly. But remember, before we actually test this out, mouse needs to be available to us, which we're passing through as an argument through update. I guarantee you right now, we are not calling update and we're not passing through an argument whenever we're looping over each placement tile that we have within our placement tiles array. So let's go ahead and scroll down to our animation loop down below. It's going to be right here on line 121 for me. We're looping through all these placement tiles on line 129, and then we're calling draw. We no longer want to call draw, we want to call update instead. But whenever we call update, we need to make sure we're passing through that mouse object, which we're assigning down here, and setting its x and y values within our event listener. So let's save that, refresh, and you'll see when I move my mouse, we're not going to see anything related to that collision detection code until we actually hover over one of these white spots. So as soon as I hover over one of those white spots, you're going to see we're console logging out the text colliding, exactly what we want. But if I hover off of it, no longer seeing that being logged out, it just stops completely. And this is going to work for each individual placement tile block that we have because we wrote correct collision detection code. So now what we want to do is say when we hover over one of these, we want to brighten up this one individual tile's alpha value, which is just going to make it completely white. To do this, we'll scroll on back up till we find our placement tile class. Now you might be noticing as we're going about developing this, it's really annoying to have to scroll on up and find the exact class we're looking for. If this is the case and you're feeling annoyed, this is a great sign in which you want to refactor your code. So to refactor this, it makes sense to place these classes in their own individual file. So to do this, what I'm going to do is start by taking out our placement tile class. I'm going to select the whole thing, hit Command X, and then I'll save index.js. And then over here within our JS folder, I want to go to File, New File, and then paste in that class of placement tile. So I'll save this with Command S. And then what do I want to save this as? I'm going to save this as classes. All of our classes are going to go in here until this file gets too big, and then I'll go ahead and break these up into their own individual files, but right now this is totally okay. All of our classes are going to go within classes.js, save it within our JS folder, and now our code is a little bit better organized than prior, but we do need to make sure we're pulling this into our project. And to pull this in, we'll go to index.html, and I think it makes sense to pull this in right before index.js because we might be using placement tiles data or waypoints within one of our classes. So I'll add in another script tag right above index.js, and then instead reference classes.js. So everything should still function the exact same. Let's refresh to make sure it does. Doesn't look like we have any bugs, so great. We do want to refactor index.js just a little further. And the way I'm going to do that is by taking our enemy class all the way from the very top right here on line 43 down below to 82. I'll cut that out of place, and then go into classes.js and simply paste it on in. We want to make sure that we have everything saved, refresh, and our game should still function as expected like it did before. We see our enemies, everything is working perfectly, but our code is going to be a lot cleaner because all of our classes are separated into their own file, and now index.js really just focuses on our implementation instead. Now back to getting these placement tiles to light up whenever we hover over one of them. Now we can just go inside of classes.js, scroll to the top, and find our placement tile class. That's a lot easier than having to search for it within index.js. What we can do is say when we are colliding, when we're console logging out colliding, we're also going to set this .color equal to a value of white. When we assign this equal to a string of white, we're just getting the full opacity color right here, so this will be equal to 1. And it's going to brighten up the whole thing. Let's go ahead and save that, refresh, and then hover over one of these. You'll see that it just brightens up, and all these are actually going to brighten up because we never actually set our color back to its original transparency. So to set it back to its original transparency, after this if, we could write an else that says this .color is going to go back to the string that we have up here. So I'll copy that, paste it within color, save, and refresh. And now when I hover over one of these, yes, it's going to turn white, but as soon as I hover off, it's going to go back to its original value. This is going to work for each placement tile that we currently have drawn onto our game. So the next step is going to be adding in an actual building object whenever we click on one of these tiles that's lighting up. So if I were to click right here, we'd want to go ahead and place a building object. It's going to be a square to start in that exact location. So how do we go about doing that? Well, the first thing we need to do is create some sort of building class. And to do that, within classes.js, we can scroll to the bottom and add in a new class of building with opening and closing curly brackets. So what does a building look like? Well, it's going to have a position and it's going to look rectangular. So here we'll add in a constructor. And we know this constructor for each building we create is going to pass through one argument, a simple object. Within the simple object, we're going to pass through a position that is equal to an x of 0 and a y of 0, just so we can see exactly what position looks like before we call it. And then we want to set this dot position equal to position. Now we could use inheritance to do this by extending the building class, but personally I like to stay away from inheritance just a little bit, especially when games start getting really complex, because it creates for a lot of abstraction and a lot of editing other code that might affect other objects. In this case, I'm just going to stay away from inheritance, at least for the time being. Maybe we'll add it in later, but I just want to let you know that is an option, because this code right here is the exact same as we have right here for our placement tile. Now what would a building look like? Let's add in a draw method that determines exactly that. So building is going to have a fill style. I'm going to make each building have a color of blue so we can separate it from everything else. And then I want to call c.fillRect, which is going to draw a rectangle at an x-coordinate of this dot position dot x, a y-coordinate of this dot position dot y, and then a size, right now 64 by 64. And that's pretty much all we need to get started with a building. So let's head back to index.js. What we're going to do here is right above animate, I'm going to create a constant called buildings. Set that equal to an empty array. So here's how we're going to handle this. Whenever we are currently hovering over one of these placement tiles and we click, we want to say place a building into that buildings array and then render it out. We just need to determine which building tile are we currently hovering over in this moment in time. We're basically going to be setting an active tile let. So let's go back to our code. Right beneath buildings, I'm going to declare a let equal to active tile, and I'm going to set it equal to undefined, just to show that intentionally I don't want anything defined on this until we set it directly. So I only want to set an active tile when I know that I'm hovering over one of the placement tiles. And we know we're hovering over one of the placement tiles within classes.js, specifically at the very top with our placement tile class. Right here within update is where we're currently determining that. But this is being called for every frame currently, and I think there's a better way to do this. We can go ahead and call this only when we're moving our mouse instead. So what I'm going to do is within index.js, we have active tile equal to undefined, but whenever we move our mouse, I also want to call that collision detection code for each building placement tile, and then I'm going to set active tile equal to the exact tile in which we're currently hovering over, but we need to get tile in the first place, and I'm going to show you how to do exactly that. So what we want to do is loop through all of our tiles. And we can loop through all of our tiles by grabbing them with placement tiles dot for each, and say for each tile within this array, we want to call the following code. So within this, we want to call our collision detection code between our mouse, which is being set up above, and the tile we're currently looping over. We know that collision detection code is within classes.js. It's this if statement right here. So I'm going to grab everything within this if statement, hit Command C, and then go back to index.js, and then write a new if statement within this for each that says if the following conditional is true, then within this I want to set active tile equal to the tile we're currently looping over. And then since this tile is being set, this is the one tile out of everything that we're looping over, I don't want to loop over anything else. And if that's the case, I want to call break, which should get us out of this for each loop whenever this is activated. Now the thing is, for each does not allow you to call break. It does not allow you to break out of the for loop. Why? Well, the JavaScript developers just haven't implemented that feature yet. So as a result, we want to refactor this for each loop into a standard for loop in which we indeed can call break. So to refactor this into a for loop, I'm going to call for let I is equal to 0. And I want to say loop through this for as long as I is less than placement tiles length. And then for each iteration, I want to add 1 onto I with I++, This is the exact same thing as we have down below. We just need to select the individual tile that we're looping over. And to get that tile, we can create a const within the for loop that says a const of tile is equal to our placement tiles array. And we want to grab the one individual tile we're looping over by adding in our index of I right here. So now this for loop is indeed the exact same as this for each loop down below. It's a little more verbose, but it's okay because we need this in order to call break like we want to make sure we're breaking out of this for loop and making things as efficient as possible. So I'm going to take this if statement all the way down to break, cut it out, and then delete this old for each. Now I'm going to take that code and paste it within our for loop beneath the constant. And it looks like I'm missing a bracket somewhere. I'm missing a bracket for this if statement. Might have accidentally deleted it. I'll just go ahead and add one in after break, save, and now our code looks good to go. Now this code isn't going to work if we're using this right here because this is only available to us within the actual class. Instead, what we want to do is replace each instance of this with the actual tile in which we're currently looping over. So go ahead and replace that. And now this code should function, but we need to think to ourselves, once we set active tile, it's never going to be unset if we hover off of one of these blocks. So for each time we move our mouse right above this for loop, I'm going to set active tile equal to null intentionally. We want it empty before we actually monitor for collision. And then finally down below, beneath our for loop, I'm going to console log out active tile to make sure that this is actually being set correctly as we hover over the different tiles. So let's save that, refresh, and start moving our mouse around. So you'll see as I move this, we keep logging out null. That's exactly what we want. But once I hover over one of the tiles, now that is being set to the exact placement tile in which we're hovering over. So we know we have an active tile set. When we hover off of it, it goes back to null. Our collision detection code is working, and now we can use this active tile to actually say, place a building when we click on this direct active tile. Let's go back to our code. And then what we're going to do is add in another event listener. I'll just go ahead and add this up above. Make it a little easier to read for you guys viewing. And this time, instead of calling window.addEventListener, I'm going to call canvas.addEventListener. So we're pulling in canvas at the very top of our file. This is one of the very first things we did. But when we declare we want to add an event listener directly onto the canvas object, well, this is only going to monitor for clicks directly on the canvas, not anywhere within the window. So if we click over here, the event's going to fire. But if we click off the canvas, the event's not going to fire. Just a way to make your code a little more robust, make sure that your intentions are exact. So within canvas.addEventListener, we're going to listen for click events on our canvas and add in a second argument, which will be an arrow function. We do want the event object here as well. So whenever we click on our canvas, the first thing we want to do is monitor for if an active tile is set, because we know if there is an active tile that our mouse is currently hovering over that one individual tile. This is basically saying if we're colliding with a tile. If we are colliding with a tile, we want to take our buildings array and then push in a new building at a specific position. So we know a building object takes an argument of an object with a position property inside of it that also has an X and also a Y. So where should we be placing our building on the X-axis? Well, our active tile has all the properties associated with the current tile we're hovering over, including its X and Y position. Therefore, for X position on the building, we can say we want to set it at an X position of the active tile's position on the X-axis. We can do the exact same thing on the Y-axis by saying place the building at the active tile's position, but on the Y-axis. This is going to allow us to place a building, but I don't believe we are rendering out our buildings within our animation loop. And we are indeed not. So right up here within our animation loop on line 57, I'm actually going to go down to line 67, and then add in our buildings, and loop over these with a for each. Let's say for each building within our buildings array, I want to call building.draw. So we'll save that, refresh, and now when we click on one of our tiles, we're going to see that we just drew a building in place. If I click anywhere else, we're not drawing a building because there is no active tile. But if I click on any individual spot where there is a tile, you're going to see we can indeed draw a building in that exact location. Now, the very last thing I would do here is make sure that we cannot draw buildings on top of each other. Because yes, we are colliding with this tile that was there previously underneath. And if I click, we are still adding buildings to our building array. And I can even prove this to you by first getting rid of this console log down below so it doesn't clutter up our console. And then within our click event listener, every time we click, I want to console log out our buildings array just so we can see exactly what is inside of it. So let's save, refresh, and then when I start clicking, you're going to see it's empty But if I click on one of our placement tiles, it starts populating itself, which is great. And now currently we have 7 buildings in place. If I click off of one of the buildings, we still have 7 buildings, but if I click on one of the buildings that already exist, we're still adding a building into that. So we need to prevent that from happening. Otherwise, we might get multiple shots coming from a building at once, which is something we do not want. So here's how we're going to fix this. I'm going to head inside of classes.js, make sure that I'm focusing in on our placement tile class. I'm going to add in a property called this.occupied. So is this placement tile occupied in this moment in time? By default, none of our placement tiles will be occupied, so we'll set it equal to false. But now we can use this property within index.js specifically when we click. So we know we're already assigning an active tile that's available to us. If an active tile exists, yes, we do want to push in a new building to this exact location, but we only want to push it in if the active tile is not currently occupied. So we'll add in an AND statement that says if our active tile is occupied, well, basically is not occupied by adding in an exclamation point at the beginning, then we do indeed want to push in a building. So this is going to prevent us from pushing in buildings on top of each other. So we should be able to push through a building when a tile is not occupied, but as soon as we push through a building, right after that, we want to select the active tile, and then set is occupied equal to true. That way we can no longer call buildings.push for this one individual tile no matter what. So let's save that, then refresh. And now when I click on this one location to create a building, yes, the building is created, but if I click again, you're going to see only one building can be placed there. And we cannot draw buildings on top of each other, no matter how many times we try. So this is great. This is definitely setting us up for success. But one last thing I want to do is make sure that our buildings, these blue little squares, take up the full width of an actual building sprite. So the full width of a building is going to be 2 tiles instead of 1. How can we fix this? Well, it's very simple actually. All we need to do is head over to classes.js and find our building class. For me, it's going to be on line 70, and I know our building width down here is equal to 64. So if I want to be more declarative in regards to what 64 is in that position, I can add in this dot width and set it equal to 64 for our constructor up above. Now that I have this dot width available to us, I can use that within our fillRect function. It says this dot width is still going to be equal to 64, but I know that a building should be twice this size because that's how large our sprite sheet is. So I'll save that and then refresh. And now when I draw out a building, you'll see it takes up the full width of that location in which we might want to draw a building on. So this is absolutely perfect, and this is setting us up for success in regards to getting real buildings on the screen, or at least real sprites on the screen, that are shooting projectiles at our enemy before they reach the very end right here. So back in To Do, we can successfully check off building placement. Now that we have pathfinding and building placement, let's go ahead and start shooting projectiles from these buildings, directing them at our enemies. So in order to begin shooting projectiles, the very first thing we need is some sort of projectile class. So in order to add a class to our game, we're going to go over to our new classes.js file and scroll to the very bottom of this file. So you can create this class at the very bottom of the file. I'm going to create it on line 70 so you can see it a bit better. But this class is going to be called Projectile with an opening and closing curly bracket. And then each class we create needs some sort of constructor function so we can assign properties to each projectile that we create. So what does a projectile need? What does it actually consist of? Well, a projectile is just going to be a small circle that is launched towards an enemy. So if we want to create some sort of circle object, we need some sort of position associated with the projectile. So within our constructor, I'm going to pass through one argument, which takes one property to start. It's going to be position. And I'm going to say that the default for this should be an object with an x property of 0 and also a y property of 0. So now that I'm passing this through as an argument, I can say that this .position associated with the projectile we're about to create is equal to the position we pass through as an argument within its constructor. Now, what other properties might a projectile have? Well, a projectile is definitely going to be moving because we need it to go from the building towards an enemy. And typically if something is moving across the screen, what I like doing is adding in a property called velocity. And this is going to be equal to an object with also an x property. Set that equal to 0 to start, and then a y property equal to 0 as well. Now velocity is going to be determined programmatically, which means I don't have to pass it through within a constructor right here, which is why I'm defining it down below. But this should be all we need to get started with our projectile's properties. So next, to actually draw this out on the screen, I'll add in a draw method And within draw, I want to draw some sort of circle. So to create a circle within Canvas, we're going to reference our context with C, and then I'm going to begin a path. This path is going to be an arc. So to create an arc, I want to reference our context once more, and then call C.arc. So this will allow us to draw an arc, which we're going to use a full 360 degrees to draw a full circle. With this method, we could draw 1/2 of a circle, 1/4 of a circle, but we want to use it to draw a full circle because Canvas does not come with a full circle method by default. So we need to use arc to create that circle. An arc takes a couple of arguments. The first is going to be an x position. So we know our position is being passed through as an argument right here and being assigned to a property. We can grab that property with this dot position dot x and then add in a second argument, which is going to be the y position of this arc. So the y position will be this dot position dot y, which we assign up above. And then the third argument is going to be the radius of this arc. So how large is the circle going to be? By default, I want this to be about 10 pixels large for the radius. And then we need to determine how large should this arc be. Should it be a 90-degree arc, 180, 360 degrees? Well, right here, we're going to say, where do we want the arc to start for this fourth argument? We want it to start at a radians value of 0. And then how far do we want this to extend? Well, we want this to extend the full 360 degrees of a circle. So you might be thinking right here, we can just put in 360, and that means we're going to draw a full arc. But in this case, we need to make sure that this value is not degrees. It actually needs to be radians. So how do we convert 360 degrees to radians to complete a full circle? Well, I'll tell you right now. We need to reference math.pi. That is going to be half of a circle. So to get a full circle in radians, all we need to do is multiply this by 2. So we're drawing our arc from 0 radians to math pi times 2, which just means we're drawing the full length of a circle. Finally, we just need to fill this arc in, which we can do with C dot fill style to determine which color we want to fill it in as. I'm going to say that our projectiles should be orange to help differentiate it from everything else we have going on. And then we want to actually fill this in with C dot fill parentheses. So we have a good blueprint for projectiles that are going to render out as circles on the screen, but now we actually need to get them rendered out into our game. So to render these out, I'm actually going to scroll down to our building class. And what I'm going to do within our building class, specifically within the constructor, is create a property called this dot projectiles. And I'm going to set this equal to an empty array to start. So each building is going to be responsible for managing its own projectiles. That includes rendering them out on the screen, creating them, and so forth. So to start rendering out a projectile on top of a building, within this array, I'm actually going to add in a new projectile, which we can now do because we created the class above. So what does a projectile take? Well, it takes an object as an argument, which has a property of position. So where should we be assigning the position for this one projectile? Well, since we're creating this within our building class, what we can do is, for our x coordinate, we can assign our projectile to have a position of this dot position dot x. And that's going to assign this projectile to the very left side of wherever our building is placed. And then we can do the same thing for y. We'll assign our projectile's y coordinate to this dot position dot y. And now whenever we spawn a projectile, it's going to be placed in the top left-hand corner of our building because we have this dot position available to us whenever we create a building. So each building we create should have one projectile within a projectiles array. Let's go ahead and get this rendered out on the screen. So to render this out, we need to head back to index.js and go inside of our animation loop, which for me is on line 57. So on line 69, I already know that I'm looping through each of our buildings and I'm selecting each individual building. We're drawing out those buildings right here, but after this, what we can do is select our building and then grab its projectiles. And once we have its projectiles, we can run for each and say for each projectile within the building projectiles array, we want to call the following arrow function. And now that we have each projectile object available to us, we can simply call .draw, which should in return draw the projectile out onto our canvas. So let's go ahead and save this, and then head back to our game, refresh, and now when we click and draw a building, you're going to see a projectile is now created with it. Perfect, that's exactly what we need to start. But when we're shooting projectiles from buildings, it doesn't really make sense to have the projectile start from the top left-hand corner of the building. We actually want this to shoot from the center of the building instead. So how, by default, would we move our projectile from here to the center of our building? Well, let's find out where we are actually creating projectiles. It's going to be in classes.js, specifically right here on line 92 when we just added in this new projectile to our projectiles array. So we no longer want this to be in the top left-hand corner, which is associated with our building with this dot position. Instead, we want this spawned in the center of our building. So what we can do is, right beneath the width, we can add in a property called this dot center. Set this equal to an x and also a y value. So what would the x value be for the center of our building? Well, we can reference this dot position dot x to get the very left-hand side of our building, but to get the center on the x coordinate, we would add on this dot width divided by 2. So this dot width is available to us because we assigned it up above. We're saying that we want to add onto this a value of 64 because this dot width is equal to 128. When we divide that by 2, we get 64. Should mean that our center is going to be right in the middle on the x-axis. Now for y, we want to do something very similar. We want to assign y equal to this dot position dot y. That's going to be the very top of where this building is drawn, but we can get the center by adding on this dot height divided by 2. Now it's important to note we never actually created this dot height, and if that is the case, right beneath the width, we can add in a property called this dot height and set this equal to 64 because we know our buildings are not taking up 2 tiles, they're only taking up 1. And now we have this dot center available to us, which we can now use when spawning a projectile. So instead of referencing this dot position dot x, I'm going to reference this dot center dot x. Same thing for y, I'm going to reference this dot center dot y instead of position. So let's save that, refresh, and then create some buildings. Now you'll see that our projectiles are spawning from the center of our building rather than the top left corner. So the next thing we want to do is get this projectile moving towards an enemy that we have moving across our screen. So how would we go about doing that? Well, we want to do the exact same thing that we were doing between our enemies and our waypoints by calculating the sine and cosine values and assigning those to our enemy's velocity. But in this case, we're going to be assigning those values to our projectile's velocity instead. So a quick recap for you, we're going to go ahead and create a right triangle between the 2 points in which we want our projectile to travel to. It's going to look a little something like this. Once we create this right triangle, we want to get the angle associated with this right triangle. Once we have that angle, what we can do is plug that angle into sine and cosine functions. We'll go ahead and say theta is going to be the angle right here. And once we get these sine and cosine functions, we can assign the results to the velocities associated with this one projectile right here. Cosine is going to go to our x velocity, and sine is going to go to our y velocity. And that's always going to make sure that this projectile is moving in the right direction towards whichever point we specify on our enemy. So first thing first, we need to get this angle right here between our projectile and a specific enemy. So we'll head on over to our projectile class right here, and I'm actually going to add in an update function, because this is going to update all the values associated with this one individual projectile we want to update. So whenever we call update, we want to make sure that we call this .draw. It's going to actually draw out our projectile, and now we can start editing our values. Let's go ahead and create a const called angle. This is going to be equal to the theta angle that we're getting right here. So to get that angle, we're going to reference math.atan2. So remember, atan2 takes the distance on the y-axis and the distance on the x-axis as its argument. So what is the distance on the y-axis between this one individual projectile and the enemy in which we want to go towards? Well, let's go ahead and calculate it. To grab an enemy in which we can start pushing a projectile to, we can reference our enemies array. And then I'm just going to reference the very first one to start. We're going to go ahead and fix this and populate this dynamically later on. But just to get this code working, we'll populate it with enemies bracket 0 to get the very first one. With our enemies selected, we know we want its position on the y-axis. Now all we have to do is subtract this dot position dot y, which is going to give us the y distance between this enemy and the actual projectile which we're currently dealing with. But we do need a second argument, and this is going to be the distance on the x-axis. To get this, we can simply copy the statement in which we just put in, paste it as the second argument, and then all we need to do here is swap out the y values with x. So make sure these x values come in as a second argument. That is just the way atan2 works. But now whenever we spawn a projectile and call update, this angle between the enemy and the projectile should be available to us. That means we can select this dot velocity on the x-axis and set this equal to math.cosine with the angle we retrieved as the argument. It's going to make sure that we're always pushing our projectile in the right direction on the x-axis so that it goes towards the enemy. We're going to do the same thing for the y-axis. So I'll select this dot velocity dot y, set this equal to math.sine, and then pass through the angle in which we're retrieving right here. So this is going to produce the perfect ratio between x and y that pushes our projectile towards the enemy. the last thing we need to do is set this .position.x to always be incremented by this .velocity.x. So for each frame, we're adding on the current velocity retrieved from this equation up above. We want to make sure we're doing the same thing for this .position.y. For each frame, we'll add on this .velocity.y. And we know we're using the position that we assign right here within our actual draw function, which is going to give the illusion of this moving in the correct direction. So we want to make sure that we save this, but we also want to make sure that we're calling update and not draw within index.js for each projectile. So right here, previously we didn't have an update function, now we do, so we'll call update instead. And let's save this, and then go back to our game, and then create a new building. So as soon as I create this building, you're going to see that our projectile is automatically moving towards the position associated with the very first enemy. And each time I create a building with a new projectile, you're going to see that these are following that very first position right here. Now, it doesn't really make too much sense, in my opinion, to be going towards the top left of an enemy. Instead, we want the projectiles to be going towards the center of an enemy. So this is something that we can fix within classes.js. Whenever we're calculating this angle, instead of getting the angle between the enemy's top left position, which we're currently doing by referencing the position values right here, we can instead replace position with center in both locations. Now, if we're going to replace that in both locations, we need to make sure that our enemy's class actually has a center property available in it. So let's scroll on up till we find our enemy class. It's right here. And indeed it does. So just by replacing position with center within this equation, we should be getting our projectile moving towards the center of an enemy rather than the top left corner. So we'll save this, refresh, and then create some buildings. Now all of these should be moving towards the center rather than the top left. And indeed they are, so perfect. Now the very next thing I would do is make sure that I can remove these projectiles whenever they touch an enemy. So we could run some circular to rectangular collision detection right here because our projectiles are circular and our enemies are rectangular. But in this case, it's going to be a lot easier to just make our enemies circular and run collision detection on that, so we don't have to write any extra complex code right here. So the first thing I would do is swap our enemies out with circles, and we're going to do this anyways when we replace our enemies with sprites, so let's go ahead and do it now. Let's find our enemy class. I'm going to scroll up to line 29, and there it is. And to replace this with a circle, I'm going to comment out c.fillRect, and beneath this, I'm going to begin creating an arc. So to create an arc, I can do that with c.beginPath, and then call c.arc. So I want to challenge you to try drawing your own arc right here. Pause the video, see if you can do it. Otherwise, let's do it together. So for the very first argument right here, arc takes this .position.x. The second argument is going to be the y position of this arc, which we can get with this .position.y. The third argument is going to be the radius associated with the arc, so we'll reference this .radius instead of a static value. But if we want to reference a property like this, we need to make sure that we create that property within our constructor, which I'll do with this .radius, and set this equal to, I don't know, let's say 100 to start because that is the size of our width and height. And then, next to that, we need to declare where should this arc start. I want this to start at a radians value of 0, and then go all the way to a radians value of math.pi times 2 to complete a full circle. Now I just need to fill this arc in, which I can do with c.fill, and now we should have a circle instead of a rectangle associated with our enemies. Let's save this, refresh, and watch as our enemies come. So there are our enemies, and right now they are very big, and they're not really traveling from the center because I don't believe we declared the center to be where we should draw our arc from, which indeed we did not. So let's change position right here for x and y to the center we declared up above. And then also let's decrease the radius from 100 to 50. That should actually give us a full diameter of 100 right here, so that makes sense. When we refresh that, that looks a lot better. The enemies are closer to the size in which we had them earlier. So I'm going to go ahead and stick with this for our new enemies. So what's going to happen next is whenever we create a building, it's going to shoot a projectile. And once that projectile touches the outer rim of one of these enemies, we're going to splice out that one individual projectile and remove it from our game altogether. So to detect for collision, we'll head on over to index.js and begin writing some collision detection when we actually have a projectile available to us. So to write some collision detection code between two circles, we need to get the distance between the two. So that means the distance between this point all the way to the very center of the enemy. And to get this distance right here, we need to get the y difference and also the x difference between the two. Once we have these two values, we can plug them into an equation and get the distance of this right here. Let's just say it's something like 20. So what equation do we have to use to get this value? Well, it's going to be something called math.hypot. So right here where we're looping through our projectiles, let's create a const called distance. I'm going to set this equal to math.hypot. It stands for hypotenuse, which is just a fancy word. Basically just means the long side right here in which we assigned it 20. But math.hypot takes the difference on the x-axis for its first argument and the difference of the y-axis for its second argument. A little confusing compared to math tan 2. But we can get the x difference by creating a const of x difference or distance, doesn't matter what you call this really, and then grabbing an enemy's position on the x-axis and subtracting a projectile's position on the x-axis. So we definitely have a projectile available to us, but what we don't have is an enemy available to us. That is only available up above when we're looping through enemies.for each. So we need to find a way to get the enemy which a projectile is associated with. And an easy way to do that is to simply prefix enemy with projectile.enemy. So what's going to happen here is each time we create a projectile, we're going to assign a specific enemy in which that projectile should be moving towards. The enemy is going to be assigned to an enemy property. Therefore, when we're referencing a projectile, we can reference that enemy's position to make sure that we're always monitoring for collision correctly between our enemy and also our projectile. But if we want to use the style of code with projectile.enemy, we need to make sure within classes.js, we find our projectile class and then add in a property of this .enemy. And this is going to be equal to whichever enemy we pass through its constructor. So we need to make sure that we declare an enemy argument and then find wherever we are actually creating a projectile. And that is going to be down below within our building class. So right now we're creating a projectile right here. Now we can also pass through an enemy property, which we are going to assign dynamically within our building class, but for now, we'll just grab our enemy with enemies 0. It's going to give us the very first enemy within our enemies array, but now the enemy's position will be available to us directly within the projectile that we create. So let's save this. Make sure that we also have index.js saved as well. And now we should definitely be getting the x difference. If we want to test this out before writing any more code, we can comment out distance, then console log out x difference, and then create a projectile within our game. So let's save, refresh, and then open up our console. And we should see when we create an enemy, the distance between the projectile and the enemy. So great. That is looking good. Let's take care of things for the y-axis as well. So I'm going to duplicate line 75 of this x difference, and then call this y difference instead. So to get the y difference, we're going to reference our projectile enemy position.y, and subtract from that the projectile position.y. And this code is almost completely correct, but we do need to make sure that when we're referencing an enemy like we are right now, that we're referencing the enemy's center, because that is where we want to begin monitoring for collision for. We don't want to monitor for collision from the top left-hand corner of the enemy. So whenever we're referencing enemy, we actually need to reference the center, not just the position. For our projectile, yes, we can definitely reference our position, because since we're drawing an arc, that arc by default is drawn from position x and y. We don't actually need to move this value to create some sort of different center value. So that should make sure that the x difference and y difference is correct, and now we should be able to use them within this math.hypoth function. So the very first argument is going to be the x difference, and the second argument is going to be the y difference. And now, distance will give us the 2 points between our enemy and our projectile. So let's console log out distance and see what that looks like. And I'm also going to do a command F for console log to make sure that I'm deleting any other console logs that I don't want muddying up our code. So I'll delete console log in all those other locations and just keep distance right here. And I'll also check classes.js real quick to delete any other console logs that might be in here. And there is one. Save that. Save index.js. And then refresh. Right-click, inspect element, and then open up the console. And now, when I create a projectile, you're going to see the distance between our projectile and the center of our enemy. And that's trying to get as close as it can to 0, but it's just a little slow, so it's kind of lagging behind. And you can see it's getting closer and closer each time it takes a corner turn. But we went all the way from the very top, all the way from something like 300 pixels of distance, down to about 6 to 1 to 0 pixels. So we know we're getting the distance correctly, but now we need to actually remove this projectile once it touches the edge of an enemy's circle. So with this distance, we can say if the distance between these 2 points is less than the radius of the enemy, which we can get with projectile.enemy.radius, plus our projectile's radius. So projectile.radius, that we know the edges of the two circles are touching, and that we want to remove the current projectile from the scene. So to remove the current projectile, we can select our building that we're currently looping over up above, grab its projectiles array, and then call splice. Where do we want to splice this from? Well, we need some sort of index from our for each, which we can add in with comma I. That'll give us the index. And now we can use it to say at this one specific index of I, remove one value from building.projectiles. But we always need to make sure we're looking at our code closely. We're referencing .radius right here on our enemy, which we know we added in previously. But did we add a radius onto our projectile class? Let's go and check it out. So within classes.js, let's find our projectile. It's on line 73 for me, and I don't see anything related to a radius. So it's very important that we add this in here, otherwise that function might not work. So here, I'll add in this, .radius. And what is the radius of each projectile currently? Well, right now it's a static value of 10, so we can assign radius equal to 10, and then make sure when we're actually drawing our arc, we're referencing the property up above. So we'll do that with this .radius. And now, within index.js, this if statement should definitely work. We should be splicing out a projectile once it hits an enemy. So we'll save this, refresh, and then draw a building. Once that projectile touches the very first enemy, it should be removed. And there it goes. So this is looking great. But one thing I do want to note is since we're looping from the front of an array using .forEach right here, we might have some bugs later on. If you're using splice within forEach, you're basically introducing the potential to add bugs to your game. The bug you might deal with is basically a flicker across all your projectiles. So why does that even happen in the first place when using splice within forEach? Well, since forEach loops from the very start of an array, we're going to start from right here and go towards the very end. If we were to call splice on this projectile right here, we're going to go ahead and cut it out completely. What that's going to do is basically move these two remaining projectiles back one index. So basically we would be skipping over the rendering process of this projectile because once we increase the index within forEach to go to the next item within the array, we're basically saying only render out this last remaining projectile because this one got skipped over due to the removal of the previous one. And since this one did not get rendered out, it introduces a flicker, which basically just makes your game look really jank. So as a result, whenever you're using splice within a forEach loop, I recommend swapping out forEach with a traditional for loop that loops from the back. Why would we loop from the back? Well, let's say that we're looping from the back and we're rendering in this direction. We're going from left to right. We're going to render out this first one, and then we're going to splice out this third projectile. If we were to splice that out, yes, this last item in the array would be shifted over to that current position. But the thing is, we already rendered this item out, which means when we go to the next index, we go to the very next item available to us, and there isn't going to be any flicker because we're not skipping over any projectiles within our array in the process if we're looping from the back. So let's make sure that we don't introduce any bugs in the future by swapping out our forEach right here with a standard for loop that loops from the very back of the array. So to swap this out for a for loop, I'm going to write for let, and I want this to start at the very last index within our array. So I is going to be equal to our building dot projectiles dot length -1. That's going to give us the very last index. And I want this to run for as long as I is greater than or equal to 0. So once we hit the very first item within our array, we're no longer going to run this loop. But for each iteration of this loop, we want to subtract 1 from I. This just means we're going to hit every item within that array from the very back. And then we just need some opening and closing curly brackets. So with this for loop, I is going to be available to us, similar to like it is within this for each, but we do need a projectile. To grab a projectile within this for loop, we can create a const called projectile and set this equal to our building dot projectiles. That'll give us that array, and then select the index in which we're currently looping over from the back. And that's going to give us the very same thing in which we see down below, just in a different format that is going to be bug-free. So let's delete to line 72. And then I'll also delete the closing curly bracket and parentheses associated with that for each. And I just want to add in an ending curly bracket and make sure that I get rid of this curly bracket right here. This is going to be replaced with this ending curly bracket I just added in. And your code should look something like this. So let's save this, refresh, and make sure that our projectile is still being removed once it touches an enemy, which indeed it is. So great, our code still works, but it's going to help prevent us from running into bugs in the future. Now we might want to speed up the speed in which these projectiles move, and we can do that really easily. Let's go ahead and find our projectile class within classes.js. And down below, where we're assigning a velocity based on cosine and sine, we can basically multiply this by a value that's larger, such as 5, maybe even 10, and what 5 represents is the power in which we're adding on to our x and y velocity. We can even create a const called power, set it equal to 5, and then replace 5 in these two locations, just so we know exactly what 5 means. So we're multiplying that by power, and it should speed up our projectiles, and all of our code should still function as before. Let's save this, refresh, and then click. It's definitely moving faster, but is it getting removed? Yes, it is. So no issue with that, looking great. Now the very next thing we want to do is spawn multiple projectiles, but make sure that we can only spawn projectiles if our buildings are within a specific range of our enemies up here. How would we go about doing that? Well, first, let's add on a radius to our building. So at the very bottom, right here within our constructor, I'll say that this dot radius is equal to around, let's just say 250. So our building radius is going to be 250. This is basically the radius in which we can select enemies to shoot projectiles at. Once an enemy is outside of this radius, we will not be allowed to shoot projectiles at them. So we have radius available to us. Let's see what this radius looks like by adding in an arc. So we can do that with c.begin path, and then call c.arc. We can reference this .position.x, this .position.y. Third argument is going to be the radius in which we just created, which we can grab with this .radius. And then we know we want to start from a radians degree of 0 and end with a radians of math.pi times 2. And we always need to take in consideration we are using a center right here for our building, so we don't really want this arc to start at the top left of a building, but rather the center, so we would replace position with center instead, and then we can call c.fill to fill it in. Now I want this arc to be a little bit of a different color from the actual building, just so we can better differentiate what is the building and what is the arc in which we can begin shooting enemies. To do that, right before fill, we can add in a c.fill style, and set that equal to an RGBA value, which will allow us to give this some transparency. So red is going to be a value of 0, green is going to be a value of 0, and then blue is going to be 255 to make sure that it's as bright as possible. But I do want this to be transparent. To make it transparent, I'll say that its alpha value is going to be 0.2. So let's save that, refresh, and then draw a building. And now we have a radius associated with each individual building. So these are basically locations in which we can start shooting at an enemy. Once an enemy runs in to this radius right here, we're going to select an enemy, and then we're going to target that enemy until they move out. So if the enemy is no longer available to us, then we'll select the next enemy in line, and if no enemies are available to us, then we're not going to do anything. This building will not be allowed to shoot. But how do we go about selecting enemies and shooting projectiles at them non-stop? Well, basically each building we create is going to have a target associated with it. This is what we're currently shooting at. So we have some sort of target associated with the building. We'll add that in with this .target, and this isn't going to be equal to anything to start. We're going to generate this on the fly for each frame in which our enemies are moving through our building's radius. So to generate this on the fly, we can head over to index.js, find where we're looping through our buildings, and then for each frame of each building, we can say that building.target is going to be equal to null. So we're always going to make sure that this is empty before we try setting it. To set this, we need an array of enemies which have the radii overlapping with our building's radii at the same time. So if our building is overlapping with an enemy, we're going to set building.target, but we need to find which enemies those are. So to find those enemies, we can create a const of valid enemies. So these are the enemies in which we're going to be able to shoot at. We can get these by selecting our enemies array and then calling filter on this. So this takes an arrow function as its argument, but basically within filter we can say for each enemy within our enemies array, we'll call the following arrow function, and this is going to return a value. It's going to be either true or false. If this value is true, we're going to remove this enemy from our enemies array, and it will not be stored in valid enemies. But if it is true, we will be storing that enemy here, which means that we can use it and set building target equal to the very first result in here. So basically, we want to test if this enemy we're currently looping over within our enemies array collides with our actual building radius. To grab that circular collision detection code, we can go down below to line 78 and grab the exact code in which we're using to test for collision between our projectile and the enemy. I'll grab these 3 lines, paste them up above within our new filter function, and then we just need to do a little bit of refactoring. So we don't want to test for collision between our projectile dot enemy, but rather the current enemy in which we're looping over. So I'll delete projectile dot in those 2 places, and we're detecting not for our projectile, but rather the current building in which we're looping over. So this will give us the distance between our building and also our enemy. And if this distance is less than the radius associated with an enemy and a building, then we're going to go ahead and return true or false. So with return right here, we can say if distance is less than our enemy radius plus our building radius, we know that the two are definitely overlapping. That means this is going to equate to true, which means any enemies that are overlapping will be stored within valid enemies. Let's go and test this out by console logging out. Valid enemies, we'll save that. Head back to our game and refresh, and then place a building. And it looks like we have this other console log going on right there. Let's get rid of that. Looks like it is this down here on line 88. I'll get rid of console log distance. But before proceeding onwards, we always want to look at our code real quick to make sure that everything is set up correctly. So we're definitely referencing the center of our enemy because we're using .center. But in this case, a building is square, and therefore we need a position .x and a position .y. But we want to reference the center of our building for this collision detection because that's where we're drawing the radius from. That means we want to get rid of position right here in these two locations, and replace it with center to make sure that our collision detection code is as accurate as possible. So let's save that, refresh, and draw out our building. And now you'll see over here, no enemies are overlapping with our building radius. But as soon as one enters, now we have one enemy, now we have two enemies, and now we have three enemies. And this is just going to keep increasing for as long as enemies keep entering this little radius right here. And as soon as an enemy leaves, maybe this one will leave completely over there, you're going to see that it decreases. So we have full collision detection code monitoring for each building, whether or not an enemy is within its radius. If an enemy is within its radius, that is going to mean that we can start shooting projectiles at that enemy that's currently in here. So the last thing we need to do regarding setting a target for our building is right beneath this valid enemies code in which we just wrote. I'll go ahead and say that our building.target is equal to valid enemies bracket 0. That's going to give us the very first enemy that is within this array. If nothing is there, well, building target is just going to be equal to null or undefined. So I'll delete this console log, and now all we need is a way to make building start shooting continuously at this one target in which we're selecting. So over in classes.js, we're going to focus in on our class of building. Right now we're creating one projectile whenever we create a building. We're no longer going to be creating projectiles this way, but rather based on a timer. So I'm going to add in a property called this.frames for each building we create, and this is going to be equal to 0 to start. Now for each time we call update, I want to increase this value by 1. We don't actually have an update function in place for our building just yet. Let's add one in. I'll say that our update function should go ahead and call this.draw. And each time we call update, we're going to call this.frames and add 1 onto it with a ++. So now what we can do is we can write an if statement that says if this.frames modulo, let's say 500, is equal to 0, then we want to push in a new projectile into our projectiles array. So basically what this is saying is take the current value of frames. If we divide it by 500 and the remainder is equal to 0, then we want to call the following code. So basically for every 500 frames, we're going to create and push in a new projectile. So we can grab this .projectiles and then push in a new projectile right here. So up above, I know by default, I don't want a new projectile pushed into our projectiles array. Therefore, I'll cut out our new projectile right here. Make sure that this .projectiles is empty, which it is. And then with that cut out new projectile statement, I'm going to paste it into our push code right here. So now for each 500th frame, we're going to create a new projectile, but the enemy is not going to be equal to the very first enemy within our enemies array anymore. Instead, we're going to use this.target, which we just selected earlier. And really, we should only be pushing in a projectile in the first place if this.target exists. If this.target is equal to null, well, the building doesn't have anything selected. It should not be shooting a projectile. Therefore, within this if statement, I'm also going to add an and that says if this.target exists, then I do indeed want to run the following code. We're going to shoot a projectile at the enemy of this.target. And before testing this, looking at it, I believe 500 might be a little too much. Let's actually decrease this to every 100th frame to make sure that we're actually shooting things consistently. So I'll change that. And the very last thing we need to do is make sure that we're no longer calling building.draw, but rather building.update. So we call all this code right here. So to call that, we'll go to index.js, find building.draw. For me, it's on line 67, and then call building.update instead. So we'll save this, and then move back to our game, refresh, and then create a building. You're going to see once an enemy enters this radius, we're going to start shooting at it. So it enters, we select it, we start shooting, and when it exits, it should theoretically stop. Let's see if it does. And no, it looks like we are still shooting towards our enemy even though it is outside the radius, and we should be selecting a new one. So we're going to have to do a little bit of debugging here. Hopefully we can solve it quickly. Now I do recall earlier on, we selected enemies 0 somewhere else, and I believe it was within classes.js. So let me do a quick Command F within classes.js for enemies. And indeed, I did reference enemy 0. So this is what's messing us up currently. Right now, when we're determining the angle, which determines where a projectile should be shot at, we're only determining that angle based on the very first enemy within our enemy's array. But now we know we're populating our enemies dynamically and assigning an enemy equal to the property of this.enemy above. Therefore, we don't need to reference enemy 0 in this location right here, which determines the angle. Instead, we can reference this.enemy.center x and y, and that should make sure that our projectile is always going towards the right enemy. Let's save this, refresh, and then try this one more time. So I'll create a building, and then once an enemy enters it, we're going to start shooting at it, and once this enemy leaves, we should select a new one, which indeed we do. So we're only selecting enemies which are within the radius of our actual building, and none of these enemies up here are being selected because we coded this out correctly by selecting the enemies based on the radius of our building. And one of the cool things is, this will work for every building that we create. So each building we have with this radius, we're only going to be able to shoot at enemies that actually overlap with our building's shoot radius. So once these enemies leave, we can no longer shoot them. You're going to see eventually, once our enemies completely move out of these radii, just nothing will be shot at all because we no longer have the ability to push out projectiles. And there's the last one, and now nothing can be shot at until some of these overlap over here. So I think with this, we can go back to do and check off shooting projectiles. Next, we're going to focus on health bars. So we'll have our enemy, and we're going to add a bar right above them. This green bar is going to represent how much health does an enemy have. And then, as we hit enemies with projectiles, the size of this bar is going to decrease. And behind it, it's going to reveal a red bar. And once the green bar completely runs out, we're going to remove the enemy from the scene completely. So how do we go about creating this green and red health bar for each enemy that we have within our game? So the first thing we're going to do is head on over to classes.js and find our enemy class. So for me, that's going to be on line 28, and I want to focus in on our draw function right here. So draw currently is responsible for drawing out our enemy. It's just a circle. We want to add some additional draw code here to draw out our enemy's health bar. So I'll add a comment that says this is going to be our health bar right here. And how would we draw a health bar? Well, we need to draw some sort of rectangle above our enemy. And to draw a rectangle, we can use c.fillRect. So fillRect takes 4 arguments. The first one is going to be the x position, so we'll get that with this.position.x. The second argument is going to be the y position, which we can get with this.position.y. The third argument is going to be the width of the health bar, and I just want the width of this health bar to be the full width of our enemy, so I'm actually going to use this.width right here. And then how tall do I want this health bar to be? Well, I don't want our health bar to extend the full height of our enemy because that would just be really large. I just want this to be some sort of static value that's never going to change. So I think around 10 pixels is going to be a good value for this. Now, what color should a health bar be by default? Let's start with the overlaying part of the health bar, which is going to be green. To make sure that this health bar is green, we can add in a c.fillStyle, set this equal to a string of green. So just with this, if we save this and then refresh, we wait for our enemies to start coming out, you're going to see now they have some sort of health bar associated with them. So our health bar is touching our enemy currently. Let's make sure that we have a little bit of space between the health bar and our enemy. To make sure that we have that spacing, we just need to subtract from position.y, because this starts at the very top of the enemy currently. So if we subtract something like 15, we're ensuring that we're subtracting the full height of our health bar, plus a little extra, so 5 pixels worth of space. Should give us the exact look we're going for. We'll save and refresh and then wait for enemies to come out. And I think that is in a good position. So next we're going to draw an additional part of this health bar. We're going to be drawing a red bar that is placed directly behind this green bar. So that way when we decrease the width of the green bar, we're going to see that red health bar in place. It helps us understand how much health an enemy has left. So to draw that additional health bar, we're going to copy these 2 lines of code and paste them right above their current position, but we don't want to draw another health bar with a color of green. we want to start drawing a health bar with a color of red instead. So we're going to draw out this red health bar in the same exact position as the one we just drew, but then we're going to be drawing on top of that with this green health bar instead. So that means when we decrease the width of this green health bar, we're going to reveal the red health bar behind it. We can see that this works by decreasing the width of this green health bar. Let's go ahead and decrease it by something like 20 pixels. Save and refresh, and now we should see our red health bar extend the full width of our enemy, which it does. And we only have a little bit of the green health bar extending. This is great to help us understand how much health an enemy has left. So the next thing we need to do is make sure that we're decreasing this green health bar whenever a projectile actually shoots and touches an enemy. So to do that, we're going to extend the full width of our green health bar back to the full width of our enemy, and we're going to add in a property to our enemy class called this.health is equal to 100. So by default, every enemy we create is going to have a health of 100 to start, and then as a projectile hits an enemy, we're going to decrease this value right here, and then we're going to determine based on that value what the width of this green health bar should actually be. So first, let's start decreasing this value right here, this .health, whenever a projectile hits an enemy. Let's save classes.js and head on over to index.js. We're going to want to scroll down until we find out where a projectile hits an enemy. And for me, it's going to be on line 85 within this if statement. We can even comment this out to make this a little more apparent in regards to what this does. This is when a projectile hits an enemy. So once a projectile hits an enemy, what we can do is select the enemy in which a projectile hit, which we can get with the current projectile's enemy property. So once we grab the enemy, we can grab its health property, which we just added on, and then subtract equal 20 from the current value. So each time a projectile hits an enemy, we're going to subtract 20 from the health. Let's console log out the projectile enemy health to make sure that this is indeed working, because we're not going to see anything rendered out until we begin using this health property directly within our class. But let's save that, open up our console, refresh, and then I'm only going to create one building. And once this starts shooting at this enemy right here, we should see its health start to decrease. So it's going to shoot once, the health decreases to 80, then down to 60, and it's going to keep decreasing for as long as that enemy is being hit. And each of these enemies have their own individual health associated with them. As you can see, we're getting different values whenever a projectile hits a different enemy. So great, we know that's working. Now we can use that health property within classes.js to determine the width of our green bar right here. So we know this is the width of our green health bar. What we can do is we can multiply this by a percentage value based on this .health. So this .health is going to be equal to 100 to start, but if we divide this by 100, the full value of our health, we're going to return some sort of percentage value which we can multiply by the actual width of this green bar right here. So hypothetically, let's go ahead and say this .health right here is equal to 80. We just hit the enemy. We divide that by 100. What are we going to get? We're going to get 0.8. When we multiply this .width by 0.8, let's just say hypothetically this .width is 100. We're going to get a value of 80. So basically, we just took 1/5 off the health bar, and then we would run this again. We'd hit an enemy, say our new health is 60 divided by 100. Well, what is 0.6 times our width of 100? Well, that's going to give us 60. So it's going to keep decreasing until we go down to 0 and tell it to stop. So let's save this and see it in action. I'll refresh, and I'll exit out of our console over here, create a building, and now we should see this health bar, at least the green part of it, start decreasing whenever a projectile hits an enemy. So it's decreasing slowly and slowly, and it's just going to keep going. I'll create another building right here so we can keep hitting this first enemy. It's just going to keep going forever and ever. You'll see it starts even going to the left a little bit. We don't want that. But we're going to say whenever this health bar, the green health bar right here, has a value of 0, we want to remove this enemy from the scene. We're no longer going to be seeing this weird little health bar effect going on in the first place. So we essentially need to write some sort of conditional that tracks for our enemy's health. We can do that when we're listening for when a projectile hits an enemy. So we're going to subtract 20 from the enemy's health, and then right after that we can write a conditional that says if the current projectile's enemy.health is less than or equal to 0, then we want to splice out this specific enemy from our enemy's array. So how do we splice this out when we don't have the enemy index available to us, at least within this specific portion of code? Well, based on the enemy we have right here, we'd want to find the index using a findIndex method. So we can get that by selecting our enemy's array, and then calling findIndex on top of this. So this is going to take an arrow function for an argument, and here we can pass through which enemy we're currently looping over. So we're going to say we are looping over this current enemy, and this is going to return a value of true or false. So if the current condition is true, we know the index of the enemy in which we want to select. So what condition do we have to write to make sure that this enemy we're looping over is equal to the projectile enemy in which we want to remove from the scene? Well, we can simply write if our projectile enemy is equal to the current enemy we're looping over. We're going to return that index and store it in a const of index. We can even call this enemy index if we want to be a little more specific. But now this should be available to us, and what we can do is call enemies again, then splice, and splice out from the enemy index we just retrieved one value from that position. So let's save this, refresh, create some buildings, and then start trying to remove some enemies. So we're going to start launching projectiles at this first one, and once it hits 0, we just remove it completely. Now there might be a bug introduced here. Can anyone tell me what it is? Well, sometimes other enemies might be removed even though we didn't specify we want these exact enemies removed. So why would they be accidentally removed? Well, right here, so find index, if this returns true, well, it's going to give us the exact index of the enemy we want to remove. But if this returns false, enemy index is going to be equal to -1. If we try call enemies.splice on -1 to 1, this might error out. So we want to make sure that we add an if statement here that says if the enemy index is greater than -1, then we do indeed want to splice out an enemy from this enemy index. Now, why might we not be able to find an index associated with our enemy's array? Well, sometimes when our projectiles are launched towards an enemy, the enemy is removed before the projectile actually hits. So if the enemy no longer exists and we're trying to run it within our enemy's array before we actually splice it out, enemy index might return a value of -1, meaning it was not found. Therefore, we do not want to splice anything when that happens. So as long as we add this if statement right here, our code is going to be robust. We should not get that issue with random enemies being removed. So let's go ahead and save, refresh, and try this one more time with a couple of buildings, just to make sure that no random enemies are removed throughout the process. We're going to completely destroy all these enemies, create a lot of buildings to make sure that they go quickly. And it looks like nothing is being removed that shouldn't be removed. So this looks great. How else would I make sure that this code is as clean as possible? Well, since we are using splice right here on our enemies array, we need to see how are we rendering out enemies in our game? Are we using a traditional for loop, looping from the back of an array, or are we looping through the front using a for each? Let's go ahead and find out where we're looping through our enemies. By scrolling up, we are indeed using a for each. So since these are being spliced out of the array on the fly, we want to make sure that we switch this over to a traditional for loop, but one that starts from the back of the array. If we don't want to write this whole for loop out again, we know that on line 78 that we're looping from the back of our building projectiles array. So we can grab this line, paste it right above line 59 where we're calling .for each, and then add in an ending curly bracket. Then we can start refactoring this so it matches up with the actual for each right here. So we want to loop through not our building projectiles, but rather our enemies. And now we have to select an enemy manually, so we'll create a const called enemy, and set this equal to our enemies array, and pass through I as the index so we can get that one exact enemy we're looping over for this iteration of the loop. So now that enemy is available to us within here, we don't have to call this for each anymore. We can simply call enemy.update based on the enemy we're getting. And now when we're splicing items out of the enemy's array, we shouldn't have any weird flickering that might occur because we're looping from the back instead of using a for each loop. So we'll just do one more quick save, refresh, and just make sure this works one more time with that new for loop. So our enemies should be rendered out, which they are. Our shooting still works, and they are removed from the screen completely. We don't have any issues, and we can even right-click to make sure that we don't have any bugs in the console. And it seems like we are completely good to go. So that's going to allow us to head back to To-Do and check off health bars. So next in line is Sprites, but I'm actually going to switch this up a little bit. I'm going to move stripes to the end, right before launch, because I think it's more important just to get all of our main game functionality out of the way before we start adding in cool images and animations. So instead, I'm going to focus on waves instead. So I'm not talking about ocean waves here, I'm talking about waves of enemies. What happens when we go ahead and kill off that first wave? Well, we want to spawn out another wave of enemies, another grouping per se, to make sure that our game keeps on going for however long we specify. So how do we go about creating more groups of enemies whenever we kill off that first round, that first wave? Well, let's find out where we're spawning enemies in the first place. It's going to be in index.js on line 42 down to 49. So this for loop right here spawns 10 enemies, at the exact position we want them to start at, and then they're going to start updating towards the waypoints that we wrote within our map. So basically the algorithm here is we want to listen for when our enemy's array is back equal to 0, then we want to run this for loop one more time. And we can either run it as the exact same, meaning we're going to spawn 10 more enemies, or we can increase this value right here to say we want more enemies spawned to make our game even harder. So if we're going to use this for loop somewhere else, it makes sense to refactor this into a function. That way we're not duplicating code and editing things in two places, even though they do the exact same thing. So to create a function for this, right beneath it, I'll write a function called spawn enemies. And what is this actually going to call? Well, simply this for loop right here. So I'll take this for loop, paste it into the function, and I know by default I want to call spawn enemies as soon as this file loads, so that we always have 10 enemies coming in from the left by default. So now that this is within a function called spawn enemies, this is not called by default, until right beneath this, we actually call the function name, spawn enemies. So this should make sure that our code functions as is. Let's save and refresh and make sure that our enemies are coming in from the left. All we need to do is see 1 and then 2, and we are good to go. So that still functions as expected, but now we can use the spawn enemies function in the exact spot we need to when we're tracking for our enemy's length. So let's scroll on down. We're going to go to where this is where a projectile hits an enemy. Now these first statements deal with enemy health and enemy removal, but we want a conditional down below for tracking total amount of enemies. So to track for the total amount of enemies, we'll write an if statement that says if our enemies dot length is equal to 0, meaning we don't have any more enemies available to us on the screen. We want to call the following code, spawn enemies. So if there are no more enemies, we're going to spawn 10 more from the very far left side of the screen, and they're automatically going to be set in motion because those enemies have their waypoints associated with them within the actual enemy class. So I'm going to save this, but to start, I'm actually only going to create 2, but remember, I right here is set to 1 to make sure that X offset is always going to be correct between the first 2 enemies. So if I want to spawn 2 enemies, I need to increase this value to 3. So now let's make sure that we're spawning more enemies as soon as we get rid of those first 2. I'll save and refresh and create a couple of buildings right here to quickly get rid of those enemies so we don't have to wait too long to watch this. Just going to enter the radius, we're going to shoot at it, get rid of it, and we get rid of this one as well. And only once we get rid of that one are we going to spawn more enemies coming in from the right, and we should only have 2. So there's the first one, and there's the second one, and this is going to keep going on for as long as we specify. Now, this would be a pretty boring game if we didn't do something to make our enemies more robust. We could do something such as give our enemies more health, or we could simply spawn more enemies. I think spawning more enemies is going to be the simplest thing, so let's go ahead and start with that. So spawn enemies is going to be a variable. How would we make this variable? Well, we could simply pass through an argument called spawn count. Count doesn't really matter. And then use this within our for loop. So let's say we pass through, right here when we call spawn enemies, an argument of about 3. We want to start with 3 enemies by default. We would use 3 right here with spawn count as the second statement within our for loop. So we'd get rid of the 3 right here, but this would actually only spawn 2 enemies because remember I is equal to 1 to start. So we'd just simply add on 1 to this, and that should give us the correct count. Let's make sure this works. We'll refresh. And then we should see 3 enemies now by default. So there's 1, there's 2, and then eventually there's going to be 3. And no more than that. And there is not another one trailing behind it. So now that we have the ability to increase the amount of enemies we're spawning at a time, we can go to the other location in which we're calling spawn enemies. For me, it's going to be on line 106. So, after the first wave, how many enemies should we spawn? Let's go ahead and say 5. Well, that's great, but what happens when we take care of these 5 enemies? Wouldn't it be great if we added some more enemies onto this automatically? So we go from 5 to something like 8. If that's the case, we need some sort of let in which we can change this programmatically. So I'm going to create a let called enemy count, and by default this is going to be equal to 3. And if I'm setting this equal to 3, I want to use it within spawn enemies right here. So I'm actually going to move the position of spawn enemies from line 53 down to about line 58. And I'm going to place enemy count as the argument instead of the static value of 3. So with enemy count, I want to scroll on down back to where we're calling spawn enemies again. And then I know for each iteration of our wave, we're going to be calling this code right here. So what I can do is take our enemy count and add onto it a value of 2. We're going to add on 2 more enemies for each wave. Then I can get rid of the static value of 8, call enemy count, and now we're always going to be increasing our enemy count as we go through getting rid of these different enemies. So to make sure this works, we're going to get rid of the first 3 enemies, and then we should have 5 enemies coming in as soon as that wave is over. So let's save, refresh, create a ton of buildings, and let's see if we can get this working. So we have 1, we have 2, and then we have 3. As soon as we get rid of this third one, we should see 5 enemies coming in. So there's 1, there's 2, there's 3, there's 4, and then we should have a 5th one as well. There it is, and no more after that, which we don't. And then after this, how many enemies should we have? Well, we look at our code real quick. We're adding on 2. We should have 7 in this round, and so forth. So that kind of gives you an idea of how to create more enemies within your game as soon as you get rid of the previous ones. And this is as performant as possible because we're only using the exact enemies we have available to us within our actual enemies array. So looking really good for creating waves for all of our individual enemies. That's going to allow us to go back to to-do and check off waves. So now let's add in game over functionality. So how do we determine when our game is over? Well, I think it makes sense to determine that our game is over when about 10 enemies have gone off the right side of the map. So basically, we're going to have our enemies, and we're always going to be tracking their X position along the side. So once their X position reaches off the side of our canvas, meaning our enemy is over here, we're going to remove this enemy from our enemies array, but at the same time, we're going to decrease a value. That value is going to be our hearts. So I'm going to start us off with 10 hearts. When an enemy goes off the side of the screen, we're going to subtract 1 heart, so in this case we would have 9. And then once we get down to about 0 hearts, we want to end our game. And to end our game, we'll display some text that says game over right here in the middle. So what's the very first thing we should do to achieve this functionality? Well, I want to track when our enemies go off the right side of the map. Now currently within our game, our enemies are moving very slowly. And to track whether or not these enemies are actually off the side of the map, we would have to wait quite a long time. So the first thing I would actually do here is speed these enemies up, so that way we're just not waiting forever to test our game, and make sure that we have the functionality in place that we want without dying of boredom waiting for these to get off the right side. So how would we go about increasing the speed of our enemies while still making sure they hit our waypoints? Well, we're going to want to go to classes.js, and you'll see right here, we are within our enemy class. And if we go down to update, this is where we're currently updating the position of each individual enemy. So our enemy's position are determined by this math cosine and this math sine function. These two basically act as the x and y velocities for our individual enemies. Now it's not completely apparent that these are the x and y velocities, so what we could do is, above this, declare a const called x velocity, and then assign this equal to math cosine. But it is likely later on, as we progress through our levels, we might want to increase our x velocity or our y velocity by some constant, which in return is going to make our level harder. So the better we do, the harder we make our enemies by speeding them up. If we want to speed up our velocities later on, it makes sense to not use a constant directly within update, but rather change this constant to a property within our constructor function for each individual enemy. So up above, I'm going to scroll up to our constructor and add in a new constant called this dot velocity. This is going to be equal to an object with an x property. I'll set it equal to 0 to start, and then a y property also set equal to 0. So now that this velocity is available to us, we can use this down below by saying, when we go ahead and determine our angle right here, this dot velocity dot x is going to be equal to math cosine angle. And that'll give us the perfect x velocity we need to add on to this dot position dot x. We want to do the same thing for the y-axis, so I'll add in this dot velocity dot y is equal to math sine angle. We're just setting it equal to this function down below. And that'll go ahead and set the y velocity equal to the perfect value to make sure that our enemy is always moving towards our waypoints. So really what we're doing right here is we're just declaring what math cosine and what math sine produce. They produce an x and a y velocity, which means right here, we no longer need this function, which is a little non-descriptive. We'll get rid of that, replace it with this dot velocity dot x, and we know right here, we can replace this with this dot velocity dot y. So our game is still going to function exactly the same. But in order to speed up our player, what we can do is multiply our velocity value on the x and y axis by a constant. So if we're going to multiply this by a constant of 3, we're essentially saying speed up our enemy by a multiplier of 3. So we're going to go 3 times as fast with this. So let's save, refresh, and watch what happens. So our enemy comes in, and it is definitely faster, but it looks like we are missing a couple enemies, and once we hit this very first waypoint, well, our enemy just goes back and forth, it does not continue on to the next one. So this is obviously something we need to fix. Why is this even happening in the first place? Well, when we head on over here to our update function, all of this code that we just wrote is perfectly fine. The issue is really within our if statement right here, because we are saying if the center of one of our enemies is equal to the waypoint x and y, then we are increasing that waypoint index, which forces our enemy to go towards the next waypoint. The issue is, since we're multiplying our x and y velocity by a value of 3, the value we're producing right here with math around this.center x and center y is never actually going to be directly equal to waypoint x and waypoint y. We're always going to have that little 3-value difference between these two values right here. As a result, we need to change up this if statement a little bit to say, if our center x and our center y are within a range of where our velocity is set, then we want to go ahead and increase our waypoint. So this will make a little more sense as we go about changing this. Instead of saying triple equal right here, I'm actually going to subtract. So from center.x, we're subtracting our waypoint.x. And then around this whole thing, I'm going to wrap this in math.abs. That stands for absolute, which just means if we get a negative value, it's going to make it positive. And then I'm going to say if this is less than this dot velocity dot x times 3. And I want to wrap this in a math.abs as well, because our velocity on the x-axis could also be a negative value. I always want to make sure I'm testing for positive values instead. Then that is when we want to go ahead and increase our waypoint. So what does this equation mean that we just wrote? Let's go ahead and get into it a little more in depth. So let's say hypothetically waypoint x is going to be a value of 100. And then we're moving towards waypoint x with the center x of 98 over here. So from 98, if we subtract 100, what are we going to get? We're going to get a value of -2. Now let's go ahead and compute this equation down here with math.abs this velocity x times 3. So what is velocity.x? Well, it's always going to be a value of -1 to 1. In this case, we're assuming that our enemy is moving over to the right. Therefore, x would be a positive value. Let's go ahead and say this dot velocity x is equal to 1. We multiply 1 by 3, which we have right there, that is going to be equal to 3. But to complete our equation up above, remember we used math.abs. So if we were to wrap this -2 in math.abs, that would be equal to 2. And now we just have to say to ourselves, is this 3 that we produced greater than 2? Yes, it indeed is. In that case, we would go ahead and say we know our enemy's center is within the distance of our waypoint, which would be something like right here. This is about a 2-pixel difference. So if that is the case, then we're going to start moving our enemy to the next waypoint, which might be up above here, and our enemy would keep moving in that direction. So essentially, rather than our enemy's center having to hit this waypoint exactly, we're saying that we only need to be within a specific range of this waypoint instead. Specifically, we need to be within 3 pixels of the waypoint in order to change our waypoint index, which will change the direction of our enemy. So we want to go ahead and do this range-like formula for our y-axis as well. We just did it for our x-axis. To do this for y, we'll go ahead and replace the triple equal sign with a subtract sign, and then wrap this equation within a math.abs to make sure that it's always producing a positive result. We want to say if this is less than math.abs for our y velocity, which we can get with this dot velocity dot y times 3, because now we have that 3 multiplier up above. Then we know we want to change the location of this individual enemy. Let's go ahead and save this, refresh, and see how this works. So our enemy comes in, and then once we hit that waypoint, we're going to go to the next direction because we're within that range of 3 pixels based on the additional speed multiplier that we added onto this. So, to clear this code up a little bit, I think it makes a little more sense, instead of multiplying 3 right here and setting it equal to the position, to set this dot velocity x and this dot velocity y by 3 up above. Because if we do that, let's do it now. I'm going to go ahead and remove these times 3's from here and put them up above. Now, within our equation down below, we don't need to multiply this by times 3. Because we know this dot velocity x and this dot velocity y is being set exactly equal to the times 3 up above. And if we wanted to clean our code up even more, what we could do is, our multiplier right here, we're multiplying this by 3, so we go 3 times as fast. We can call this a const of speed, set it equal to 3 right here, and then replace these two values with speed, so it's more indicative of what that 3 means. And now we can just increase this in one spot rather than 2, by saying our speed is equal to something like 10 if we want these enemies to go really fast. So we save that and refresh, and you can see just exactly how fast these are going. You can even put this to a ridiculous speed if you'd like. It's still going to work exactly the same. Just goes to show exactly how you can make your game harder as your player progresses through the different levels. So I'm going to set our speed equal to 10. Now that our speed is set equal to 10, we don't have to wait as long for the enemies to reach the end of the map. We can just simply track exactly when they go off the right-hand side to begin decreasing our hearts. So now we need to track whether or not our enemies are actually going off the right-hand side of the map. How do we go about doing that? Well, we want to go to index.js and find where we are currently looping through our enemies. So it's going to be within our animate function, which is on line 59 for me. And I know we're looping through our enemies with this for loop right here because enemies is the very first thing we see within our statements right here. So beneath enemy.update, I can write an if statement that says if our enemy.position.x, because we know position.x is actually going to be the far left-hand side of the enemy, which is exactly what we want. If that position is greater than our canvas width, our canvas width is simply the edge of our map over here, what do we want to do? Well, we can console log out, decrease hearts, and that'll give us an indicator whether or not this is working, but we also want to splice the enemy out of our enemies array, because that's going to allow us to spawn more enemies once our enemies count reaches 0. So to splice an enemy out of the array, we'll grab our enemies array, call splice, and then from what index do we want to splice from? Well, the index we're currently looping over, which will be I, we want to splice one enemy from that value. So we'll add 1 as the second argument. So each time we splice an enemy out, I'm going to console log out our enemies array as well, just so we can see this decrease over time. Let's save that, and then I'm going to inspect and open up our console, and then refresh. So once these enemies go off the right-hand side of the map, we should see some console log text over here, and they go off. So we definitely see our text decrease hearts, and now we can see once that first enemy went off, we removed that enemy from our array, the second enemy went off, and then the third one went off, and now we don't have anything within our enemies array. So shouldn't we be respawning enemies now that our enemies array is 0? Yes, we should be, but currently, where are we spawning enemies within our animation loop? If we scroll on down, we're going to find spawn enemies down here on line 114. We're only saying to spawn enemies if a projectile actually gets rid of an enemy, and then our enemy's length is equal to 0. So we don't actually want this code right here. It makes more sense to take this if statement and the comment out of where we're tracking for whether or not a projectile hit an enemy, and just taking it out and putting it directly within our animation loop. So if I go ahead and put this directly beneath our for loop where we're looping over our enemies, this will still work exactly the same. So when we get rid of enemies using projectiles, this code will still fire because enemy's length is equal to 0. We're only going to call it once because immediately we're going to call spawn enemies, which increases enemies.length. But at the same time, if our enemies go off the right side of the map using this if statement up above, it's going to set our enemies.length equal to 0 at some point, meaning we can also call this right here down below. So we're not limited to just calling the statement directly within where we're tracking for when projectiles hit enemies. Now we can call it whenever enemy's length is equal to 0, which is great. That is exactly what we want. So let's save this here, refresh, and then wait for our enemies to go off the right-hand side of the map. And when all of them go off, we should spawn new enemies, which indeed we do. We increase the enemy count, the game is harder, and this is just going to keep happening for as long as we tell our game to keep going for. So we want to start decreasing a heart value. Let's add that in. Right up above our animate function, and right up above spawn enemies, I'm going to create a let called hearts. So this is basically our life count. How many lives do we have within our game? I'm going to set this equal to 10. And now, when an enemy goes off the right side of the map, we're no longer going to call these console logs, but instead, we'll go ahead and reference hearts, and then subtract 1 from that current value, which means as hearts decreases, within this, eventually hearts is going to be equal to 0. So if hearts is equal to 0, what do we want to do? Well, for now, we can console log out, game over. So our game should stop when hearts is equal to 0. Well, what I'm also going to do is console log out our hearts so we can see this value go down over time. I'll save that and refresh. So now we have 3 enemies. We have 10 hearts. And we're subtracting from that hearts value. And eventually, once this reaches 0, that is when we're going to declare our game is over. So we just need 2 more. We can console log out. Game over now. So what do we want to do now that our game is over? Well, I think it makes sense to display some game over text right in the center here. And we might want to pause all animations within our game directly. Let's go ahead and start with just pausing our game once our hearts get down to 0. I think that's really easy to do. So to pause our game, on line 61, where it says request animation frame, I'm going to set this equal to a const called animation ID. So request animation frame for each frame we're running through this returns an ID value. This just increases over time, but this is an ID we need in order to cancel this animation from running. So with this ID stored within animation ID, whenever we lose our game, when we say if hearts is equal to 0, now I need some actual brackets because I want to write more than one statement here. When hearts is equal to 0, I'm going to call cancel, animation frame. And this is just a simple method that comes from the window object, but since we're referencing a window object, we actually don't need window dot. And within cancel animation frame, it takes an argument, and that is going to be the animation ID in which we want to cancel. So up above, we just declared this animation ID is equal to the ID we're returning from the current frame. So now we can use animation ID within the argument right here. And whenever our game is over, nothing within animate should be called at all. So I'll save that, refresh, and now when our count reaches 0, our game should pause completely. There should be no more animation. So now when these two go off the edge, let's see what happens. Those two go off and our game just pauses completely because we called cancel animation frame with the correct ID. So that takes care of that. Now let's go ahead and display some text directly in the center right here. So there are two ways we can display text here. One, we can draw text directly within Canvas, or two, we can use HTML. I always go with the HTML version because it is a tool that is available to us since we're developing games on the web. And if a really good tool like HTML and CSS is available to us, why not use it? Why force yourself to use something that's more complicated by drawing that text directly on the canvas? In my opinion, it's way easier to use HTML and CSS, so I'm going to do it over there. So to create some game over text, I'm going to wrap our canvas element within a div. And this is just going to act as a main container that I can use to overlay our text on top of. So within this div, this little container right here, I'm going to create one more div, and this div is just going to contain the text game over. So if I save this, by default, go back to our game and refresh, we're not going to see any text. We actually have to click and drag down here in the bottom left corner of our canvas to see that text, because by default, a div element is a block element, meaning it's within the document flow. So it'll push other elements around. You'll see right now game over is being pushed around by our canvas because our canvas is also a block element. And this is just a standard with web development. Since we're using text within a game, we don't want this within the document flow. And to take this without the document flow so we can overlay it on top of our canvas, we want to give this a CSS style of position absolute. And that's going to make sure that it doesn't push other elements around. So within that div, to start adding in CSS, we can add a style tag. And I'm going to set that style tag equal to double quotations right here. Within these double quotations, I can start writing CSS to style this text. So like I said, I want this out of the document flow. To get this out of the document flow, I'll write position, absolute, and now I'm setting the position style equal to absolute. Simple enough. So that's step one to taking this out of the document flow, but if I save this and refresh and select down here, you'll see our text is still down here. We next need to specify what element should this game over text be relative to. So to help illustrate this, we have our canvas element right here. This is just a canvas tag, and then we have our game over div tag down below. And then these are both within one main large element div. So this is a little illustration of how our HTML layout looks right now. We want to make sure that our game over tag down below is relative to this blue parent div. And as long as it's relative to this blue parent div, what we can do is set another style called top, and it's going to determine how far from the top of the parent div with a style of relative should this game over text be. So we set our game over text top to be equal to 0. We're saying we want to move our game over text to the very top of its parent div with a position of relative. So let's go ahead and do this directly within CSS, and hopefully it makes a little more sense with that. So this div right here was that blue parent div. On top of this, I want to add a style of position relative, because I know I want to move our game over text to the very top of this div right here, which contains our canvas and our actual text. So what I want you to really remember is a position absolute element on a child, like this div right here, requires a parent div to have a position of relative if we want to move this actual div relative to that parent. Now it's a little confusing, but it'll make more sense as we go about it. But now that we have position relative on the parent and position absolute on the child, we can add in a top style and set it equal to 0. So let's save that, refresh, and now you can see that our element up here is at the very top of that parent div, and now we can move this to the very center of our screen. So how do we go about moving this to the very center? Well, we have our game over div right here currently, and right now it's only taking up the exact space of the game over text. What I want to do is increase the size of that div to take up the full width and height of our canvas so it extends all the way out here. And then within that div, we're going to use a display property called flex. And this is just a special property which allows us to move the contents of this main red container div in certain positions. So let's say that I want to move our game over text down towards the center of our canvas right here. How would I go about doing that? Well, now that I have a display of flex on that div, I can add on a style of align items center. And any items within this main red div right here, including our text, are going to be moved towards the center of our main div container, which would be down there. It would move game over down here. So let's take this one step at a time. The first thing we need to do is get our main div to extend the full width and height of our canvas down below, and then we're going to add on flex and center as additional styles. So let's extend the width and height of our game over container. To do that, we're going to add on 3 more properties. So we have top equals 0. I'm going to add on bottom equal to 0 as well. If I save that, refresh, now I can go ahead and select this little tool right here within our console. This is going to allow me to select and inspect an element. So if I were to hover over a canvas, you'll see that it's lighting up blue. Now I can click it and inspect all the elements associated with our game directly within HTML. This is the element we're currently working on right here. This is our game over text. You can see all of our styles being applied. We have position absolute, top 0, and bottom 0. So what do we just do here? Well, we said that we want this element positioned relative to our parent div, which takes up the full width and height of the canvas. And since we set its top equal to 0, we're saying start the element at the very top of that one parent div. But we also want this element to extend to the very bottom of the div as well. So you'll see when I hover over this, the highlight is going from the top of our canvas to the bottom. That's what's allowing it to extend the full height of the canvas. If I were to go down here, I can toggle the styles on and off just to see what it looks like. So if I click bottom and then hover over our div again, you'll see it's only taking up the height of the actual text. But I do want bottom 0 on, so this div extends the full height. Now I want this to extend to the full width of our canvas, so then we can begin using flex styling on it to really center our text in the center. So to get this to extend the full width, in addition to bottom, I'll add on a left property equal to 0, and then also add on a right property equal to 0. And if you're new to CSS and inline styling like so, just make sure in between each style that you're adding a little semicolon, and it'll make sure that you don't have any bugs in the process. But with left 0 and right 0 in place, let's save, and then refresh, and then inspect our element. You'll see that takes up almost the full width of our canvas. It's actually off to the side a little bit. Let's move this on over a bit, so we can hover over this one more time. And yeah, our div is definitely going off the width of our canvas. So why is that? Well, right now our parent div right here by default has a display of block. We can even see that in place by looking down below. This div has a display of block. What a display of block means is 1, this div is within the document flow, it'll push things around unless specified otherwise, and 2, that this div takes up the full width of whatever parent div it has. So its parent div is body, and body takes up the full width of our browser window. So when we're saying this div right here is a display of block, we're saying take up the full width of this body element up above. This is the parent div. What we want to do is change this display property not equal to block, but equal to something called inline block. What inline block does is it says don't take up the full width of the parent, but rather only take up the width of the contents within the actual div. And the only thing that's taking up width within the actual div is going to be our canvas element. Therefore, when we set this display equal to inline block, this div right here is only going to take up the full width of the canvas rather than the full width of the body. So let's add that style into the parent div. To add that style in, I'll add a semicolon, and then say display is equal to inline dash block. Let's save that, refresh, and then hover over our child div, and now you'll see it's only taking up the width of our canvas because our parent div is only taking up the width of the canvas as well. Perfect, that's exactly what we want. So we achieved the effect with our child div right here taking up the full width and height of the canvas. Now we want to use that flex property so that we can begin using those additional sub-flex properties such as align items, and then another one called justify content. Let's add that on directly within our child div. I'll add in a semicolon that says we want a display of flex. So this is a special display property, which is going to allow us to use sub-flex properties such as align dash items. And this will align all child items vertically within this one div right here. We just need to set it equal to center. So it's important to note, align item center will only work if display is equal to flex. If I were to get rid of display flex right here, align items would not take effect. So we need to make sure that we have display flex for its element if we want align items to work. But if we save this and refresh, now you can see our game over text is directly within the center, at least on the vertical axis. So now the last thing we need to do is get game over moved to the center. And we can do that with one more flex property. And that flex property is going to be equal to justify content. And this will also take a value of center. We just want to say on the x-axis, move this to the very center of an element with a display of flex. We save that, refresh, there is our game over text. So looking good, but this is quite small. Let's increase the size of this by adding on a font-size property going to set this equal to, let's say, 72 pixels, make it quite big, because currently I believe that text that was there by default was around anywhere from 12 to 16. Let's save and refresh. That is looking a lot better to me. And right now, I think I'd rather make this text white. I think that'll contrast with the background a bit better. To make the text white, I'll add on style of color, equal to white, simple enough. And then I also want to make this text uppercase, because I think that just makes it stand out a little more from the background as well. So I'll say game over in all caps, save and refresh, and I do indeed like where this is going. Now this is using the default text associated with my browser and my computer. I want this to actually match the style of our game a little bit, so we need to go ahead and get some sort of different font. To get good free fonts, what I like using is fonts.google.com. So I'm going to go directly there. And these are all free to use fonts that we can use in personal and commercial projects like our game. And you can search through all these, there are tons and tons of them, but the one that I like, I'm going to go up to search fonts up here. It's going to be called Changa 1. So I'm going to select that, and I really think this matches the style of the artwork within the game. So over here, we want to make sure that we select this style. What this is going to do is open up this little sidebar over here. It's going to give us these link tags, which we can copy. I'm going to copy this with Command C, head back to our code, and with these link tags, at the very first line, right above our style, I'm going to paste all of these in. And this is going to pull the font into our game, but now we just want to specify that every piece of text within our game should use this font right here. So how do we actually swap out the fonts now that we have this one font being pulled in? Well, back at Google Fonts, they also provide CSS rules to apply to specific families. So we can grab this line right here, copy that with Command C, head back to our styles, and within our body tag, I'm just going to paste that on in. And since this is within our body tag, basically every other HTML element we have right here is by default within our body tag. As a result, it's going to read the font family from the parent of body, and it's going to apply it to everything else. And since we have Changa 1 available to us using these links up above, everything should take effect once we go in and save this file. So let's go back to our game, and then refresh, and now Game Over has that new nice style applied to it. Now one last thing that I would do to this text here is add some sort of stroke to the text, because although this contrasts relatively well with the background, if you really want the ultimate contrast between text and some other element, one really good way to do that is make sure that you have a stroke around your text that is a completely different color. If you put a black stroke on white text, it's going to contrast really well no matter what color you have in the background. So I want to add in that additional contrast, and really the only way to add in that additional contrast is to add a style to the text you want this applied to, and the style is going to be called -webkit-text-stroke. And I'm going to set this equal to 3 pixels and say that I want this stroke to be equal to black. So we're currently using a WebKit style, which means that this is not completely built into browsers by default. This is more what people call a polyfill, meaning it's more like an experimental style rather than something that's super robust. But this does currently work in most browsers, so I think it's okay to add this. And so I'm going to save, refresh, and now we have that nice border around our text, and obviously this is easier to read, even more so than the white text that we had prior. So by default, our game should not be over. We're only going to make our game over when our hearts count reaches 0. So back over here, I want to set our display not equal to flex by default, but rather none. And when we set this equal to none, save, and refresh, we're just not going to see that text at all. It is not selectable. But once our hearts is equal to 0, that's when we're going to set it back equal to flex. We need to do that programmatically within our code. So to do that programmatically, let's go into index.js. We know right here, this is where we have a game over, and we're canceling our animation frame. We want to select that HTML element. To select it, we can use document.querySelector, and this allows us to select any HTML element available to us within our code. So I'm going to add some parentheses, and then a quotation. And what element do I want to select? Well, I want to select an element with an ID of game over capital O. So right now, this ID is not available to us. To make this ID available to us, we need to go back to index.html and add an ID onto this div right here where we have our game over text. So to add in an ID, we'll declare that our ID for this one individual div should be equal to game over with a capital O. So I want to save that, head back to index.js. Down here, you'll see that I'm using a pound sign. This pound sign just means we want to select an ID. So in index.html, if we declare an ID right here, that is selectable with the pound sign. And then what is that ID equal to? It's going to be equal to game over. So now we should have that text selected directly within our JavaScript. With that text selected, we can call a style property on top of that. Now, what style do we want to grab? Well, our display property, which currently is equal to none, so it doesn't display at all. But once our game is over, once our hearts is equal to 0, we want to set this equal to flex instead, to make sure that our flex styles take effect, and that our game over text actually shows in the process. So let's save that, refresh, and now once we go ahead and get our heart count down to 0, I'll open up our console one more time, so we can see that decrease. We should see the game over text appear dynamically. And there are the final ones, and there is our game over text. Now we as the user know that our game is officially over, so great. So I think with this, we can head back to To-Do and check off game over. Next, we're going to add resources into our game, so we're going to be adding in coins that determine whether or not we can place a new building on one of our placement tiles. If we have enough coins, yes, we'll be able to place a building, great, we place it down. If the coins are not enough, well, we have to wait until we get rid of enough enemies, who in return give us more coins. But before we go on to coins, I do want to track our heart resources, because right now we're only console-logging that out to determine how many lives we have left. As a result, in the top right-hand corner, I want to add text that displays how many hearts we have left, and then right next to that, we're going to add the coins and all the functionality related to the coins. So how do we go about adding in text for our hearts? Well, to do this, I'm going to do it directly within our HTML, similar to how we added our game over text. Now, right beneath game over, I can add in an additional div, and inside this div, I'll list out 10, because I believe that is how many hearts we set within index.js. So this div is going to represent our hearts, but once we add this div, we know we need to style this. Because divs by default have a style display, a block, which means it's going to be in the document flow, is going to be placed right beneath our canvas. We want to get this out of the document flow so we can place it on top of the canvas. To do that, we can add in a position of absolute, and that's going to get it out of the document flow, great. And once we add in position absolute, we can begin positioning this relative to its parent div, which is this div right here, which contains our canvas. And once we can position this relative to our parent div, we can add in properties like top, and say that we want the 0 pixels from the top of its parent div with a position of relative. We can add in another style called right, set it equal to 0, and now this div is going to be placed in the very top right-hand corner of this parent div. So let's save this, refresh, and see what that looks like. You can see up here we have the text of 10 in the very top right-hand corner. Now, there really isn't any breathing room with our text in the canvas. We always want to make sure we're adding in breathing room to give us the best look possible for our text, to make it as easy to read as possible. So instead of setting top equal to 0, I'm going to set it equal to around 4 pixels, and then I'm going to set right equal to around 8 pixels. So if I were to save this, refresh, now we have our text over here, we have that padding around it. It makes it a lot easier to read compared to where it was prior. Now I do want to style this text further. I want to make it bigger to make it even easier to read. To do that, we can add in the style of font-size and set it something bigger, like 36. I believe right now the default is something like 16, so we'll save that, refresh, and that is indeed a lot easier to read. But one more thing I want to do is make this text the same color as our game over text with that border around it as well. So instead of saying this is a color of black, I'll specify a color that should be equal to white. And then I want to add in that border around the text, which we can do with this right here. It's going to be webkit-text-stroke. Set equal to 3 pixels black. I'm just going to copy this whole line, go to the end of color white, paste in that line. And then I don't actually want this to be 3 pixels. I want it to be a little thinner, simply because this text is smaller than the text we have up above. So I don't want this line to be too big relative to the actual font size. So I'm going to change the 3 right here to 2. Save that. Refresh, and now that is very easy to read compared to what we just had prior. So to help indicate that this is a heart, we could either write hearts at the end of this, or we could add in an icon. I believe it is easier to add in an icon because that's going to be more understandable for people from different countries who might not completely understand English. So let's go ahead and add in a heart icon right here. Where would we even get the heart icon in the first place? Well, where I like getting my free SVG icons from is going to be a website called heroicons.com. This is an icon library from the creators of Tailwind CSS, and all of these are completely free to use within your commercial and personal projects. So if I want to find a heart icon, I can click this search bar right here, type in heart, and it automatically will find us an associated heart icon. Now I want the solid version because I know I want to fill this icon in. I'll hover over it and copy the SVG. Once I do that, I can head back to my code, and right above our 10 right here within HTML, I'll hit Command V to paste in that code. And this SVG is going to represent that heart shape. Let's save, go back to our game, and refresh, and you'll see now we have a really clean looking heart within our game. But we do want to style this up a little bit to make sure that it matches up with our text, and that is to the left of the text rather than above. So within this SVG, I'm going to get rid of this class attribute. It's just not needed at the moment. And I'm going to add in a style tag instead. So I want to set the width of this SVG equal to around 30 to 35 pixels. Let's go ahead and set it equal to 30 pixels and see what that looks like. I'll save, refresh. That's definitely smaller. I think that's looking pretty good. Let's increase the size just by a little bit. I think I'll go up to 35 and be set with that. Now another thing I want to do is change this heart color to red. So I'll add in a style that sets the color to red, like so. Now if I were to get rid of this fill equal to current color, delete that, save, and refresh, you're going to see that's black instead of white. It's not taking in the color of red. But since hero icons provided this attribute to us by default, it's saying that the fill of this path right here should be equal to the current color associated with the style of the SVG. Basically what this means is current color is equal to the color we specify up above within our style attribute. So if we save this with fill equal to current color, go back to our game, you're going to see now that is red. Perfect. But these two are still not aligned vertically. We want to make sure that they're perfectly aligned so that we don't have any weird inconsistencies going on with our text and our icon. So to get these aligned, on the parent div right here that contains the SVG and the text of 10, we can add on a display of flex. So if you ever want two elements placed directly next to each other, you can go to the parent div, put on a display of flex, and it should place them directly next to each other with the correct spacing on the vertical axis. But if we definitely want to ensure that these are even directly within the center of the container div, we can add on that style of align items and set it equal to center. This is going to center things vertically within this parent div. So let's save this, go back over here, and now those are definitely more in line than they were before. I think our heart is a little close to our text, so I'm just going to give this a little more breathing room in between those two. And to do that, I'll go to SVG, add an additional style called margin dash right, and set it equal to something like 5 pixels. Doesn't need to be too big right here. We can save that, refresh, and I think that looks really good for our actual heart indicator. Now, we just need to make sure that this is decreasing whenever our enemies go off the screen and we actually lose these hearts. So I want to add an ID to the text right here of 10, but currently we can't add an ID of 10 because there are no tags around this text. So I'll add in a div tag around 10, and now I can add the ID of hearts. And that's going to allow me to select this directly within index.js. So let's go ahead and save this, and then go to index.js and find out where we're currently losing our hearts. So I'm going to do a command F for hearts. I'll keep searching for wherever we are subtracting 1 from hearts. And it's going to be right here on line 70. Whenever our enemy position X is greater than canvas width, we are taking 1 off of our current heart value. So it makes sense right here, whenever we decrease hearts, that we also want to update our HTML in the process. So to update our HTML, I can go ahead and select our hearts div with document.querySelector, and then get the ID of hearts. And then on top of this, I can call inner HTML, and this is going to allow me to select the contents of this hearts div right here. And I can set it by adding in an equal sign, and say that I want it equal to whatever hearts is at this current point in time. So whenever we subtract 1 from hearts, we're going to select our hearts div and set its inner HTML equal to that new value. So with just this, we can go back to our game after saving, refresh, and this should decrease whenever our enemies go off the right side of the screen. Let's watch that happen. And indeed, now we have an indicator in regards to how many hearts we have left. And once this reaches 0, our game should no longer be active. So let's double check that to go off the screen. And our game is no longer active. We have 0 hearts. Great. That is perfect. That is exactly what we want. Now let's start adding in an indicator for how many coins we have so we can place buildings on our map. So to add in that indicator, I'll go to index.html, and I essentially want a duplicate of our heart and our actual hearts div that displays the number. And if I know I want a duplicate of these two, what I'm going to do is wrap these in their own div, just for organizational purposes. And now I can select this main div that contains those two, hit Command C, and right above them, I'm going to paste in a new instance. So we're going to save this and refresh. Now we have 2 versions of this. It's a little messed up because since we added in a div, this is the new parent element of our SVG and our div down below, which means that these are placed on top of each other because our div and our SVG are block elements. The parent div always needs to be flex if we want these right next to each other. So on top of this new div we created, we need to add on a style of display equal to flex. And then we'll also say that we want to align our items within this so that they are centered vertically. So that's going to take care of this div with the first heart content, but I do want to copy the style and paste it on the second div, just so we get the exact same effect with our heart being right next to the actual heart text. So let's save this, and then refresh, and now those are next to each other, perfect. But we're going to change this heart out with a coin. So let's go to Hero Icons, and search for a coin. Well, it doesn't actually look like a coin is available to us here, so we're going to need to use another icon library in order to get that coins icon. So the other icons library I recommend using is not going to be Hero Icons, but also fontawesome.com. So this is another great library which we can use for icons, and a lot of these are free to use on both personal and commercial projects. You just have to double check to make sure that you can actually use them. So I've already verified for their coin icon, which I'm going to find with the search bar. I'm going to type in coin. This coins icon right here is available for personal and commercial use, so I'm going to click on that. And then once this opens up, we can click this little SVG icon to copy the SVG code. I'm going to click that, and now I can go back to our HTML and find where I want to place this SVG for coins. So right here, this first div is going to be our coins, and the second div will be only for our hearts. So right above this SVG, I'll add in the new SVG from Font Awesome, so you can kind of see the difference right here. The Font Awesome SVGs are pretty bloated compared to the Hero Icons SVGs. That's the only thing I don't like about them. But if we don't have that available to us within Hero Icons, we can definitely go over to Font Awesome and just kind of suck it up and deal with this longer SVG code. So I'll save this. And then I want to go down below and copy the style associated with the heart we had prior. I'm going to cut this out, and then I can get rid of this SVG completely, replacing it with the coins SVG. But I do want to apply those styles to this new coins SVG. So within the SVG tag, I'll paste in that attribute. And now this should be a width of 35, a color of red, and a margin right of 5 pixels. We're going to change this. Let's just make sure that this is actually showing on our screen. So I'll go back to our game, refresh, and now we definitely have our coins right here. But these are black. It does not seem like they are taking the red color. So why aren't they taking the red color currently? Well, we do have a color set equal to red, but the SVG by default from Font Awesome does not have a fill where it's set equal to the current color. Because by default, in order for this to actually take in a color that's associated with our style, fill needs to be equal to current color. So before I save this, I do want to decrease the width of these coins by at least around 10 pixels. So I'll go down to 25 because I think these are a little big compared to our heart. And then with this, I should be able to save, refresh, and now we have our coins in place, looking great. But a coins icon should not be red by default. It should probably be a color like gold because coins are gold. So our color right here, I'll change that to gold. We can do one more save, refresh, and that is looking great. One of the last things I wanted to do here for our interface is give us some spacing between our heart icon and the number on the left, just so we can help indicate what are our coins and what are our hearts. So to add in that spacing, all I need to do is select our coins div right here, the parent div, add in a style of margin-right, set it equal to something like 10 pixels, and that's going to separate this div from the hearts div down below. So save that, refresh, and now we have a good amount of spacing. We can even add a little more if we want. Maybe 10 more pixels. Let's go ahead and say margin right will be equal to 20 pixels. Save and refresh, and I do like how that looks. Now when our enemies go off the screen, right now we're decreasing our coins. That's a simple fix. Because we have two divs which have an ID of hearts. ID should always be unique, and this is representative of our coins anyways. So I'll replace this with coins, and that should fix that issue. Now the very last thing that I want to do here for our interface is add in some sort of black background right here to further contrast these elements with our background. I want this as easy to read as possible for the user so they can immediately look at this and understand where their hearts are at and how many coins they have left. So here's what I'm going to do. Right beneath our game over text right here, I'm going to add in a div. And this isn't going to have anything inside of it, but we are going to add in a style attribute. So basically what I'm going to do with this div is just set it to a fixed width and height, something like this, and then I'm going to color it in with a black background. I'm going to move it with a position of absolute to the top right hand corner, but it's going to be placed behind our coins and our heart text to help give us some additional contrast with our background. So for this div, I'll start with a position of absolute. And I know I want this on the top right hand corner of our canvas, so I can add in a top equal to 0 and a right equal to 0. Simple enough. But since there's nothing inside of here, we're not going to see anything until we specify a width, a height, and a background color. So I'll add in a width, set equal to 400 pixels because I want this moderately large, And I'll set a height equal to around 80 pixels because I don't want this going too far down from the top of our canvas. Now I can add in a background, dash color, and set it equal to something like black. And let's save with just this. See what that looks like. So now we have a black background div in place. This is 400 pixels wide by 80 pixels tall, but this obviously looks really stupid at the moment. Instead of just including this completely opaque background, I'm going to use a background gradient to give it a really nice fade effect that makes it more natural to our game UI. So for our background color, I'm going to swap out black with a style of linear-gradient. And this is actually going to be equal to a function. So it needs to be laid out in a very specific way. And the first argument here is going to take a 2 that says what direction do we want to go to. Well, we want to go to the left and to the bottom. So let's say this is our rectangle right here. What direction should our gradient be going towards? Well, we know we want it to go towards the left and the bottom. It means our beginning colors are going to start up here and they're going to end at the very left bottom of the screen. So now we can add in a comma and begin specifying colors. So I'm going to make all these RGBA so I can start associating opacity with the color. And I just want this to be black. So for red, I'll specify 0. For green, I'll specify 0. For blue, I'll specify 0. That's going to give us black within RGBA values. And then for alpha, I want this to be not completely opaque, but a little bit transparent. So I'll specify the alpha value here is going to be 0.8. And now I can add in an additional comma and one more RGBA value. And here I want to specify what color do I want to go to. So we're going to start with this blackish color with a 0.8 transparency, but I want it to go to a completely transparent value that also starts off with a blackish color. So let's specify black with 0, 0, 0, and then say that our last value right here, alpha, is going to be 0, which just means it's completely transparent. We're not going to see it, but we're going to fade into that value because we're using linear gradient right here. But one important thing to note right here is if we want linear gradient to work, we can't use background-color. We actually have to specify this is just going to be a simple background property. So I'll get rid of -color, like so, save, refresh, and you can see our gradient traveling from the top right to the bottom left, but it is not perfect. We still have some hard edges on the left and the bottom side. So if we want to fix this, we can add in one more color between these two values. I'm just going to add in the same color that we have at the bottom, which basically is going to help determine the position in which our opacity actually fades out. So we're saying we want to start off at an alpha value of 0.8, semi-transparent, but once we hit the very middle of the gradient, we want to fade out completely to an alpha value of 0. So we're basically specifying we want to hit the middle part of the gradient before we even deal with the very end right here. And we need to make sure we add in a comma because this is another argument, and this should help get rid of the visible edges we currently have on this div. So let's save that, refresh, and that is looking really good. We definitely have some contrast right there with our text in the background. It is very apparent to us that this is our user interface, this is our coins, this is our heart, but it is not distracting at all from our current background. We can still view all of our canvas elements the way they were meant to be viewed. So now I'm going to add in that coin functionality. Basically, I only want to be able to place a building if we have enough coins available to us. So I want to set our default coins equal to 100. I'll scroll on down, find out where our coins div is. It's right here on line 75 for me. And I'll replace 10 with 100. So that'll be our default coin count, but I also need to specify within index.js a let, I'm going to do this right beneath hearts on line 58, called coins. And coins is going to be equal to 100, which specifies we have 100 coins available to us to place buildings. Now, where are we currently placing buildings within our game? If we scroll to the very bottom of our file, it's going to be right here on line 137 for me, where we are using this click event. So we know if a tile is active and it is not currently occupied, we are pushing in a new building into our buildings array at that specific position. So here we can take our coins and subtract a certain value from it. So whenever we place a building, I want to subtract a value of 50. Each building basically is going to be worth 50 coins. But as soon as I subtract this value, I also need to update the HTML, which I can do with document, query selector, select the element with an ID of coins, and then change its inner HTML equal to the new coins value we just computed right here. Now I also want to say I only want to perform these two lines of code if a certain condition is true. So I'll add on a condition with a double and sign and say that I only want to be able to subtract coins if the current coins value minus 50, so what we're just spending on a building right now, is greater than or equal to 0. Then I want the user to be able to spend their coins and place a new building. So let's say we only have 30 coins right here. We subtract 50. That's obviously negative 20. That means we cannot call any of this code down below. But let's say that coins is equal to 50. Subtract 50 from that. That's equal to 0, which means that this is good. And we can indeed push in a new building while updating our coin HTML. So let's save this, refresh, and watch this in action. So we have 100 coins, but when I place a building, that immediately goes down to 50. I can place another. That goes down to 0. But if I try placing another building, it just won't let me because our current coins value is, well, 0. Now we want to give ourselves more coins when we get rid of an enemy, but we don't currently have the ability to do that. 1, because the enemies are too fast, and 2, because we simply haven't coded it in. So we want to find wherever we are splicing out enemies. We can do a Command F and search for enemies dot splice. So this is one position in which we're splicing out enemies when our enemy goes off the canvas width. We want to do another Command F for this to find the other instance, and it's going to be down here on line 122. This is when our enemy health is equal to 0. We are splicing out an enemy as long as it exists within an enemy index. So I want to add an additional statement right here. As a result, with this if statement, I need an opening and closing curly bracket. And basically, whenever we splice out an enemy, I want to take our coins value and add on to this a value of 25. So each enemy we get rid of is going to be 25 coins. And once we add on 25 coins, we need the ability to update our user interface, which we can do with document.querySelector, select our coins ID, and then set its inner HTML equal to the new coins value. This is going to update our coins. It's going to allow us to spend resources to build more buildings. But right now our game is kind of impossible with the speed in which our projectiles are moving and the speed in which our enemies are moving. So I'm going to save this file right here, index.js, and I'm going to go over to classes.js as well. And I'm going to decrease the speed of our enemies down to 3, just so it's possible for us to get rid of some to test out this new coins functionality. I'll save, and then refresh, create some buildings. Now we have 2 created, we have 0 coins, but now when we get rid of an enemy, that's going to increase to 25. Let's try to get rid of another. And it looks like we did not get rid of another, so we're going to have to wait, unfortunately. Those 2 will go off to the side, decrease our hearts, at least we know that's working in the process. We get a new enemy, and we get rid of the very first one, and now we have 50, which is going to allow us to spend another, but we cannot draw any more until we get to that 50 value. So great, I really like how this is looking so far. But I think with this, with our new user interface, and our coins drawn out, and that functionality in place, we're going to be able to go back to resources and check it off. Next, we're going to move on to sprites, so replacing our circles and squares with actual images. We're going to start with a very easy sprite, which is going to be a projectile, move on to a more moderate sprite, which is going to be an enemy, and then move on to the hardest sprite, which is going to be building. At the very end, we'll cover explosions, which are going to be a little different from the sprites we're covering above. But let's start with the easiest sprite, replacing our orange projectiles with some sort of image projectile instead. So within our game, we're currently using our buildings to shoot these orange projectiles. I want to replace these with actual image artwork. So where would I get that image artwork in the first place? Well, we could go back to our game over here and inspect our image folder. What do we have available to us within image? Well, we only have our game map available to us at the moment. So we're going to need some assets in which we can use and pull into our game, but we need to think to ourselves, where do we get these assets in the first place? Well, all the assets I'm about to include within this course are going to be available to you within the Google Drive link associated within the description. And I got all these from completely free sources so that you can use these on personal and both commercial projects. The authors for all these assets are also going to be listed within the description if you'd like to see the main source. But I already resized everything to the perfect dimension so that we can use these directly within our map right here. So at the very beginning of this course, we should have already downloaded the tower defense assets. And inside of here, we have all the assets related to our game, such as explosions, orcs, projectiles, our tile set, which we already used within tiled, and tower.png. This is the tower we'll be using to actually launch the projectiles. We want to use 4 of these assets currently and then bring them into our actual code. So the 4 assets we want to use are going to be explosion, orc, projectile, and tower. To select these, I'm going to hold down Command on my Mac and then click on whatever additional files I want to grab. And I believe the same key for Windows is going to be either Alt or Control, so try those out to make sure that you can select multiple files. Once you have all these files selected, we can right-click and then hit Copy. I'll click that, and then I want to go into the project folder. So I know my project is currently within Web, and then we created this as tower-defense. So this is all of our code. I want to paste these within our image folder so everything is completely organized. And then I'll right click inside of here and paste those 4 items. So if we go back to our code now, and we look within image, now we have 4 additional images in which we can work with. Within our game, we have explosion, orc, projectile, and then tower PNG. So I want to focus on our projectile first because I think this is the easiest sprite to implement into our game. So how do we go about replacing those orange circles with this image that we have right here? Well, we're going to want to go inside classes and then find our projectile class. So if we're scrolling through this and we're ever having trouble finding a certain class and this is just getting annoying, it's pretty much a good sign that we want to refactor these into their own individual files. And for me, I am kind of getting sick of having to find these individual classes, so I'm going to do that first before I actually implement this new projectile sprite. So to make sure that these are in their own individual files, here's what I'm going to do. I'll start with class of projectile on line 99. I'll select everything from 99 down to the very end of the class, which is on 132 for me with this ending curly bracket, and I'm going to cut everything out with Command X. That'll be Control X for you Windows users. And once everything is cut out, I can hit Command S to save, and then I can begin pasting this into its own separate file. So to create a new file, I'm going to go up to File, New File, and then paste in that projectile class. Once I paste this in, I can hit Command S to save it. And where do I want to save this new class? Well, we're already within our JavaScript folder, JS. I think it makes sense to create a new folder specifically for our classes for organizational purposes. We didn't do this in the beginning because it would have been a little overkill based on the amount of classes we had, but since we have a lot of classes right now, it makes sense to begin organizing things to make our code easier to locate. So I'm going to hit New Folder right here, and then create a folder called Classes. And inside of this classes folder, I'm going to call this new file Projectile.js. I'll save that. And now we have this folder of classes within our directory. And inside of it, we have our Projectile.js class. I want to do this for all my classes within classes.js to really organize things because this file is getting larger and larger. And we're going to be adding in an additional class as well. So let's continue doing this. On line 99, I'll select our building class and go all the way down to the very end of our file right here. I'll cut that out. And now I can go to File, New File, paste in our building class, hit Command S. Where do I want to save this? Well, within JS, and then within our classes folder. And I'm going to save this as building.js. That takes care of that, but we do have a couple more within classes.js. Let's start at the very top with a class of placement tile. I'll grab everything from line 1 down to line 26, cut it out, go to File, New File, paste it in, hit Command S, save this as placement tile with a capital T, and then within my classes folder, I'll hit save, and that takes care of placement tile. And you kind of get the idea right here. We're just going to do that for everything within classes.js. What else do we have left? Well, simply our enemy class. We can either rename this file and put it within our classes folder, but I'm just going to do the same way we've been doing things. I'm going to cut everything within classes.js because I know all that's left is enemy. And then, once I cut that out, I can actually delete classes.js. We're no longer going to use this file. So I'll delete that. I don't want to save it. But I do want to create a new file with all the contents of class of enemy. Hit Command S, save this as enemy.js. And then, within the JS folder, I'll go inside of classes and save this class as enemy.js. So now, as you can see, it's going to be a lot easier for us to locate the classes in which we want to deal with, especially when we're going to be working with all of these individually. But we do need to make sure, since we just refactored everything into their own individual classes, that within index.html, we actually pull in all these new classes into our HTML. So we got rid of classes.js down here. We no longer want to reference that. But instead of referencing classes.js, I'll add in a slash right here. So we're going in our JS folder, going into classes, and then I'll start by pulling in building.js. It's going to pull in all the code associated with our individual building class. But I want to do the same thing for these 3 additional classes down below. So what I can do is copy this line, paste it in 3 times, and now I can just go down the list. Instead of referencing building.js, I want to reference enemy.js right there. That'll pull in all the code. Same thing with placement tile. That'll pull in all the code associated with that. And then finally, we have our projectile. And once we have all this in place, we want to save and then test out our code to make sure that everything's still working. So I'll refresh. We can place buildings, no problem. Our enemies come out and our projectiles come out as well. All of our placement tiles are in place still, so our code is successfully refactored and working just as it was before. It's going to be step 1 is just refactoring everything correctly. Now going back to getting our projectile to look like this over here, what we could do is go to projectile.js and update our draw method. We could update it like so, by including c.drawImage, and this takes 3 arguments. It's going to be an image, and then it's going to be an x value, and then a y value. The x and y represent the position in regards to where we want this image to be drawn. So we already have an x and a y. We can replace this with this .position.x, and then the y can be this .position.y. But what we don't have is an image in which we can pass through into this drawImage function. So to create an image for a projectile, here's how I'm going to do it. Right within our constructor, I'll create a this.image property and set it equal to a new JavaScript image. So this comes with the JavaScript API by default, which means we don't have to pull in any additional libraries to actually create this new image object. Now to associate this new image with an actual image source, such as projectile.png, we can't actually pass through the source directly within our constructor. I know that makes sense, but unfortunately that's not how the API is laid out. So instead, here's what we need to do. We need to reference this .image.src instead, and then set where the source of this image is going to be. So right now, even though this file is within JS and classes, we're pulling it in within index.html, which means we need to reference the file relative to index.html. So we'll add a string right here and say, where do we want to go to get our projectile image? Well, we're going to go inside of image, and then where? We need to reference projectile.png. We should be good to go with just that. So now that we have this .image available to us, within c.drawImage, we can reference this .drawImage, and let's comment out this other code down below, which created the orange projectile, and see if things work correctly. We'll hit save, refresh, and then draw a building. Once it shoots, it's going to shoot out that new projectile. That's really all it takes to begin drawing out sprites into our game. So this is looking great, but what happens when we want to replace our enemies with sprites as well? Well, we're going to be reusing a lot of the code that we just wrote. And if we're reusing code we just wrote, why would we duplicate the work we have to do? In this case, it actually makes sense to extend our class right here and within enemy.js so that we're reusing the code that we just wrote. We don't have to change everything in 2 places, 3 places, wherever it may be, where we want to reuse this drawing code. As a result, we're not going to check off the projectile sprite just yet within our to-do list. We're going to refactor this so that it's actually extending a sprite class. So here's what I'm going to do. I'm going to go to File, New File, create a new class of Sprite. This is going to have an opening and closing curly bracket, and then I'll hit Command S to save this. And I know I want to save this within classes. I'll call this Sprite.js. So this is going to be the parent class that all of our Sprite classes inherit from. Now what should a sprite consist of? Well, if we create a constructor, we know that a sprite is going to consist of an image, which we can write out with this .image is equal to a new image. Now this code is looking quite similar to what we just wrote out within our class of projectile. Let's go ahead and take this code out from here. This .image is equal to new image, and this .image source is equal to this string. We're going to cut this out, go back to sprite.js, and we'll paste it in here instead. So we have a duplicate right here for this .image. We can get rid of one of these, and this is essentially what a sprite consists of to start. Now a sprite is also going to have a draw method associated with it. Whenever we draw out a sprite, which is essentially an image by the way, I don't know if I mentioned that. Whenever we draw out a sprite or an image, we want to call c.drawImage, which takes an image for its first argument. It's going to be this .image. Now for the second and third argument, we need a position. So in this case, it kind of makes sense to add in a position property associated with our sprite class. So for our x position, we'll reference this .position.x, and for our y position, we'll also reference this .position.y. And if we want to reference these two values right here, we need to make sure that we actually create that property in the first place. So we'll add in this .position will be equal to a position we passed through within our constructor. So to create this position argument, I'll add in an object, and then within this create a property of position. And I'll say by default this position will be equal to an x of 0, a y of 0, just so I know exactly what position will consist of. And this seems to be off to a great start. So now how do we tell our projectile class over here to inherit from our sprite class over here? Well, within projectile.js, we can say that this class of projectile extends our sprite class. But the sprite class is not currently available to us simply because it's not pulled in within index.html. So let's go ahead and pull this in. And our sprite class needs to be the very first of our classes because we know building, enemy, and projectile are going to be inheriting from this class. If we pull in our sprite class after all these other classes, it just won't be available to us. Therefore, we need to make sure that we duplicate line 98 where we pull in a class. That duplicates the building one. And then replace the very first building.js with sprite.js instead. So we're going to be pulling in our sprite class before we pull in our building, our enemy, and our projectile. Placement tile doesn't really matter because we're not going to be drawing out any image for that. So now that Sprite is available to us within projectile.js, we know when we extend Sprite that this definitely is going to work, but we know that our Sprite class takes a position argument. So we want to make sure that we're setting that position directly within Sprite. We need to call a super method. And all super does right here is it calls constructor within our Sprite class that we're extending from. So we know that our constructor within Sprite takes one argument, it's going to be an object. Within this object, we have a property of position. And position is being set by the actual position we're passing through our projectile class. So if we're setting our position property directly within Sprite, we no longer need to set it right here, because then we're just writing duplicate code. So we can actually get rid of this .position is equal to position because we know that's being set directly within Sprite. So let's save this and then check out sprite.js just so we can reference between these two files. So right now our image.source is being set with a static value right here. Eventually we're going to need to update this. I think at the moment it's okay though to leave static. And then we have a draw method, which calls c.drawImage and puts in all the stuff that we need to actually draw our image out on the screen. But you'll notice within projectile.js, we also have our own draw method, which calls the exact same thing. But since we're extending our sprite class, we don't need to call the exact same thing. This draw method will be available to us already because we're pulling it in from sprite.js. As a result, we can get rid of this draw method altogether. Update is still going to work with this .draw because we know within sprite.js, we have a draw method within here. And everything should still function the same, but we just cleaned up our class a bit by extending from Sprite. And all of our other classes are going to be a lot cleaner as well because we're not duplicating any of this code, which we're going to be reusing consistently. So let's save this, and then go back to our game. And now our projectiles should still launch at the enemies, which indeed they do. We're just using a little bit of inheritance from that parent class of Sprite. So great, this is going to be step 1, and with step 1 complete, we can knock off our projectile sprite. Next, we'll move on to our enemy sprite. So what does our enemy sprite look like for this game? Well, over here, within our image folder, you'll see that I imported an orc.png file. So this is from one of those free asset packs, and I put this together perfectly so that we can use it as a sprite within our game. But you'll notice the sprite consists of 7 different images. How do we actually get these 7 images imported into our game and animating correctly? Well, the gist of it looks like this. We're going to import this whole sprite sheet into our game. And then once we import our sprite sheet into this game, we're going to crop it down so that we only display the first enemy. So within this crop mark, for each frame we go through within our game, we're going to move the crop mark over by 1 enemy. That's going to render out this version of the enemy. And then for the next frame, we'll go to the next one. For the next frame, we'll go to the next one. And we're just going to keep going through this whole thing until we create the illusion of movement. Once we get to the very end, we're going to reset our crop mark back to the very beginning over here and go through the whole process. So this crop mark is going to be responsible for rendering out the sprite sheet. And by moving it for each frame, we're going to create the illusion of animation. So how do we begin creating this crop mark for this orc.png image? Well, let's go to enemy.js and make sure that we're extending our enemy class so that it extends from our sprite class. Now, what does our sprite class take? Well, it takes a position and an image. So I want to call super, which will call the constructor within sprite. And I know the constructor within sprite takes 1 argument with a position property, which we know position will be set equal to the position we're actually passing through our enemy class right here. So that'll be good to go. But down below within draw, this code right here draws out our red circle enemies. We don't need this anymore, but we do need to include our health bar. So how do we include the code from our sprite class's draw method, while also including the code from this enemy class's draw method? Well, if we want to call the draw method specifically within sprite, right here within draw, we can reference super, which is going to reference our sprite class, and then call from our sprite class dot draw. So we basically get the best of both worlds. we can call the draw method within Sprite, but we can also include all of our individual draw code right here associated with our enemies. So let's save this and see what our enemies look like over here. So eventually they're going to start coming in, and right now our enemies look like our projectiles, simply because within our sprite class, we're using a static reference to reference this individual file. This needs to be dynamic, especially because we're pulling in enemies now, not just projectiles. So to make this dynamic, we need to pass through a new property within our constructor. To add in a property, right after we set our position equal to this object, I'll add in a comma, and add in a property of image src for image source. Now with image source in place, I can copy this, paste it in, right here where our string was. But now that the string is gone, we also need to set our actual projectile source within projectile.js. So we know when we create this one individual projectile, we're going to call super, which calls the constructor on sprite, takes a position. Now it also takes an image src for source. We can set this equal to the location of the projectile.png. We'll get that with img/projectile.png. But before we go to our game and refresh, we need to make sure that image source is also set for the enemy class that we have over here. So inside of enemy.js, I'll also say for our super, we're setting an image source equal to image/projectile.png. Let's just render everything out as a projectile to start. Let's save this. And also make sure that we have projectile.js saved as well. Refresh. And we see our enemies, and we're also shooting projectiles as well, all rendered out within our game. But this gives us the ability to change within enemy.js the image source associated with an enemy. So we no longer want to reference just a projectile.png. Instead, we're going to reference orc.png. So let's replace projectile with orc. Save this, refresh, and see how things look. So this is how our game looks currently. We're currently just rendering out our full sprite sheet. We're not cropping anything, but that's going to be the exact next step. So we want to crop the sprite sheet so that we only show one orc at a time, and then we'll move on to animating this orc. So how do we go about cropping the sprite sheet? Well, I could do this within our enemy draw method, but I'm actually going to do it within sprite.js because it's going to allow me to extend our building class once we move on to that and animate that as well super easily. So to begin cropping our sprite sheet within draw, I'm going to create a const called crop. This is going to be equal to an object with a position property. This position property will have an x. I'll set it equal to 0 to start, a y, which I'll also set equal to 0. And then in addition to position, we're going to have a width, which I'll set equal to 0, and then a height, which I'll also set equal to 0 to start. So this crop const is going to represent the crop dimensions of where we want to crop from our actual sprite sheet of orc.png. So we're going to define the dimensions, essentially, of this box right here. We know at the very start we have an x position of 0, a y position of 0. Our height is just going to be equal to the full image height. But what should the width of this crop box be right here? How do we actually calculate this? Well, essentially what we're going to do is grab the full width of our image, and then we're going to divide that by the amount of sprites we have within the sprite sheet. So if we count them, we have 1, 2, 3, 4, 5, 6, 7. If we divide that by 7, we're going to get the width of just one of these sprites. And this is going to give us the width that we want to use within that crop const. So we're going to need the image width, and then we're going to need the amount of frames associated with this image. So let's go back to sprite.js and say that the width right here, the width of our crop is going to be equal to this .image.width. That's going to give us the full width of the image. And now we can divide this by 7, which is the amount of frames that we actually have within that image. Now we need to remember that we're using the sprite class for both our projectile and also our orc. And our projectile does not have 7 frames associated with it. It has 1. Therefore, we need to make the 7 a dynamic property, something that we can set for both our projectile and also our enemy. So if we want to make this property dynamic, instead of referencing 7, right here within our constructor, I'll create a new property, and I'm going to call this frames. I'll set it equal to an object, and within this, I'm going to create a property of max. What is the max amount of frames we have associated with this sprite? So in this case, it's going to be equal to the 7, and now I can replace the 7 with this .frames.max. And that'll give us the correct image width, but like I was saying, we need to make this dynamic to take into account our projectile sprite as well. So frames max can't be a default of 7 right here. It needs to be a default based on an argument we pass through within our constructor. So instead of saying 7 right here, I'll reference frames.max instead. But if we're referencing frames.max, we need to pass it through within a constructor. So here, I'll add in frames, say that it's equal to an object with a property of max, which by default will be equal to 1. I'm setting this equal to 1 by default because if we look down here at this equation, we're dividing this.image width by this.frames.max. If our sprite only has one frame, such as our projectile right here, we know that the width of this crop mark is always going to be the full width of the image, because something like 20 divided by 1 is going to be equal to 20. So that's going to take care of our projectile sprite, but to take into account our enemy sprite, which has 7 frames, we need to make sure that we're setting frames max equal to 7 whenever we're creating a new enemy. So let's go into enemy.js. We know that our super right here now takes a frames property, and this is going to be equal to an object with a property of max. So the max here for this specific enemy is going to be equal to 7, and that should give us the correct crop values for both our enemy and our projectile. So back within sprite.js, we're almost done with our crop dimensions, but we do need to finish off our height because our crop mark should not have a height of 0. It should be the full height of the image because we're not cropping anything on the y-axis. So let's get rid of this 0 and replace it with this .image.height. And that'll give us the correct crop mark in which we need for both our projectile and also our enemy. But to test this out, we need to alter c.drawImage a bit. This gets a bit confusing, at least with the way this API was actually created. I wish it was a little easier, but this is what we're going to have to work with to get things cropped correctly. So c.drawImage, if we want to include a crop mark, we need to get rid of these first two values, and we're going to replace them with something different. We're going to replace them with the crop position instead. So our second argument instead will be crop.position.x, and then our third argument is going to be crop.position.y. Now, since we're using a crop here instead of just positioning this image, for the fourth and the fifth arguments, we need to reference the width and the height of the crop. So our fourth argument right here will be the width of the crop, which we can now get with crop width. And the fifth argument will be the height of the crop, which we can get with crop.height. But in order for this crop to work, we need 4 additional arguments added onto this. Like I said, it gets a little confusing when adding in a crop to this drawImage function. So the next 2 arguments are going to be where this image is actually placed on the screen. So we'll add in a comma, and then we know this should be placed wherever this .position is. So we'll reference this .position.x for the x-axis, and then we'll add in a comma and reference this .position.y. Now we need 2 more arguments, and this is going to be the actual width and height of the image after the crop. So basically we're cropping down to this size right here, but we have the ability to scale it up or down based on these next 2 arguments. I want this to be the exact size in which we're cropping to. So for our image width, I'll say this should be the size of our crop.width. And for the last argument, I'll say the height of this should be the size of our crop height. So in the end, we should have 1, 2, 3, 4, 5, 6, 7, 8, 9 arguments within c.drawImage. And if everything went according to plan, we set crop correctly, we set drawImage correctly, we set frames max correctly, our projectile sprite should still exist, and our enemy sprite should only show 1 orc on the screen. Let's save, refresh, and see how this looks. So we do only have 1 orc, that is perfect. And if I begin creating projectiles, we see those 1 individual projectiles, no bugs or anything of the sort. This is looking absolutely great. So now we set all this up, now we can begin animating these sprites using the same c.drawImage method that we just created. So looking back at orc.png, we just created this small blue crop box. What we need to do now is move the X position over to the next version of our image. And when we move this position, the width and height of this crop box are going to stay the exact same. We're just going to be moving the position over until we get to the very last frame. And once we're there, we're going to go back to the beginning, setting our X position back to 0. So really, we only need to focus on the position of our crop on the X axis. So let's go back to sprite.js. And our crop position on the x-axis is going to be set right here. So we need to move this value dynamically to begin moving that crop box over to the right within the sprite sheet. So really what I want to start out with right here for our x position is going to be our crop width. Because if you think about it, looking at our PNG, we're only moving our crop box over by the actual width of our crop box right here. So our crop width is defined down below. We could take this equation, put it up above with an x, but we don't want to do that because that's just duplicating code, and we don't necessarily know what this means up above when we assign it to position.x. As a result, it makes sense to create a const above crop called crop width. Set it equal to this equation that we just wrote out. So now we can use crop width within position x. We know exactly what we're assigning to position x, and if we really wanted to, We could get rid of this equation as well, or replace it with crop width, so now that's a little more apparent in regards to what we're assigning to our width property right here. But will our code function exactly the same with this new crop width cost? Well, let's think about this. Let's say that our sprite sheet for our orc is around 700 pixels. If we divide that by this .frames max, which we know is 7, then we're going to get a value of 100. So we're using our crop width to define our width down below for actual crop mark, and that indeed is correct. Our crop width should be 100 right here. But right here for our actual crop position, if we assign position x equal to 100, we're effectively moving our crop mark over to the right by 100 pixels, which means to start, when we render out our orc sprite sheet, we're actually only rendering out the next orc in line. And we try rendering out our projectile, we're not rendering out anything, we're only rendering out whatever is next to the projectile. So when we're defining our position.x and setting it equal to our crop width, by default, we want our crop width equal to 0, so we always render out that very first frame. But this position x crop width is what needs to be dynamic, so that's actually moving throughout the whole sprite sheet. As a result, within this .frames, I'm going to add in one more property called current. What is the current frame we're on? By default, it's going to be the frame of 0. So once we assign 0 to this .frames current, we can begin using it within our crop position right here. I'm going to multiply crop width by this .frames.current. So by default, we're cropping from a position of 0, because 0 right here times our crop width of 100 is going to be equal to 0. But now we can begin increasing this .frames.current by something like 1. If we increase that by 1, then we're saying to move our crop mark over by 100 pixels. That's going to render out the very next frame within our sprite sheet. If we increase it by 1 more, we're going to get not 100, but 200 pixels. And this is just going to allow us to run throughout the whole thing until we get to the very end of the amount of frames we have. Then we'll reset this .frames current back equal to 0. But first thing first, let's save this and make sure that our code still functions correctly. We always want to make sure that we do this so we don't run into any really big bugs throughout the process, and it looks like we're good to go. But now we want to make sure that we're increasing this .frames.current over time. So to get our crop mark moving over time, I'm going to begin increasing the current frame value, which we're using to actually set our X position on that crop. Right after draw image, I can begin writing that I want to start increasing this .frames.current by 1 for each time we call draw. And now I know I want this to reset as soon as frames current is equal to 7. That's going to reset our crop mark back to the very beginning. And I can do that with if this .frames.current is greater than or equal to this .frames.max. So the max amount of frames associated with a sprite sheet minus 1, because this .frames.current is using indices, while this .frames.max is using a count. Then what do I want to do? I want to select this .frames.current and set it equal to 0. That's going to set the crop back to the very beginning, and then we can begin launching it to the very end once more. It's going to loop the animation essentially. So let's save this, refresh over here, and now you'll see that these are indeed animated. We're going from the very beginning of our sprite sheet to the end, back to the very beginning. Now these are going quite quick. You can leave this as is, but I do want to slow these down a little bit. And we can do that using with something that I like calling a frame hold. So instead of calling frames current for every time we call draw right here, basically for every frame within our game, we're only going to call it for something like every 5th frame or every 10th frame. I can write an if statement that says if this .frames.elapsed modulo 5 is equal to 0, then I want to call the following code. So frames elapsed is going to be a property that just increases for every time we call draw. We're going to modulo it by 5, which just means divide it by 5, and get the remainder. If that remainder is equal to 0, then we are indeed going to increase frames.current, but we're only going to do it for every 5th frame associated with our draw method. It's just a way to slow things down so our sprite sheet animation doesn't move super quickly. This 5 right here can be called a frame hold. For how long do we want to hold off before we increase frames.current? So we can replace 5 right here with this .frames.hold, and that should give us the effect we were going for in regards to slowing down our animation. But we do need to add in this elapsed and this hold property for this to work. So we'll add those in. We'll say elapsed is going to be equal to 0, and then our hold will be equal to 5, a static value to start. We'll make this dynamic later, but now these will be usable down below within this if statement. And to help us better understand what this if statement does, we can say responsible for animation. But before we save this, we want to make sure we're always increasing frames.elapsed for every time we call draw. So we'll select this, .frames.elapsed, and add a 1 onto that for every time we call this method. So let's save this, and then see if our animation is slowed down. We'll refresh, and indeed it is slowed down. So you might like this look, you might hate it. You can go ahead and fine-tune things in regards to how you want your animation to look. Me personally, I think this is a little too slow. So if I want this to be faster, I'll go to our frames hold up above and decrease this value to something like 3 or 2. That just means run the animation for every 3 frames instead of every 5. So I'll save it at 3, refresh, and I think I like how that looks. That looks more natural in regards to the speed they're currently moving at. I'll create some projectiles. Everything still looks to be functioning perfectly. So this is how we're going to begin sprite animation, specifically with our orgs, but we're going to continue with this by animating our buildings next. So we'll go back to do and check off our enemy sprite. Next, let's add in our building sprite. So what does this look like? Well, over here within our image folder, if I click on tower.png, you can see this is what our building sprite is going to consist of. So essentially, this is about 19 frames of images, and it starts off with this little projectile. Looks just like the projectile we already added into our game. And once we hit this frame right here, you're going to see this is the very last frame in which a projectile exists. We're going to launch a projectile in which we already created using a projectile sprite from this exact position on this tower sprite. And it's going to give off the illusion as if this projectile really came from this image right here, because over in the next frame, while the projectile just doesn't exist, as long as we launch the projectile from this frame right here out into the open, it's going to make it look like it was actually part of this sprite sheet that we have right here. So how would we go about adding the sprite sheet into our game? Well, now that we created this sprite class, it's going to be a lot easier to do for our building class. So I know I want building.js to use an image instead of this rectangle that we have going on here. So if we want this to use an image, we can simply go to the very top and write extends from the sprite class, because we know sprite consists of that image functionality. Now, in order to use the sprite parent, we need to make sure that we're adding in a super method into our constructor function. And remember, super just calls the constructor of the parent class, which is sprite. And we know that constructor takes one argument, and inside this argument it takes a few properties. So it's going to take a position property, which we're passing through already within our building class. So here we can say position is going to be set from our parent sprite class. And if we're setting position directly within the parent sprite, we don't need to set it directly within our building class. We can actually get rid of this line right here where we're setting this.position equal to position. Just cleans up our code a little bit. But in order to completely add in a building image, we also need to pass through an image source property as well. Because if we check within sprite.js, scroll to the top, and look at the constructor, it takes a few things: position, image source, and then frames. So we're passing through image source over in building.js. What should image source be equal to? Well, I want to start within our project root, wherever index.html is, and then go inside of our image folder. So I'll add a string right here, and then say, within the current directory, I want to go inside of img. Then I want to reference tower.png. That's going to make sure that image source is set so that it can be used within the draw image function within our sprite class. Now, when we were checking out our sprite class, we know that it also took a frames property within its constructor. So within super, we're going to write a frames property set equal to an object. And right now, we're only setting the max amount of frames associated with this one image. And I already counted all of them. It's going to be 19. But if you're using a different image, all you need to do is go into that image, so tower.png, and then count up the amount of frames you want to animate. So this entire sprite sheet is 19 frames, and I already specified that within building.js. And you might think this will work right off the bat, but if we look very closely here, we're setting a property of this.frames within our parent of sprite just by passing through frames right here within super. But if we look down below, we also have a property called this.frames. What was this.frames used for within our building? Well, if we scroll down, you'll see down below, whenever this.frames is divisible by 100, that is when we're saying to launch a new projectile. We're no longer going to be using this.frames for this. We're going to call this something else, and that way this doesn't override the frames that we're actually setting within our parent sprite class. So let's change this.frames equal to what? We're going to change it equal to elapsed spawn time, because that is essentially what this is. And then down below, where we have this.frames in these two locations, I want to change this in both So I'll say when this.elapsed spawn time is divisible by 100, we're going to push in a new projectile, and we're going to be increasing this for every time we call update, for every frame essentially. Now, as long as we set these properties directly within super, we know that we can begin drawing out an image using our parent class's draw method. The thing is, we already have our own draw method down below, which draws out a blue rectangle. We're no longer going to be drawing out that blue rectangle, so we can get rid of these two lines right here, but we might want to keep the radius associated with our building. As a result, it makes sense to keep this draw method with the associated code, and then call the parent's draw method with super.draw. That way we get the best of both worlds. We can call the image-related code associated with our parent class, but we can also call any code that's just supposed to be associated with the current class we're currently on, which in this case is building. So as long as we fill super correctly, we make sure that we got rid of this .frames, and we call super.draw within our draw method, everything should go according to plan. We should see our building being drawn out. Let's save this, refresh, and see what happens. So now if I click, we have a building in place and it's already animated because we're using our sprite parent class, which takes care of all that frame-related animation stuff. Now, one obvious issue is you'll see when I click on this very top left-hand corner piece that our building is positioned a little bit beneath it, and then I can go one tile down below, click, and our building is placed even further down. We want to make sure that we're placing our building directly on the tile we actually click on, but since our sprite is drawn from the top left-hand corner, well, it's pushing our building down rather than putting it in the exact spot we want it at. So we need to add some offset to our building sprite's y-axis. So to add in some offset, we're going to go to sprite.js. And here I'm going to add in one more argument. So after frames, I'm going to add in a comma and set offset equal to another object with an x equal to 0 to start and a y equal to 0 to start, just so I know what offset should consist of. And then I want to make sure that I'm setting an offset property whenever we create a new sprite. So I'll say this.offset is equal to the offset that we're passing through within the constructor. Once this offset is set, well, we can use it down below within c.drawImage. So this is what's responsible for actually drawing out the image on the screen, and we know these last four arguments determine where it is placed. So for position y, I just want this placed a little bit up above based on the offset that we're passing through. So what I can do is add on to this.offset on the y-axis. And if we ever wanted to offset things on the x-axis as well, we can add on this.offset on the x-axis. And by default, since this.offset is set equal to 0, because we declared a default, nothing is going to happen to the sprites that we don't want moved around anywhere, which is perfect. But we do want to move our building sprite up a little bit based on this offset value. So over in building.js, within super, now we can add in an offset property. An offset is going to be equal to an object with an x and also a y, but instead of setting this equal to 0, I want to set it to -80, so we're moving the sprite up by 80 pixels. Let's save this, refresh, and click this top left-hand corner piece, and now you can see that it's placed correctly, so great, we solved that issue. So the next thing I want to do is instead of shoot based on some sort of elapsed frames property, right now we're only shooting for about every 100th frame, I want to shoot based on the actual frame within this animation. So for every 6th frame this runs, we should be shooting a projectile. Why every 6th frame? Well, if we look at our image, tower.png, we go 1, 2, 3, 4, 5, 6. This is where we want to launch our projectile, in this 6th frame right here. So rather than wait 100 seconds to launch a projectile, we're going to scroll through this animation, and once we hit this frame right here, we're going to launch a projectile out into the open. So how do we check based on the sprite sheets frames rather than for every 100th frame like we've been doing? Well, let's go inside building.js and then scroll down to our update function. So you'll see right here within this if statement, we're saying if this.elapsed spawn time is divisible by 100, then we're going to call projectiles.push. We no longer want to do this. Let's go ahead and get rid of this if statement, get rid of the ending if statement bracket, and then get rid of this.elapsed spawn time. We can also get rid of this property altogether up above, so we'll delete that. And now basically whenever we call update, we're just going to nonstop be pushing projectiles in our projectiles array. But that's not what we want right now. I only want to push in a projectile for every 6th frame of our actual sprite sheet animation. So the first thing I'm going to do is make sure this code is as legible as possible. Looking at this, if I were to analyze it for a couple seconds, I would know exactly what it does. But I can make this even more legible by replacing this with a method called this.shoot. We want to reference this.shoot. We need to create that method within the class, so I'll say shoot. is going to be equal to the following code. We're going to push in a projectile into our projectiles array. So now this is very readable within our update function, but we only want to call shoot under certain conditions. So we'll write an if statement that says if we have a target available, and we can get that with this.target. We're always setting this based on the collision detection between our building and our enemies. If a target is available, then yes, we do want to shoot, but we want to limit the rate in which we shoot. So we're going to add in an and statement, and after that, reference our this.frames object and get our current frame. So if this current frame is equal to 6, then we want to shoot. Let's save this and see what it looks like. Refresh and draw a building. We're only going to shoot an enemy once they enter in here. That works. But it looks like we're shooting multiple projectiles at once rather than just one. But it does seem to be happening on around the 6th frame, so that is good. But we definitely want to fix this bug where we're creating about 5 to 6 different projectiles. So why is this happening? Well, we need to remember that within sprite.js, within our draw method, that this code down here that's responsible for animation. We're saying we really only want to animate our sprite if the frames.elapsed time, so the total amount of frames that have occurred over time, is divisible by the frames hold. So how long should we be holding on this current frame? Really what we'd want to be doing is calling this.shoot within this if statement right here, because frames.hold is equal to 3, so there are going to be about 3 frames in which this.frames.current is actually equal to 6. As a result, we're producing multiple projectiles all at once, when really we only want to create one at a time. So we want to grab this if statement right here. I'll go ahead and grab that. Go back to building.js. And then we want to integrate this within this current if statement. So how do we integrate this if statement with this one? Well, all we need to do is grab everything within this if statement, add in an and statement, paste in the current code, and get rid of the original if. Save that, refresh, and draw a building. And now this should only be called once, and indeed it is, because we're taking into account that we're using that frames hold property. Now we're shooting a projectile for every 6th frame, but as you can see, it's not being shot from the very top of our actual building. It's being shot from somewhere down here in the middle. So we can fix this by heading down into shoot and saying that our new projectile position is actually going to have a y value of this.center y minus 80. We're going to offset this by 80 as well, similar to how we did with the actual building sprite. So let's save that, refresh, and draw a building. See what that looks like. It's close, but it doesn't seem to be exactly on the money. So how do we test this to make sure that we can get this offset related to our projectile directly where we want it to be within the center of our tower? Well, I think it makes sense whenever we spawn a projectile, we're not going to update it in regards to its velocity. We don't want to push it around in any direction. We just want it to sit there so we can position it correctly, and then we'll go ahead and let it move again. So back in our code, we'll go to projectile.js. And within update, we're going to see lines 21 and 22 consist of setting an x and a y velocity. If we comment these out, save, refresh, and then try launching a new projectile, you're going to see our projectile stops in wherever it is originally positioned. So we want to make sure that we're moving this to the top left a little bit more, so that's exactly placed on where this should be launched. So it looks like I might need to subtract around 20 pixels from both y and x. So I'll subtract 100 from y, and then 20 from x. Save that. We'll see what it looks like real quick. It launches, and that is very close, not quite there yet. It seems to be in the correct position on the x-axis, but we might need to bump this up by around 10 pixels on the y-axis. This is more like just a guessing game almost. I don't know the exact way to get it perfectly up there, but I know with a little bit of guessing, we definitely can get it there. So I think that is almost exact. It might be off by 1 or 2 pixels, but this should be good enough to get a realistic launch effect for this projectile. So to get this moving again, let's go to projectile.js, and then we'll uncomment out lines 21 and 22, save, refresh, and watch this in action. So now when an enemy moves in, it moves from pretty much the exact position. I really like how that looks. We can go ahead and call this step of the task complete. The next thing we want to fix is making sure this animation only runs if a target is currently available to us. So what is going on here? Well, let's go to building.js. Every time we call update right here, we're calling this .draw, which in return calls super.draw. So when we're calling super.draw, we're going inside of sprite.js and calling all this draw code. So all this code right here is responsible for drawing out the image, but down here, this is responsible for actually moving our animation. But the thing is, we only want to call this under certain circumstances. We don't want to call this all the time, otherwise our animation is just going to be happening over and over again. So to fix this, we can put this code right here within a separate method. I'll grab everything from our comment down to the end of the if statement, cut that out, and then right beneath draw, I'll add in a method called update. An update is going to contain all this code down below. Now typically within update, we've been calling this.draw, but this would be the exact same thing as we had prior, where this code was within our draw method, so we're no longer going to be doing that because we know we want these two called separately under certain conditions. But if we're separating these two statements of code, remember, enemy.js, the actual movement of our enemy, was dependent on that animation code whenever we called super.draw. If I were to save everything and refresh, you're going to see our enemies no longer animating because within sprite.js, update is no longer being called since we refactored things and moved it to its own method. So within enemy.js, let's just get our enemy moving real quick. Within update, we can now call, right after this.draw, super.update to call our animation code. Save that and refresh, make sure our enemies are moving again, and indeed they are, looking great. But if we draw out a building, you'll see this isn't animating at all now. We need to make sure we're calling super.update within our building code as well. So let's go to building.js. And within update here, if we were to call super.update, that's going to call our actual animation code. Save and refresh. Now you'll see our building is moving again. But as I mentioned, we only want this to move under certain conditions. What condition would that be? Well, if we have a target in the first place. So if this.target exists, we want to call super.update. That's going to make sure our building is moving. Let's save, refresh, draw a building, not moving by default, but once a target does exist, we are going to move things. But once an enemy goes outside of the range, you'll see that our building stops on whatever frame it just left off on. You can see right here, we didn't go back to the beginning. So we want to make sure that we go back to the beginning as well. We want to call the animation code for as long as there is no target and our current frame is equal to 0. So when a target exists, we'll call super.update, which animates things. Or if a target does not exist and this.frames.current is not equal to 0, meaning if we're on any other frame within our animation besides 0, we want to go ahead and animate back until our frames.current is equal to 0. It's going to reset our building back to its original position, even if a target does not exist. So let's save this, refresh, and then draw in a building. You're going to see this animates perfectly. It's only being called whenever an enemy is actually within the range. But let's watch what happens when an enemy goes outside the range. This very last one right here is going to go out, but we always go back to our original position because we're saying so. If a target does not exist, and this.frames.current is not equal to 0, we want to animate until we set this value right here back equal to 0, and therefore we won't be calling super.update any further. The last thing I'm going to do temporarily is comment out our building radius right here. This is only going to show either on building hover or when we originally placed building. I think it kind of muddies up our game a little bit when we have all these different circles overlaying each other. So I'll comment it out for now, save and refresh, and then start drawing on buildings. And this is looking really good, but if we're not careful, we won't notice a bug associated with our code still. Watch what happens when I refresh, draw down below, and then draw a building on top of this one we just drew. If I draw on top of it, you're going to notice that the top building is overlaid on top of the bottom building. We need to make sure that these are ordered correctly. We want buildings on the bottom drawn on top of the buildings in the back. So the higher the Y value associated with a building, the closer to the front of the array they should be, and that way everything will be rendered out correctly on the Z-axis. So how do we begin sorting our buildings whenever we place them? Well, where do we place a building in the first place? It's going to be within index.js. And if we scroll on down to the bottom of our file, wherever event listers are, right here on line 141, we have a click event that essentially pushes in a building into our buildings array. Whenever we push in a new building, we're going to want to sort our buildings array so that items closer to the top of our canvas are near the front of the array rather than the back. And that's going to make sure everything is drawn out correctly. So let's sort everything with buildings.sort. This is an array method. And this array method takes a sort function. Looks like this. It's just a simple arrow function. And the arguments within this arrow function are going to be A and B. These are arbitrarily named, but we're basically looking at these two values as this is going to be building A, this is going to be building B. We're comparing whatever buildings are within this buildings array to each other. We're going to compare every single one until these are sorted out into the correct format. So this function right here needs to return a value. And when we're sorting numbers, this value is either going to return a negative value, an equal value, or a positive value. So here's what I mean by this. Let's select building A by referencing our A argument, and then we're going to get its position on the y-axis. From this, we're going to subtract our B building position on the y-axis, and this is going to compare the two y positions. So let's say building position y is equal to 100. That means it's about 100 pixels from the top of our canvas, and B position y is equal to 110. If we were to subtract 110 from 100, we would get a value of -10. Since this returns a negative value, it's saying move A to the beginning of the array. So hypothetically, let's say our array starts off with B in the front, and then A at the end. Since B is in the front, even though it's further down as indicated by 110 right here, we're drawing it behind A because it is the very first thing we're calling B.update on, which contains all of our draw code. But when we run it through buildings.sort, when we compare these two positions together and we get a value of -10, it's saying move the first building right here to the front of the array. Whenever we get a negative value, we're moving the first position to the beginning. If that's the case, we're taking A, we're moving it to the beginning, and therefore we're going to get a resulting array of A before B, and this makes way more sense because A is higher up on the screen than B. We want to make sure that this is rendered out first, and then B is rendered on top of that. So this isn't a totally comprehensive course on the sort method right here, but hopefully that gives you a little overview in regards to how sort works in the first place. So let's make sure that we save this, and then go back to our game, and now we're going to click from the bottom, and then click from the top. And since we called sort, the top building is no longer being drawn on top of the bottom one. We know this works correctly, and it's going to continue working correctly whenever we keep adding in new buildings, which is exactly what we want. So I think this is going to take care of our building sprite. There are still a few finishing touches which I want to take care of later, but I think this is good for now. So let's head back on over to To-Do and check off our sprites building. Now let's finish this off by rendering out explosions. So within our game, whenever a projectile hits an enemy, I want that projectile to have some sort of exploding effect associated with it. So if we go back to our project and we look under our image folder, we can view explosion.png, and you'll see this is an explosion animation that we have here, and this is about 4 frames long. So if we want to start using this within our project, really all we need to do to start is go to index.js, and then right above our animation loop, it's actually going to be right above spawn enemies right here. On line 59, I'm going to create a const called explosions, and this is going to be equal to an empty array. So we want to populate this array with explosion sprites whenever a projectile actually hits an enemy. So where does a projectile hit an enemy? Well, let's scroll on down and see if we can find it. Well, it's going to be right here on line 131 for me. This is where I'm selecting our building, its individual projectiles, and then splicing out that one projectile from this specific spot within the projectiles array. So right before this, this is where I want to create that explosion. So to create that explosion, above this, I can write explosions.push. And I want to push into this explosions array a new sprite that we can animate. So now we have a sprite class available to us. To create a new sprite, all we need to do is write new sprite and then start filling in the correct arguments to actually instantiate this sprite object. So what are the arguments associated with our sprite class? If we forget, we can always head on over to sprite.js, scroll to the top, and within our constructor, these are the arguments we want. So they're really properties, not so much arguments, but our first argument is going to be an object that contains all these properties. So I'll select that object, hit Command-C to copy it, go back to index.js, and now when I'm creating this sprite, I can paste in all those arguments, but we do have to change the syntax a bit in order to get this working, but this is a good start. So position is not going to be equal to, but rather colon to, assigned to, with this little colon right here, an object with an X and a Y. Image source, we don't have a variable available to us in which we can just use shorthand syntax like we are right here. So we need to make sure we add a colon and assign this equal to some string. I'll leave it empty to start. And then we need to get rid of these other equal signs because we're passing this object through as an argument rather than saying that these are going to be defaults. So formatted correctly, this is what it should look like. We're taking our explosions array and pushing in a new sprite with all these arguments. Now the sprite is going to be representative of an explosion, so where do we want this explosion to occur? we can determine that by setting this position property. Where on the x-axis should we create this explosion? Well, right above, we can see we have a console log where we're logging out projectile.enemy.health. And if projectile is available to us, we can grab that projectile, get its position on the x-axis. And that's going to say we want to spawn this new sprite exactly where this projectile is about to be spliced out. We want to do the same thing for y. So I'll get rid of the 0 and say we want to create a new explosion at the position of projectile.position.y for the y property right here. So that's going to spawn this in the correct position, but we do need to determine what kind of image do we want to use for this new sprite. Over here within our image folder, we know we have explosion.png available to us. So for image source, we can specify we want to start within our project root, where index.html is, with a /. We want to go inside of our image folder with img, and then select explosion.png. And that's going to render out that sprite sheet associated with our explosion. Moving down our property list, we have a frames property set to an object with a max equal to 1. Now, how many frames is this explosion sprite? We can look within explosion.png. We know this is 4 frames. So instead of using 1 right here, we're going to use 4 instead. And finally, we don't need any offset, at least not yet, so I'll leave the offset as it is. So this should populate our explosions array with sprites, but to render these sprites out, we need to loop through this explosions array and then call the draw and update functions associated with these sprite objects. So up here, I'm going to determine where do I want to render out our explosions relative to our other objects. I think it makes sense to render these out right after our enemies. That way our enemies do not cover these explosions. So right here, I'll begin looping from the back of our explosions array. If I want to loop from the back of something, well, I know I'm already doing that up above with our enemies, using this for loop right here on line 67. I'm going to copy this very first line, paste it down below, and then close out that for loop. But instead of specifying that I'm looping through our enemies, I want to loop through our explosions array instead. So now we're looping from the back of our explosions array. We can select one specific explosion by declaring a const, grabbing one explosion equal to our explosions array, and passing through I as our index. So we're grabbing one individual explosion, and now that we have that explosion, we can call both draw and explosion.update. And we're calling these separately because we needed to divide up our update and draw functions within our sprite class to make sure all of our other sprites would render and update accordingly based on their needs. So we created the explosions array, we populated it, and now we're rendering it out. So when a projectile hits an enemy, we should see explosions on our screen. So let's save this, refresh, create a building, and see if we can see any explosions. So that hits, and yeah, you can definitely see these explosions are being rendered out. But we don't want these here forever. They're going to make our game less performant, and it just looks kind of silly for all these explosions to be scattered out throughout our map. So within this for loop, we can write an if statement that says if the current explosion we're looping over has a frames object with a current value, so the current frame of this explosion, if the value is greater than or equal to our explosion frames object max, so the max amount of frames, then we want to splice out this individual explosion from our explosions array. So I'll select our explosions array, and then say I want to splice out this one individual explosion by using the index of I, which we're getting from this for loop right here, and I want to splice out one explosion from this index. So now after our whole animation runs, we should be splicing out one explosion. It should not exist on our screen anymore. Let's save this, refresh, and see if that works. So, as you can see, this code is just not working. Why is that? Well, in order to debug this, we're going to need to console log out these two values right here. So let's console log out first, explosion frames current. I'll paste that on in, save, then open up our console by inspecting an element, hitting the console tab, and then refreshing, and let's see what this populates. So I need to create one explosion, and there it is. So at the very top, it looks like frames current is going from 0 to 1 to 2, and then resetting back to 0. Well, first, this should definitely be going up to 3. Why is it not going up to 3? Well, we're going to have to check out our rendering code within our actual sprite class. So let's head into our classes folder, go into sprite.js, and find out where we are resetting our frames current. So that's going to be down below within our update method. And yeah, right about here, this if statement actually resets this.framesCurrent back to 0. So I'm not really sure why I wrote this. It might have been a mistake on my part, but we do want to get rid of this -1 right here. because that's going to allow us to go one more frame into the future to make sure that we complete this whole sprite rendering. Right now, all of our current sprites are off by 1 because we're not rendering out that very last frame available within those sprite sheets. So let's make sure we're getting rid of -1, and that should fix the issue with us not looping through our entire sprite sheet. So that's already saved. I'll refresh, and then we'll create some new explosions. And that should go up to 3, so there it goes. That definitely fixed that. Now we're getting the full animation for our enemies, our explosions, and even our buildings, so great. But why is this still not splicing out? Well, our last frame is going to be an index of 3 over here. Let's go into index.js and analyze our if statement where we're actually splicing out an explosion. So we know our frames max is going to be equal to 4, but this is not an index value, therefore we don't start on 0 when we're referencing frames max. But this over here is indeed an index value. So what we can do is either subtract 1 from explosion.frames.max to make this index-like, or we can add on 1 to explosion.frames.current. I think it makes more sense to subtract 1 over here, so I'm going to do that. But now, if we save this, refresh, and then start creating some explosions, we're going to see those explosions disappear immediately as soon as they complete their full animation. That looks absolutely great. So the last thing I'm going to do here is prove to you that these are being removed by consolating out our explosions array. And we should really never see more than one explosion in here as long as we only have one building within our map. So let's create that explosion. There's our first one. And yeah, eventually it just goes back to its empty array status. We never have more than one sprite within this array at any time. So we know our explosions are being created correctly and they look really good in the process. So with this, we're going to be able to go to our to-do list and check off explosions. Now the very last thing we're going to do is launch this game so that we can share it live on the web. And we're going to do this for completely free using GitHub Pages. So how do we go about launching this game? Well, the first thing we need to do is make sure that we have a GitHub account created. So if I head on over to github.com, GitHub is essentially a platform that stores your code on the web so that you can grab it from anywhere in the world. We're going to be pushing our code up to GitHub, and as a result, it's going to host our game on a URL which anyone can visit as long as they have access to internet connection. So if you don't have an account, you want to make sure that you sign up for one by clicking this button right here. It's completely free. I already have one, so I'm going to sign in. And once you sign in, you're going to be greeted with a dashboard that looks something similar to this. Now what we want to do is create a repository. A repository is basically just a page that stores all of our game's code on the web. This can be private or it can be public. For our game, we're going to make it public because all this code is already publicly available. And if you want to host this for free using GitHub Pages, it needs to be public as well. But if you don't want your code visible to everyone on the web, well, you can go ahead and make your repo private. It just means no one can view it besides you. But if you do want to host your game using GitHub Pages using a private repo, you will need to pay something like $5 to $15 a month for it. So we're going to go over to New and create a new repository. So we don't need any template. You are going to be the owner. Don't need to change anything here. For repository name, we're going to call this something like tower-defense. That's really all we need to get started. Here you can see this is what I was talking about. You can make your repo either public or private. Since we want to launch this for free on GitHub Pages, we need to make sure that we're using public right here. But we don't really need to do anything else unless you really want to, such as include a README or choose a license. I'm going to skip all this. I'm just going to create my repository with our name and the public option selected. So I'll create that repository, and this page is going to act as a storage device for all of the code we just wrote. So you do need to know a little bit of command line in order to get this working, and I highly recommend checking out some sort of GitHub tutorial available out there on YouTube. There are tons and tons of them already, so I'm personally not going to do one. Just go ahead and look up a quick tutorial on how to push up to GitHub, and you'll be up and running in no time with this. But I'm going to show you as much as I can anyways. So we're going to create a new repository on the command line. I'm going to select everything that we see right here, and just copy that. And then I want to open up an app called Terminal. So Terminal actually looks something like this. It's either just a white or black screen that allows me to view my computer's contents but using a command line. So everything that I just listed out right here is a one-to-one representation of what we have over in something like Finder. I just listed out my home directory, which contains everything within Christopher Liss. This is my home directory over here. You can see what I have over here matches up with what we have within Terminal. So applications matches up with applications over here. We have documents, library, etc. But we use command line to run specific commands such as the ones GitHub give us so that we can push our code up to GitHub and then host it live on the web. Now I use a very specific terminal. I don't actually use the default that comes with Mac. I use something called Warp, which looks like this. This is something that you can download for free. I'm not sure if it's available for Windows, but I definitely know it's available for Mac. And this is what I pretty much always use because it's fast and also it looks good. If you're a Windows user, you want to use something called PowerShell, and can pretty much run all the same commands we're about to be running right here. So if you're using Mac, you can use either Terminal or Warp, and if you're using Windows, I definitely recommend using PowerShell or the Ubuntu Linux shell, in which they also have available if you know how to set that up. But basically what we want to do is change our directory, so CD, into the directory in which we're currently storing our game. So if you don't know how to navigate your terminal too well, this is how I recommend doing it for beginners. So I'm going to move this to the top left-hand corner, and I'm going to bring back our Finder. So this one-to-one representation of what we have in terminal over here. I want to make sure we're going into the folder where our game exists. So over in Finder, I'm going to go inside of Web, where I store my project, and I have a couple of these right now, but the one I've been using is going to be Tower Defense GitHub. I want to select this folder right here, and then after I've written cd space, I'm going to drag this folder onto the Warp terminal, and this will work also for the main Mac terminal, and I believe even PowerShell as well. But once we drag that on in, it's going to give us the exact URL in which we need to go to, so we can change our directory into our project of Tower Defense GitHub. With this here, if we hit return, we're going to be inside of that project, and I can hit ls to list out all of our project's files and folders. So you'll see we have index.html, our JS folder, our image folder, etc. But once we're inside of here, we should be able to paste in that command that we got from GitHub over here, and it should push all of our code directly up to GitHub. So personally, I've already been using Git for this because it's always good to track your progress as you go throughout something. So I'm going to get rid of my current Git instance by removing with recursive forest the folder of .git. You don't need to do this. This is just for me because I already had it running. But now you'll see that Git is not available within this project, so I can paste in all that code that I copied over from GitHub. If I just run all this, it's immediately going to push it up to GitHub for me. Now, if you haven't set up an SSH key with GitHub, it might require that you add in your username and password, and as long as you authenticate correctly, it's going to push up all your code. And if you're having trouble, definitely check out one of those GitHub videos available to you on YouTube. But once you push everything up and refresh over here, we're going to see that we made our first commit. So all we really did was create a README file using the command line and then push that up to GitHub. That is our first commit. That was the first piece of code that we really changed for this repo, but it's really not, because we already wrote all of our code. So if we want to add in our additional code, we can see that the code is definitely still there. We have an image folder, we have a JS folder, index.html. If we want to push the rest of this up, we need to run a few commands using our terminal. So we're going to run these git commands. The first one is going to be git add dot. And this stands for git add all. It means add everything that's currently within our Tower Defense directory. We'll run that, and then we can type git status to make sure that those are actually added into the GitHub staging area. I'll hit enter, and you'll see these are all the files that we're preparing to push up to GitHub. This is everything that we actually edited within our game. So great, this is exactly what we want to push up. But we can't push this up just yet because we need to create what is known as a git commit. A git commit is just a snapshot of your code at a particular point in time, and as you make commits for your code, you can jump between them in case you ever mess up. You can always go back and revert to a prior instance so that you're never losing your code along the way. You always have some sort of temporary instance which you can go back to. So to create that git commit, we can write git commit -m, which stands for message. And then we need 2 double quotation marks, and inside of this we can create a message that describes what code changes we just made. So here we just developed Tower Defense game. That's going to be my commit message. You can write whatever you want, but it's good to make this as descriptive as possible for whatever it is you just did. So I'll hit enter after that, and now we just created all these files directly within Git. And as long as everything was created correctly, now we can type git push, and it's going to push everything up automatically to the same Git repo in which we ran all those initial commands on. So if I click our code tab right here, you're going to see now we have all the files associated with our Tower Defense game. We have index.html, we have everything within our JS folder, we also have everything within our image folder. We can click on one of these and see all the images associated with our game. So this is great. Now we have a storage area which we can always come back to in case we mess up our code on our local machine. But we do want to host this live on the web. To host this live on the web, we're going to go over to the Settings tab. I'll click that. And then on the left-hand bar over here, you're going to see a tab for Pages. Let's click that as well. And now you can see right here, GitHub Pages is designed to host your personal, organizational, or project pages from a GitHub repository. We're going to host this specific GitHub repository so that it's live on the web. So in what GitHub branch does our game currently exist? Well, we can click this tab and then just select main because that is the default. We haven't done anything complex here. And now it's going to ask what is the root of our project within all of our code files. Well, that's also going to be the default, which is /root, because we know that is where index.html is currently saved. It's saved within the root of our project. So as long as we have a branch of main and index.html is stored within our project root, we can hit save, and it's automatically going to set up a URL which we can visit to view our game. So if I click this, we're going to be returned with a 404 error saying there isn't a GitHub Pages site here. Not yet. It is currently building in the background. So the first time you launch this, you can go over to the Actions tab. You'll see GitHub is building our site so that it can be viewable on the web at that URL. So it's currently building right here and also on deploy. But once this is done, we should be able to visit that URL. You'll see now it's finished. If we click that same URL, now our game is completely available, but on something anyone can visit no matter where they are, as long as they have connection to internet. So if we start playing our game, we can create a building. This works exactly as we coded it locally, which is really freaking cool. Now, if we ever want to make any updates to our game, we can simply go back to our code, start typing in some updates, update here. I'd save this, and then I would head back to terminal, do a git add all, and then I would run through the same process of doing a git commit message, and then a git push. And if you push that up, it's automatically going to be pushed up to GitHub, and it's going to automatically run the same commands that were just ran right here. As a result, your live site at this URL is also going to be updated automatically with those changes you just pushed up. So it's a really nice deployment method that GitHub provides so that you don't have to drag and drop anything using FTP. You can simply just push up your code and all of your changes will automatically be available on this live URL in which anyone can visit. So if you want to play this game, you can either visit this URL right here, and there will be another one available within the description related to the Chris Course's GitHub account. But otherwise, I think this is a great start for creating a tower defense game. So let's go ahead and admire the results. And if you would like to take this to the next level, eventually there will be a premium tutorial on this, in which I'll show you how to add in more buildings, more enemies, and more interactive features compared to what we have right now. But otherwise, I think this is a great start for creating a tower defense game. Thanks so much for watching, everyone. I hope you enjoyed, and I'll see you in the next one. Peace.